Testing sound. Testing sound. Testing sound. How many more to come? How many more to come? All set ചെയ്താൽ മതി. All right. All right. Oh. Right. Okay. Who else to come? Kau din ka? Oh, yan ko. Para ko na gawin, ito. Kawin no? Ano sa temetro? Diyan ka? Diyan ka itaw ka? Ano? All right, we'll start. හිර වෙලා ඉන්න එපා. ගොඩක් වෙලා ඉන්න ඕනේ. මේ සාමාන්‍ය ඉඩ අරගෙන කැමති විදිහට ඉන්න ඕනේ. නැත්තම් ගොඩක් වෙලා ඉන්න ඕන නිසා අමාරුයි. හිර වෙලා ඉන්න එපා. හදිස්සේ. ඈ? charger? පුළුවන්. මේ ඇඩැප්ටර් එක නෑ. මගේ මේ කේබල් එක විතරයි. හරි. Right, one more second. All right, we'll start. Some physical students are still yet to come. That's why we are waiting. 1 second. All right, we'll start. Right. Will you come in? No? Right. Good evening, all. We'll start. Right. Okay, so I hope my audio and video is clear for online students. I checked from my end, it's clear. What about you? All good, right? Online students? So if needed, you can come to front. Anyway, I don't mind. Can someone confirm in the chat? Am I loud and clear? From my end, it's fine. Yes, okay, good, clear. Right, good. Right, we'll start. Listen. Now, this is the plan today. This is actually the second practical seminar I'm conducting. The first one was mechanics practical seminar. And there are some new students also who were not there in the mechanics one. And there were some who were asking about the mechanics practical seminar. And in last few days, I personally know that there was some students who were going through the mechanics ones as well. And here also, still there are students who haven't have that much of a comfortability with mechanics practicals, right? That video is still there on YouTube. You can watch it in a free time. It will be, I think it's around 6.5 hours or 7 hours, something like that, right? මේ වගේ time period එකක තිබ්බ එකක්, right? Free time එකක් අරගෙන mechanics එකත් බලන්න. If you are not comfortable with mechanics practicals yet, right? This is the second one we are having from waves. And from my end, I'm going to conduct 3 more practical seminars regarding optics 1, and thermal, and for current electricity. Right, those 5 will be the main 5 practical seminars I'm planning to conduct for this year. And around like maybe 1 month before the exam, plan to conduct another practical seminar with the guest practicals. Right, now these are lesson based ones, right? So altogether my plan is to have 6 seminars for practicals, right? This is the second one. And the next coming 3 are from lesson based, and the last one will be with few guessings, right? Not all 38, some guessings in the last one, right? Okay then, and this is actually the first time I'm also conducting a night seminar. Last time it was a day one, right? So since this is a night seminar, sometimes you might feel sleepy sometimes, because this will go up to like 2:30, let's say 2 for now, right? Let's say 2 for now. Oh, time එක දාලා තිබ්බනේ. දැනගෙන ආවේ. හරි. දැවිලා ඉන්න waves practicals යන්න දෙන්නේ. නැත්නම් එන්නේ නැහැ. All right. Especially online students, since we are just in front of a screen. So make yourself comfortable. Have something close to you, like a bottle of water, snacks, something like that. And for physical ones, you have some chocolates and toffees here. You can have them if you feel sleepy. අවුලන්නේ හැක්ස් අනු මනන් ඇති එක එක වැඩි චොක්ලට්ස් එහෙමත් ඇති වල්ලා ෂෙයා කරගන්න කට්ටියත් එක්ක හරිද and you will be having 2 breaks right breaks දෙකක් plan කරලා තියෙන්නේ බලමු right 2 breaks first break will be around 9:30 10 okay and the second one will be around 12 to 12:30 ඒ වගේ breaks දෙකක් හම්බ වෙයි right and the physical ones you can't go out from the institute in during breaks right come that's all you can come to front row if needed then dead yeah එන්න එන්න එදෙන් දෙන්න එතකොට මට ફોකස් කරන්න ලේසි බලන්න ලේසි දෙකට නැත්නම් වෙන කවුරු හරි ගමන්නේ අදීශාරි කවුරු හරි මේ ගේම් ටීම් හින්දා කිව්වේ අවුල නැද හරි okay then listen for physical students you can't go out the institute during breaks right you can't go out the institute during breaks listen right so I hope you have already taken some meals මොන හරි තියෙනවනේ ගෙනල්ලා තියෙන්නේ ඊට පස්සේ කන්න කඩේට යන්න ඕනේ ඒ වගේ මොකද බඩගිනින්න තමයි වෙන්නේ මම එදා කිව්වා ගෙනල්ලා තියෙන්නේ අපිටත් එක කෑම ගෙනාවේ and listen for you the whole behind this one is arranged for dining එතකොට ඒකට ගිහලා කන්න පුළුවන් අනිත් ටික දන්නවනේ අන්තිම දන්නවනේ ඉතින් මේ ක්ලාස් එක නෑ නැත්තේ all right okay we'll start right listen so when it comes to waves practicals we have 6 practicals under waves right 6 practicals under waves now the plan today is we'll be starting from the first one from waves and by the end of the seminar you will learn all 6 practicals about waves right and stay awake and be vigilant in the class during the discussion because are you having schools tomorrow no supposed to start no 22nd 23rd another schools nah? I think for some of the students you have for some have Takshila yeah all right okay right මේ ස්කූල් සිබ්බත් මේ ටික හොඳට අහගන්න ඕනේ මේ ස්පෙෂලි දැන් ඔන්ලයින් අය පුළුවන් තරම් ඉන්න try කරන්න I mean try to stay until the end right දැන් නිදිමතයි නම් ඉතින් ගිහිල්ලා රෙකෝඩින් එක පස්සේ බලන්න but try to stay until the end in the live class and finish this off from today itself right එතකොට මෙතනින් පස්සේ ආයි waves practicals බලන්න තියාගන්න එපා ඉතින් එතනින් practicals ආයි ඉවරයි හරි okay and when I ask questions you all can engage answering right so I want to conduct this as an interactive one right and even if you are online you can engage with me putting your questions or anything to the chat right I can see the chat here all right we start and about the tute you can distribute this and the online ones listen online ones if you are in channels and groups you can get the tute from there I have sent a link there and if you are just on YouTube live go to the description in the description also the link is mentioned. You can go to that link and download it, right? So in the tube, that is just what you have in your guide. The purpose of giving this is to you to see what is given in the guide and what you actually should know about the practical, right? Otherwise, what I'm going to discuss is, I mean, there are more things to be discussed compared to what is given in practicals. All right. Okay, let's start with the first one. Let's start. Let's start with the first one. Right. All good, no? Right. Practical one. Practical one. Write down determination of determination of acceleration due to gravity. Acceleration due to gravity using simple pendulum. Using simple pendulum. Right. Okay, listen. What are your names, by the way? Names, new ones, newcomers, names. Dinu T. Hari, list එකේ තිබ්බා. මොනෙත් මා. Nesandu. Desandu. D. All right. Okay, listen. So first write down materials and apparatus. Materials and apparatus. Materials and apparatus. Listen. Right. So first material or the apparatus we need is pendulum. No, pendulum in the sense we have to have a string and a pendulum bob, right? First, don't write, just look at the board. You have to have a simple pendulum. Don't write, just look at the board. Simple pendulum and a small bob, right? Now when you say simple pendulum, there is no, I mean, not a must to say a bob separately, right? This just for your understanding, a small bob and a meter ruler, a stopwatch, and finally, have you heard about corks? What is a cork? C-O-R-K, cork. What is cork? Done on? Bottles වල තියෙන? දන්නවද? අර bottles වල මේ lid එක වෙනුවට එන එකක් තියෙන cork එක කියලා. Cork එකක් ඕනේ. Right? And this cork should be a cork. It should be cut at the middle, right? I'll explain the reason. A cork cut at the middle. At the middle. Right. This is what we are going to do. Don't write, just look at the board. So you all know what a simple pendulum is, right? So let's say now we have set up this apparatus using the string we have and the small bob, right? And this is a ceiling. Usually this is a ceiling. And when this is fixed to ceiling, we don't use any hooks. The reason is, once a string is fixed using a hook, once it swings, there's a possibility of slipping the string at the hook, no? Can you understand? මෙහෙම hook එකකට අපි string එකක් බැඳලා පස්සේ string එක මෙහෙම යනවානේ. When it swings, there's a possibility of slipping this fixed point. If it slips, oscillations changes. The oscillation is uniform, right? So therefore, we don't use any hooks. The mechanism here is this. That's why we have a cork, right? Cork क्या जानना? Corks जानना नहीं. What about online students? You all know corks, right? Bottles वला दिए. बोलो ना कौन थे करने वाले? एक bottles वला दिए ना. भैया मैं के टेबल लग गया दिन को मैं टेबल लग गया नो name, school, batch, phone number. කියලා පොඩි ටේබල් එකක් ගන්න ඊට පස්සේ කට්ටියට ඔක පාස් කරන්න. right? මේ ඔයගොල්ලෝ ක්ලාස් එක කට් වුණොත් ඒක ලියන්න. with a number. right? listen. hey. මොකද කේසේ? හරි ඔක හැමෝටම දෙන්න. ඒකද? නැද්ද? මේ I had only one cup මේ මම මේගොල්ලන් අහගත්තේ මේ තව කප්ස් තියෙනවා නම් ඕක දාලා ෂෙයා කරන්න උතන කොහොමද පේනවද චොක්ලට්ස් එකක් තියෙනවා. right? listen. මේ කෝක් එක යූස් කරන්න මේකයි. Cork is something like this. Cork කියලා කියන්නේ මෙන්න මෙහෙම එකක්. දැකලා නැති අයට මේ බලන්න. Corks දැකලා නැත්තම්. Bottles දැකලා තියෙනවනේ. මෙන්න මෙහෙම එකක් bottle එකේ උඩ ගහලා එනවා දැකලා තියෙනවද? Something like this. Right? That is called the cork. Right? සිංහලෙන් කියන්නේ කිරලැව කියලා. Right? ඒක because that is made of kirala. Right? කිරල කියලා පොඩි ගහක් තියෙන දන්නවනේ. අන්න ඒකෙන් තමයි හදන්නේ. මේ කිරල කියලා රින්ග් එකකුත් තියෙන අන්න ඒකේ ගහ. right? මේක කියන්නේ කිරලැව කියලා that is called corks. මේකක් ගන්නවා. and you have to cut it at the middle. right? You have to cut it at the middle. and what we are doing is this string is passed through the cork like this. This is the cork now. The cut cork. The string is passed through the cork. Once it passes through the cork, a small cut. This is a small cut. දැන් මෙහෙම එතකොට halves දෙකක් තියෙනවනේ. මේක මැද්දෙන් string එක දානවා. Like this. At the moment. You can imagine, right? Now the cork is cut into two pieces and the string is put at the middle of the cork like this. එතකොට දැන් cork එක ඊට පස්සේ මෙහෙමයි තියන්න පුළුවන් ඒක දාලා. The purpose is now this fixed point is actually a fixed point, no slipping, because a small cut is only a small cut has to go the string. පොඩි string එකක් නේ දාන්න තියෙන්නේ. string එක දාන්න විතරක් cut එකක් දාගෙන තියෙන්නේ. ඒතර hook එකක් use කරන්න බෑනේ. දැන් hook එක මෙතන තිබ්බට අවුලක් නැහැ. right? ඒතර මෙතනනේ fixed point එක. That's the purpose of using a cork, a cut cork. right? All right. And this is the bob. Pendulum bob. And the next thing is, I didn't mention here, we have to have a locating pin. A locating pin, or we can say a reference pin. Listen, a locating pin or a reference pin. The purpose is, it's kind of a needle. Reference pin or the locating pin. Right? The reason is, now we are going to count oscillations here. You are going to count oscillations, number of oscillations. So therefore, you have to have a fixed point to count it when passing. No? That fixed point is called the locating pin. Right? And we place the locating pin. There are two possible places actually. There are two possible locations that we can do. Right? Either at the lowest point of the path. There is one possible way, or can be placed at here. Right? Now for the diagram, I will draw it here. And in the latter part, I'll explain the difference between placing this here and here. Right? දෙකම කරන්න පුළුවන්. බැරි නෑ දෙකම කරන්න පුළුවන්. There are differences. Right? All right. One more second. Right. Now, what we are going to do here is something like this. So we know we have already proved one equation for period of a simple pendulum in simple harmonic motion. Right? That is a proved equation. But that is only valid for simple harmonic motion. To be this motion simple harmonic, it is valid only for small angles, small oscillations. right? Otherwise, it is going to be a circular motion, right? So therefore, we have to make sure that you are going to swing this, oscillate this in small angles, as values, right? This should be less than 6 degrees, like 5 to 6, less than 6 maximum, less than 6 degrees maximum, right? And we know period of a simple pendulum in simple harmonic motion is, what's the equation? That's a known equation. T equals 2 pi root L over G, no? Right? And what is L here? And what is G here? L. L is very special here. What is L here? Huh? Length of? No, not length of string. What is L here? Class එක කියලා දෙනවා හොඳට. And discussions වලත් කියලා දෙනවා. මේ week එකේ තිබ්බ paper එකෙත් මේකෙන් ගානක් තිබ්බා. Huh? What is L? What is L? Length from attached point to or fixed point to center of gravity of the bob. Not the string, center of gravity of the bob. Right? So very important. Otherwise, this is not the length. This is not the length. Right? It should be measured from here to the center of gravity. Right? Usually we are using a spherical bob. So it should be the center of the bob. Right? This is the length from fixed point to attached point to center of gravity of bob. Center of gravity of bob. And what is G? G is also not gravitational acceleration. It is gravitational acceleration if and only if the system is at rest. If not, that is about resultant acceleration. Right? Questions, kara. Otherwise, there is resultant acceleration. Right? If the pendulum was fixed inside an elevator, moving elevator, or a moving bus, moving car, something like that, resultant acceleration comes. Right? So therefore, even though we are writing G here, G is if and only if this ceiling is at rest. This system is at rest. If the system moves as a whole, it changes. Right? So therefore, this is actually resultant acceleration. And that is gravitational acceleration if the system is at rest. Right? Now here our system is at rest, no? This fixed was ceiling. Right? Ceiling omega stand එක ඕන fix කරන්න පුළුවන්. Fixed stand එක දාන්නත් පුළුවන්. ප්‍රශ්න නැහැ. Right? So therefore, for our thing, we will be using G. But you have to know that G is not gravitational acceleration, that is resultant acceleration. Right? So wherever it is applicable, you have to use the resultant acceleration. Right? Okay, ගණන් තියෙනවා. කරලා තියෙනවා. මම ක්ලාස් එක කරා. All right. Now, what we are going to do is something like this. We are going to determine acceleration due to gravity, which means G. Now, since T equals 2 pi root L over G, T squared equals 4 pi squared L over G, no? Right? Now, from these variables, what we can change here is, what we call that variable that we are changing? What's the name? Changing variable. Independent or dependent? Independent. Right? X. So therefore, only possible variable to change here by ourselves is L. Time එක change කරන්න බෑනේ. If L changes, only time changes. Right? ඔක්කොම වලින් time එක change කරලා length එක change වෙන්නේ නැහැනේ. Right? So therefore, only possible variable to change here manually is L. That is what we are going to do. So therefore, we are going to change L. And when L changes, accordingly, T changes, no? Because 4 pi squared is a constant, G is a constant. When L changes, accordingly, T squared changes. Right? So therefore, when L is the independent variable, T squared becomes the dependent variable. Right? Considering that, we can rearrange the equation actually, like this to plot a graph. Now, if we plot a graph between these two, considering whole T squared as Y and L as X, right? Whatever it is as a product with X is M, right? we should get a y equals mx curve, t squared and L. We should get a y equals mx curve, right? A straight line goes through origin, and gradient of that gives 4 phi squared over g. No? If gradient of this graph is, see, if gradient, say m of the graph is, these are numerical value. No? Once the graph is drawn, it is 4 phi squared over g. Now our target is determining g. Our target is determining g, right? If gradient is known, m equals 4 phi squared over g, 4 phi squared over g. So g is given by 4 phi squared over m, right? G is given by 4 phi squared over m, right? Which means our target is this. After conducting the experiment, listen, after conducting the experiment, our target is we are going to have 6 pairs of values for L and T squared, right? Once we have minimum 6 pairs of values for L and T squared, you can plot the graph. Once the graph is plotted, you can determine the gradient using the graph. If the graph is there, we know gradient is tan here. If the graph is there, so using the graph, you can determine gradient. From the graph, gradient is a numerical value. From the equation, gradient is 4 phi squared over g. Equate those two, and g is 4 phi squared over m, right? So that's basically what we are going to do, right? Is it clear? Clear? Right. Now write down materials and apparatus. So here basically I have explained everything. There are more things. I mean, basically this is what we are trying to do. We are going to do in this experiment. මේක කොලම් එක දාන්න මේක අහන්න මේක හෙඩ් එකකට දාපන් මම හතරක් කිව්වේ නැද්ද හතරක් කිව්වේ නේ කොලම් හතරක් ඕනේ කියලා මම කිව්වේ නේ මම කිව්වා හතරක් ඕනේ කියලා ඔය සෙට් එකෙන් අහලා වැඩක් නැහැ වෙන කායෙන් හරි මම කොලම් හතරක් ඕනේ කියලා කිව්වේ නේ හතරක් ඕනේ හතරක් ඕනේ name මොනවද මම කිව්වේ school batch phone number නෑ write down materials and apparatus write down one by one materials and apparatus write down one by one first a simple pendulum write down a simple pendulum a simple pendulum a simple pendulum oscillating length okay a simple pendulum a small bob within brackets metallic there are reasons we'll explain in the latter part why we need to stick to a metallic one rather than using a wooden or something else, right? There are reasons so in physics for anything there's a justification, no? For here so that's there a small bob metallic is preferred, no? Metallic. Then a meter ruler. Why we need a meter ruler? Why do we need a meter ruler? Now we are going to change length. Then we should be able to measure the length of the string, right? From here to the center of the bob. A meter ruler is needed, right? A meter ruler. Then a stopwatch. Why a stopwatch? We need to measure t square, periodic time, right? We have to measure t. Once t is measured only, you can find t square, right? A stopwatch. Next one, you better write this with a red pen. This one, cork cut at the middle. Cork cut vertically at the middle. A small cut, just to penetrate this string, just to put the string, that's it, right? A cork cut vertically at the middle, a cork cut vertically at the middle, a cork cut vertically at the middle, a cork cut vertically at the middle. Last one, locating pin, locating pin, a locating pin, a locating pin, a locating pin, right? Okay, then take this down as the theory. Oh, wait. So before the theory, you have to draw this here, materials and apparatus. Draw the apparatus, only the apparatus, only the apparatus, this part. Draw this, and this is the locating pin, and label these ones. Draw the diagram only, right? Locating pin, bob, this is the string, cork, right? Take it down. And let me mark L here. You also have to mark this L to the center point, up to the center. That is very important. Take down the apparatus. Adisa, පොඩි වීඩියෝ ක්ලිප්ස් ටිකක් කරන්න ඕනේ. එදා ලස්සනට අරන් තිබ්බේ ඒ වගේ එදා අදීශ ලස්සනයක් කරන් තිබ්බා මම අර දාලා තිබ්බේ. මේ නෑ කීපයක් ගන්න වෙයි මේ එකම ඇන්ගල් එක තිබ්බට පස්සේ එඩිට් කරද්දී මේ ඒතර එකම ඇන්ගල් එකනේ ඇන්ගල්ස් කීපයකින් ගමු. මේ වාගේ ෆෝන් එකෙන්ම ගන්න ඒකේ සෑහෙන්න වෙනසක් තියෙනවා 13 එකත් එක්ක 13. ඒ කියන්නේ මේ ඒක රෝ නෙමෙයි. මගේ එකේ රෝ ෆෝමැට් එකක් තියෙන්නේ. ඒ වුණාට අරක ලේසි. just randoms අර එදා වගේ එහෙම මොකුත් නෑ randoms ඔය ටික කොහොමද less than 1 minute මේකක් නේ යන්නේ හැදෙන්නේ පොඩි ඒවා ටිකක් තිබ්බ නෑ charge වුණාට පස්සේ අය 9:20 බස් එක යනද නෑ මේ ආයි මං පස්සේ ඕනේ දෙන්නම් මට පොඩි clips දෙක තුනක් ඔය පැත්තට තරම් දෙන්න angles පොඩ්ඩක් වෙනස් වෙන clips එක right Sorry, I was muted. Now fine. Sorry, I was muted. Right. Take down this as a theory. Write down the equation. T equals 2 pi root L over G. And L is length from attached point to center of gravity of bob. This is very important. To the center of gravity. To the center of gravity of bob. And G resultant acceleration. G resultant acceleration. Right? 1, 2, 3, 4 gila Pascal. Resultant acceleration. Right? Resultant acceleration within brackets. Gravitational acceleration within brackets, gravitational acceleration is applicable. Gravitational acceleration is applicable only if gravitational acceleration is applicable only if the system is at rest. Gravitational acceleration is applicable only if the system is at rest. Gravitational acceleration is applicable only if the system is at rest. Right? Okay. Then write down. Now the equation is done. Here, somewhere here, put a point and write down. Right? Put a point and write down. If oscillating length, write down. If oscillating length is simple L and period of oscillation is capital T and period of oscillation is capital T. Put a comma and write down the equation again. T equals 2 pi root L over G. Write down the equation again. T equals 2 pi root L over G. And then consider square of both sides and write all lines up to here. Y equals mx. Up to here, y equals mx. Right? And now plot the expected variation between t squared and L. We are going to consider t squared as y, L as x. Then it is going to be a y equals mx variation. That is a straight line which goes through origin. Right? And mention these things. Gradient equals this. So G is 4 pi squared over M. M is gradient here. I have introduced it here. Not a mass. That's a gradient. Gradient here. Finished? Write down below with an asterisk mark. Write down below. Write down. Since gradient of graph is known, since gradient of graph within bracket simple m is known, since gradient of graph, since gradient of graph within brackets simple m is known, since gradient of graph within brackets simple m is known, there simple m is known, g can be determined, g can be determined, g can be determined, g can be determined, g can be determined. Right. Okay. Now let's see all the steps that we are performing from the beginning. Right. So put a subheading as method. Put a subheading as method. 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 Right. First point. First point. Write down. Put the string of. Put the string of. Put the string of. Put the string of simple pendulum. Put the string of simple pendulum through the cut of cork. Through the cut in cork. Through the cut in cork. Through the cut in cork. And suspend it. And suspend it. On a ceiling or supporter. On a ceiling or supporter. And suspend it on a ceiling. On a ceiling or supporter. On a ceiling or supporter. Second point. Write these ones in point form. In point form. Second point. Second point. Measure the distance from. Measure the distance from attach point to center of the spherical bob. Attach point to center of the spherical bob. Attach point to center of the spherical bob. Right. Next point. Next point. Keep the locating pin. Keep the locating pin. Keep the locating pin close to. Keep the locating pin close to the lowest point of path of simple pendulum. Close to the closest point, lowest point. Keep the locating pin close to the lowest point. Keep the locating pin close to the lowest point of path of simple pendulum. Next point. Swing the bob. Swing the bob with a small angle. Swing the bob with a small angle. With a small angle. Swing the bob with a small angle. Within brackets. Within brackets. Less than 6 degrees. Right? Maximum 6. 5 වගේ පුළුවන් නම් තව හොඳයි. Right? 5 වගේ පුළුවන් නම් තව හොඳයි. The constraint is this. Listen. Constraint is this. Once the angle is decreased, the time it takes for one oscillation, what happens? If the angle is small, right? So therefore, we have to count more number of oscillations if the angle is too small. And since there's a damping here, there are two constraints. Make a damp phenomenon, right? The amplitude decreases over time because we are doing this in reality with the air drag, right? So මේක එකපාරක් oscillate කරා කියලා හැමදාම වෙවි දෙන්නේ නැහැ. It is not going to swing forever, right? It is going to damp the oscillation. So if there is a small angle, it is going to damp quickly, right? So therefore, maximum we can go up to 6 degrees, not more than that, right? 5 to 6 okay, mainly maximum 6. Within brackets, less than 6 degrees. Right. Next point. Listen. Now, listen, before the next point, you are not going to measure the time for a single oscillation, right? For a single oscillation. The reason is this. Usually, what we have in our labs as stopwatches are the stopwatches with least count. What's the least count of the usual stopwatch we have in the, typical one we have in the lab? 1 millisecond, right? 1 millisecond නෙමෙයි usual එක. 1 millisecond එක තියෙනවා. 1 millisecond එක නෙමෙයි usual එක. ගොඩක් schools වල. 0.1 seconds. Right? 0.1 seconds එක තමයි, the popular one. The popular and typical one is this. This is a typical one. Right? 1 millisecond තියෙනවා. The typical one, if you have the manual one, digital එකේ normal, right? The manual stopwatch එක තියෙන ඒවා තියෙනවා නම් තාම එහෙම use කරන කට්ටිය ඉන්නවනේ තාම. ඒ කියන්නේ තාම schools වල තියෙනවා. මම හිතන්නේ ඕනි ස්කෝල එකේ තියෙනවා. දෙකම ඇති. manual and digital දෙකම තියෙනවා තාම. දන්නේ නැහැ ලැබ් එකට ගිහින් නැහැ. manual එකේ කට්ට දුවන එකක් තියෙන්නේ. gauge එකක් දුවන එකක් තියෙන්නේ. කට්ටක් යන්නේ. අන්න ඒකේ point one තමයි ගොඩක් වෙලාවට තියෙන්නේ. Right? So therefore, in a typical one, listen. In the typical one, there is 0.1 seconds. So therefore, you have to have a reading which doesn't exceed our maximum percentage error. What is the maximum percentage error allowed in our experiments? That I have explained before. 1%, only 1%, right? So therefore, you can do a calculation, a reverse calculation, and come up with the minimum number of oscillations we need to get the error which is less than, it should be less than 1%. Because if the error is less than 1%, now as an example, what is the equation of percentage error? Percentage error equals least count over reading into 100%. Percentage error, right? Now, maximum percentage error we are allowed to have is 1%, right? And let's say least count of the instrument to use is 0.1. 0.1. Reading එක බලමු. See, now reading is 10 seconds. Reading is going to be 10 seconds. So therefore, listen, you have to choose a possible number of, a required number of oscillations as to exceed 10 seconds. Then 10 වලට වඩා අඩු reading එකක් ගත්තොත් the error is going to increase, or panel board error is going to increase 1%. Right? So therefore, just to have 1%, the time duration, time interval you should take is 10 seconds. Right? Then you have to decide whether it's 20 oscillations or 25 oscillations or 50 oscillations based on the time it takes for one oscillation in your experiment, right? Generally, we say it's 25 because generally you are starting this length from 40. That's why you can 40 වලට length එක අරගෙන 6 කියන degrees, 6 degrees angle එකෙන් oscillate කරොත් සාමාන්‍යයෙන් 25 oscillations යන 14 seconds වගේ යනවා. So therefore it says 25 generally, right? But there's no rule to start from 40. So ආගේ bob එක වෙනසක් වෙන්න පුළුවන්. So therefore, the best option is we can't stick to 25 and we don't need to. You don't need to. 25 like a rule එකක් නෙමෙයිනේ. You don't need to. Right? මේක තමයි මේකේ තියෙන argument එක. There is a logic behind this. Our percentage error should be less than 1%. So therefore, the reading you are going to take from the stopwatch should be greater than 10 seconds. It should be greater than 10 seconds. To have 10 seconds, you can decide whether you are going to count 20 oscillations or 25 or 30 or 35, whatever it is, as to have a reading which is greater than 10 seconds. Is that clear? හරිනේ? તો මේක පාඩම් කරගන්න ඕන එකක් නෙමෙයි. මේක ලොජිකල්. මේක ලොජික් එකක් තියෙනවා. එහෙම තමයි මේක ඩිසයිඩ් කරන්නේ. නැතුව හැමෝගෙම බොබ් එක මේ 25 වලට යන්න එහෙම සෙට් වෙන්නේ නැහැ මොකද? එහෙම වෙන්නේ නැහැ. Generally, that's a general value. Right? මේක තමයි මේකේ behind තියෙන්නේ. All right, next point. Now write down the next point. Next point. Decide number of oscillations to count. Decide number of oscillations to count. Decide number of oscillations to count. Decide number of oscillations to count as not to exceed percentage error. Sorry, not to exceed 1%. Not to exceed 1% by the percentage error. As not to exceed 1% by the percentage error. And show this example calculation here. Show this example calculation. And now this changes if your stopwatch is having a least count which is different from this. If my stopwatch has a least count of 0.1 seconds, right? ඊට වඩා අඩු එකක් තියෙන watch එකක් නම් ඒකට respectively වගේ value එක වල හොයා ගන්න පුළුවන්. That's why මේ කියන්නේ. නැත්නම් දැන් guide එකේ දාලා තියෙන 25 oscillations කියලා ගෙලින්ම දාලා තියෙනවනේ 25 හරි 20 හරි කියලා. ඔක බලන්න. 25. Right? 25 කියලා දාලා තියෙනවනේ. ඒක general value එකක්. Not a rule. Right? මේක තමයි logic එක. And for that above point, within brackets, write down for that above point, within brackets mention generally 25 oscillations are considered. Generally 25 oscillations are considered. Generally 25 oscillations are considered. Right? Next point. We are still under the method. Next point. Measure time. It takes for 25 oscillations. දැන් ඔය general value එක මම ඉතින් ඊට mention කරන්නේ. මම logic එක කිව්වනේ. Measure the time it takes for 25 oscillations. Within brackets write down usually 2 time readings are taken. Usually 2 time readings are taken and average is considered. Usually 2 time readings are taken and the average is considered. Usually 2 time readings are taken and the average is considered. 2 time readings are taken and the average is considered. Right? That is something we do for more accuracy. Right? Readings දෙකක් අරගෙන average කරනකොට the error is less, no? Right? Personal error, human error. Personal means human error. Right? පොඩි හරි දැන් මෙයා pass වෙද්දී අපි count එක ගන්නවා. Right? We are taking the count when it passes the locating pin like this. Right? හරි පොඩි හරි delay එකක් වුණොත් it will be average. ඒක අර mean value එකක් වෙලා යනවනේ average වෙලා යනවනේ when you consider the average. So that's why only 2 are considered. If you can consider more than 2 readings for a given length and take the average, accuracy of the experiment can be increased. 3ක් අරගෙන 3 average එක ගත්තොත් තව accuracy වැඩි. ඒක තේරෙනවද? 4ක් අරගෙන ගත්තොත් ඊට වඩා වැඩි. Right. Next point. Repeat the experiment. Repeat the experiment for minimum 6 different values of length, for different 6 minimum values of length and record obtain readings in the following table. Obtain readings in the following table. Right. See? So this is the data table. This is the data table. Look at here. This is L. We measure L in centimeters, right? And this is T. We measure T in seconds. We measure T in seconds. And we have to take two readings now, right? This is the reading 1 of time, reading 2 of time, and reading 1 and 2, and final T, this is the average, and one more column for T squared. This is in seconds, and T squared is in a squared, right? And you have to have 6 readings minimum, right? So this is the data table. 6 readings minimum. අවුලනේ නිකමයි. ඔය උඹට නම් ඉතින් දාලා නේද? මේ ගිය සතියේ මොකද ශෝක සතිය? ඇඬුවා. ඇඬුවේ? මේ හෙට බනද නෑ? යනවා. හරි. හරි හරි. Take this down. Take this down. මම මෙතන values දාන්නම්. Usually we are starting from 40 and increasing the length. Listen. Usually we are starting from 40, right? Usually starting from 40 and increasing the length 10 by 10, right? 10 centimeters by 10 centimeters. එතකොට මෙහෙම readings එකක් එන්නේ 40, 50, 60, 70, 80, 90. Right? Then corresponding times are here, right? For a given length, you are taking 2 readings, right? 2 readings for a given length and get the average here. This T here is the average. I mentioned the average here. This is the average. I mention කරනවා. T average periodic time. Average periodic time. Average periodic time. Average periodic time. Alright. Take it down. 17 නැද්ද? එහෙනම් මේ පොඩ පිටිපස්සෙන් ගන්න. 80. මට different angles එකක් ඕනේ. අරගෙන ආයි විහංග වගේ විහංග හරි මෙහා හරි වගේ දැන් කොහොමද වීඩියෝ එකේ? Right. Finished? හරිද? I need randoms, huh? අද හරිද? Finished? මේක mention කරන්න. T is average periodic time because you have 2 readings here, right? Reading 1, reading 2, something like this. Reading 1, reading 2, and the average here. Average is R1 plus R2 over 2, something like this. And the square value of that. Squared value of that. හරිනේ වැඩේ තේරෙනවද? Yeah, yeah. No. In a free time. Hurry. And write down. Next point. Next point. Method again. We are still under the method. Plot t squared against L. Next point. Plot t squared. Plot t squared against L. Plot t squared against L. Plot t squared against L. Last point. Last point. Calculate gradient of graph. Calculate gradient of graph. Calculate gradient of graph. And determine G as discussed under theory. 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 Right? Under theory again, mega. Using this. If gradient is known, G is given by 4 phi squared over M. Right? Phi is a known value. 2207. Right? Not 3.14. 3.14 daan naha me wage wada. What's the reason? That is not an ending decimal. That's the thing. Right? 3.14 නෙමෙයිනේ. Haven't you seen a video of Dr. Pantaleon? He is finding it up to 1000 decimals. ඒ වීඩියෝ බලලා තියෙන කවුරු ඉන්නවද? කම්බයින් මැත්ස් කරන සේනික ඉන්නේ Pantaleon කියලා. දන්නේ? පස්සේ බලන්න. එයා වෙනම ලෙවල් එකක ඒ කියන්නේ එයාගේ math skills මාර ලෙවල් එකක තියෙන්නේ. ඉතින් හොයන්නේ. for up to 1000 decimals. බලන්න නැත්තම් බලන්න. right? දන්න? දන්න? කවුරුද දන්නේ නැද්ද? කවුරුද දන්නේ නැහැ? right. මේ තාම ක්ලාස් එකක් කරනවා එයා. ඇත්තට? ඒ කියන්නේ 1000 ගිහිල්ලා there's no any pattern up until 1000 decimals in 5. මේ 5 කියන්නේ මාර වැලියු එකක්. කියන්නේ සමහර ඒ වගේ අර වැලියු සෙට් එකක් ඇවිල්ලා ඒ සෙට් එක රිපීට් වෙනවා. ඔය නම්බර්ස් ගහද්දි තේරෙයි. නිකන් මම නිකන් නම්බර් එකක් කියන්නම්. 1/29 කියන්නකො. 1/29 කැල්ලයක් ගැව්වොත් ඩෙසිමල්ස් 28ක් විතර ගිහිල්ලා ඕක රිපීට් වෙනවා. ඒ කියන්නේ මේ 28 ආපු එකම තමයි ඊළඟ 28 එන්නේ. ඒකම ඊළඟ 28 එන්නේ. එහෙම ඒක රිපීට් වෙනවා. හැබැයි 5 ගේ එහෙම කිසිම පැටර්න් එකක් නැහැ. ඒක මාර නම්බර් එකක්. right කොහොම හරි. so therefore we don't apply මම දැන් කියන්න ගත්ත එක මේකේ පොයින්ට් එක we don't apply 3.14. 14 නෙමෙයිනේ ඒක. ඒක තව යනවා. but if you apply 22/7 we are safe because that is considered. so right through decimals එක තියෙනවනේ it is inside 22/7 no. right? 22/7 දැම්මා 4 5 squared over m gives gradient. gives gradient නෙවෙයි g. gives g. right over gradient. මේ තියෙන gradient එක. right? is it clear? Any questions? So that's all about the experiment. Right? There are few more important things to be discussed. So before that, any questions about the experiment? Any questions about the experiment? Online? Any questions? All good? Dinu kane? This one. Adi. What is Dinuti. Onetma. Huh? Onetmi. අනිත් අය නම් දන්න කට්ටියනේ මේ. ලවඩි ගේම් වල මතක හිටිනවා. Any questions? Online students? Okay. Any questions? Any questions? Okay. Any questions? All good? All good? Online? No. Clear? Right. Okay then. Now, the next thing is other important things about this important things. මේ ටික ගයිඩ් එකේ කොහොමත් නැහැ මොකද? listen. මේ මම දැන් එක්ස්ප්ලেইন කරපු ටිකත් ගයිඩ් එකේ මෙච්චර හොඳට නැහැ. දන්නවනේ. ඔක බලද්දි තේරෙයි. මේ මම listen. So once we finish discussing the experiment, the whole thing, you can go through what is given in the guide. එතකොට ඒක හොඳට තේරෙයි. මේක දන්නවා නම් ඒක ඇති දෙයක් නෑ. right? අපි බලමු මාත් go through කරලා බලන්න. මේ explain කරලා පස්සේ නිකන් බලන්න මොනවද ඒකේ තියෙන්නේ කියලා. right? ඔය තියෙන guide එකේ තියෙන ටික. right? And දැන් කියන්න හදන්නේ these are the important things to be considered when conducting the experiment. Right? Put as remarks. And write down one by one. Remarks. First point, write down one by one. First point, following conditions should be satisfied. 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 First point, following conditions should be satisfied for the validity of equation. For the validity of equation, this t equals 2 pi root L over G. For the validity of equation, t equals 2 pi root L over G. Right? Under that main point, right? First bullet point. මේ conditions තුන කියන්නේ. Conditions තුනක් තියෙනවා. මේ conditions තුන කියන්නේ. First one, only for small angles. Only for small angles. මම කලිනුත් mention කරා. මේ ආයි mention කරන්නේ මෙතන remarks ටික තමයි. These are the most important things you need to know about the experiment to conduct the experiment without errors. Right? දැන් කරාට පස්සේ G වලට 60ක් විතර එනවා. අවුල්නේ. එහෙම වෙනවා ඉතින්. සමහරුන් දන්නේ නැතුව කරනවා. දන්නේ නැතුව කියන්නේ නිකන් අර oscillations හරියට ගන්න නැතුව එක ප්‍රශ්න ඉතින්. දැන් මෙතන මේ ටික කිව්වට පස්සේ තේරෙයි මොනවද වෙන්න පුළුවන් mistakes කියලා. ඉතින් මේ mistakes කරොත් you can end up having an impossible value for G. Should be something around 10, right? When you are finding 9.81, it is fine if you got 9.5 or 9.3, something like that. Like apart around 25, 30, okay, value impossible to have. Mistake, right? First one, only for small angles. Second bullet point. Air resistance on bob. Air resistance on bob should be negligible. Air resistance on bob should be negligible. Next one. Bob should not be rotated or rotating alien. Bob should not be rotating. Bob should not be rotating. Bob should not be rotating. Right? Rotating කියලා කියන්නේ this is fixed to a string no. තර දැන් වා මේක swing කරද්දි oscillations කරද්දි මෙහෙම වෙවි bob එක යන්න බෑ. bob එක rotate වෙන්න පුළුවන් නේ with the string. අපි කියන්නේ තන්තු මේ ඇම්බර් වෙනවා කියලා. ඇම්බර් වෙන්න පුළුවන්. ඒක rotate වුණොත් තමයි අරක ඇම්බර් වෙනවා. එතකොට තව කතාවක්. එතකොට elastic potential energy එකකුත් ඔගේ මේ deposit මේ store වෙනවා. ඊට පස්සේ මේක කොහොමද එතකොට valid නෑ. right? එතකොට bob should not be rotating. කරකවන නම් මම මොකුත් බෑ. අපි නිකන් මේක මෙහෙම උඩට කරලා අතරින් එක විතරයි කරන්නේ. right? You can take it somewhere here. And you are going to release. Right? එතකොට මෙහෙම ගහන්නේ එහෙම නෑ ඔය. මේ shape එක මෙහෙම පොඩි angle එකකට අරගෙන අතාරින්න. Right? Okay, next point. එතකොට මේ වගේ next main point, second point. A string is not fixed to a hook at the top. string is not fixed to a hook at the top. ඔකට ලියුවා? හරිද? කොහේ හරි. String is not fixed to a hook at the top. String is not fixed to a hook at the top. Because it can slip at the hook. It can slip at the hook. It can slip at the hook. It can slip slip at the hook when oscillating. It can slip at the hook when oscillating. For the same point, therefore, a cork with a vertical cut is used. Therefore, a cork with a vertical cut. A cork with a vertical cut is used. Therefore, a cork with a vertical cut is used. Next point. Period is not taken. Next point. Period is not taken only for one oscillation. 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 What's the reason? Percentage error will go beyond 1%, right? Like oscillation එක අරගත්තොත් එම, right? ලොකු percentage එකක් එනවා. 10%, 12% වගේ percentage එකක් එනවා. එකකට ගත්තොත්, right? So that's why එකක් අරගෙන කොහොමවත් වැඩක් නැහැ. 20, 25, 30, 50 වගේ වෙන්නත් පුළුවන්, right? General value එක 25. Within brackets. A suitable number of oscillations should be considered. A suitable number of oscillations should be considered. A suitable number of oscillations should be considered. A suitable number of oscillations should be considered as to maintain percentage error below 1%. As to maintain percentage error below 1%. As to maintain percentage error below 1%. Right? For the same one, generally 25 oscillations. For the same point, generally 25 oscillations. Generally 25 oscillations. Next point. Angle of oscillation should be less than 6 degrees. Right? Next point. As the point write down, fixing locating pin. Fixing locating pin. Right. See. Now this is a magnified view of the bob. Right? A magnified view of the bob. Say A, B, C, D, E. We have some points like this. Right? Then ප්‍රශ්න වලට එද්දි මේ වගේ වහන ඕනේ. එහෙම තමයි. right? ප්‍රශ්න වල අහනවා why it is not suitable to fix locating pin at E. එහෙම අහනවා. එතකොට ඉතින් ඔයා හරියට answer දෙන්න. right? නැත්නම් ඔය අනිත් පැත්ත. why it is suitable to fix it at the lowest point of the path. right? There should be a reason, no? So there are reasons. Right? So let's see one by one. If you consider a point like 1 නෙමෙයි A. If you consider a point like A, right? If you consider a point like A, what happens is now when this oscillates like this, it damps over time. No? When it damps, it won't reach point A over time. It damps. මුලින්ම A වලට it damps, no? Damping කියන එක දන්නවනේ. Amplitude decreases over time. Amplitude decreases. ඊට පස්සේ මේක A වලට එන්නේ නැහැ. right? එතකොට ඉතින් මෙතනට count කරන්න බෑ. So therefore a point like A is not suitable. right? The reason is මම මේ ටික reasons ඔක්කොම කියනවා. right? මේ එක එක points ඔයාගෙන් අහන්න පුළුවන් මොකද? එහෙම questions ඕන තරම් ඇවිල්ලා තියෙනවා. ඒක දැනගෙන ඉන්න ඕනේ. Suitable points මොනවාද? Not suitable points මොනවාද? With reasons. right? A is not suitable because when the oscillating damps over time, it won't reach point A. right? So 25 ගන්නකොට පළවෙනි පහේ විතර ඔන්න ඒ වලට එයි. පස්සේ එන්නේ නැහැ. එතකොට ඉතින් pin එක move කරන්න බෑ. right? What about a point like point B? point B එකට fix කරන්න මෙහෙමයි. නැද්ද මොකුත් swing කරන්න පුළුවන් එක? නෑ charger එක අපරාධනේ charger එක වගේ ගන්න නැහැ මොකද? නෑනේ. පොඩි charger එක. තියෙනවද? නෑ මොකද? කරේ කතාවක් කිව්වද? හරි. මොකුත් නෑ ඉමේජින් කරගන්න. මේ නෑ මේකේ මේ බොබ් එකක් නෑ. බොබ් එකක් තිබ්බනම් හරි. අර පොඩි ඇඩැප්ටර් එක නෑ. පොඩි ඇඩැප්ටර් එක නැද්ද? මගේ ලොගෝ එක තියෙන. හරි. එහෙම කියන්නකෝ. මොකද? type C ද? නෑ මේක lightning type C කියවලද? නෑ මේකද lightning තියෙන. මේ type C තියෙන. මේ ඒක හොඳයි. මුලින් දෙන්න තිබ්බේ. Okay, look at here. We got a bomb. හරි. දැන් මෙහෙම තියෙනවා. හරි. This is a pendulum we have. pendulum එක මෙහෙම දැන් යනවා. right? B locate කරනවා මෙහෙම. මේ බලන්න මේක damping එක. මේ. දැන් මම මේක මෙහෙම කරනවා අතින් හොඳේ. නැත්තම් damp වෙනවා. ඒ කියන්නේ මේක string එකක් නෙමෙයිනේ. This is a thick wire. එකක් ගාලා damp වෙනවා. නේ? It damps. එකක් ගාලා damp වෙනවා. 25 oscillations යන්නේ නැහැ මේක. right? So that's why we use a thin string. Remember? If you are locating pin at B, this is how we should place. මෙන්න මෙහෙම තියෙනවා. දැන් ඔයා බලන්න මේක දිහා ඉස්සරහින් ඉන්නේ. So you are doing the experiment, you are checking this from the front side. ඒතකොට මේක පේනවනේ ඔයාලට මේක pass කරන point එක. හරිනේ? මෙන්න මෙහෙම ගත්තා. This is point B. Point A කියන්නේ මේ වගේ. Point A. හරිනේ? මම points එක ඔක්කොම පෙන්නන්නම්. C කියන්නේ C වල තියන්න බෑ. It collides. C කියන්නේ මේ center point එක. C වල තියන්න බෑ. right? දැන් C වල ඔන්න මෙහෙම කෙනෙක්ට තියන්න පුළුවන්. Just behind this, then the thing is the locating pin is going to be covered by the bob. දැන් cover වෙනවා නම් පේන්නේ නැහැ. count එකක් ගන්න බෑ. That is not a fixed point. right? ඊට පස්සේ මෙතන තියන්න පුළුවන්. like this. like D. D වගේ. or E. E කියන්නේ මේ වගේ. right? Okay, now tell me, what about B? මේක හොඳ point එකක්ද හොඳ නැහැද? I mean, whether it's suitable or not suitable. B is a suitable point. B වල තමයි මම කලින් අර pin එක ඇන්දේ. right? B is a suitable point. And for a spherical bob, B is actually the most suitable point. හරියටම මේ point එක අපිට මේ point එකට වඩා easily බලන්න ලේසි. අයි මෙතන මේ y එකයි මේකයි දෙකම යන point එකක්නේ. So therefore when you are doing this practically, right? When you are doing this practically, checking point B is kind of easier compared to D, right? Both B and D are workable, right? They are fine, but B is more suitable. Right? That is the lowest point. lowest point of path තමයි මෙතන path එකේ lowest point එක. This also lowest point. මේ දෙකම හරි. C is not going to work because the bob is covering the locating pin. cover වෙනවා නම් වැඩක් නැහැ නේ. ඒතර පේන්නේ නැහැ නේ කොහොම. And E is also not suitable. The reason is even though E is at the line of the lowest point, E is not suitable because that is not close enough. And then we are going to make parallax errors. Parallax errors කියන එක දන්නවනේ අපිට හරියට පේන්නේ නැහැ. අර මෙයා මෙතනින් පාස් වෙන පොයින්ට් එක මෙහෙම තියෙද්දි පේන්නේ නැහැ නේ. ඊට වඩා මෙහෙම තියෙද්දි පේනවා. That is called parallax errors. දන්නවනේ. Parallax errors එනවා. ඒතකොට ඒ හින්දා ඒකක්වත් හරියන්නේ නැහැ. Only B and D are suitable. Right. Fixing locating pin and take this down. Take it down. And label all points as A, B, C, D, E. And A is not workable, C is not workable, E is not workable. Adish. Right? Again, write down as bullet points. Again, write down as bullet points. First bullet point. Point A is not suitable. Point A is not suitable. First point. Point A is not suitable. Point A is not suitable. Because point A is not suitable because Bob doesn't reach A when it damps over time. Bob doesn't reach A. Bob doesn't reach A when it damps over time. Bob doesn't reach A when it damps over time. Bob doesn't reach A when it damps over time. Second point, second bullet point. B is suitable. B is suitable. B is suitable. As it is a close point. A close point to lowest point of path. As it is a close point to lowest point of its path. Next point. C is not suitable. C is not suitable. C is not suitable since it is covered. Since it is covered by the bob as it passes. Since it is covered by the bob as it passes. Since it is covered by the bob as it passes. D is suitable. Right? මේ දෙකට මම පොඩි ටික්ස් දෙකක් දාන්නම්. B and D are fine. D is suitable. D is suitable. D is suitable for spherical or plum shaped. Plum කියන එක plum shape කියන එක දන්නවද? Plum shaped. For plum shaped bobs. Plum shaped bobs කියන්නේ මොනවද? ඒකද මතක් වුනේ? ඈ? තාම හිනා වෙනවා. ඒකද මතක් වුනේ? Plum shaped bob එක මතක් කරගන්න. මොකද්ද plum shape bob එකක් කියලා කියන්නේ? What is a plum? Plum කියන්නේ දන්නවද? දන්නවද? plum දන්නේ නැහැ? මේ මේසන්ස් වල ගාව තියෙන plum එක. ඒක දන්නවද? ළමය කියලා කියන්නේ. ඒක දන්නවද? ඒකේ plum shape කියලා කියන්නේ නම් ඉතින් අර ළමේ තියෙන එක වගේ නෙමෙයි. මේ තව එක එක බොබ්ස් තියෙනවා. මෙන්න මේ වගේ බොබ්ස් තියෙනවා. මේකේ මේ නිකන් අමුතු අමුතු බොබ්ස් තියෙනවද? මේ වගේ ඒවා තියෙනවා. right? ඊට පස්සේ නිකන් මෙන්න මේ වගේ ඒවා තියෙනවා. right? මෙහෙම ඒවා තියෙනවා. they exist. මෙහෙම එකක් use කරනවා නම් මේ point එක හොඳයි. ඒතර මෙතන මෙයාගේ පොඩි තියෙනවනේ මේ අර මේකක් point එකක් මේ point එකක් තියෙනවනේ. එතකොට මේ point එක use කරන්නේ ගොඩක් හොඳයි. right? heart shaped වගේ තියෙන බොබ්ස් තියෙනවා. right? ඒක තියෙනවා. we don't use මම කියන්නේ එහෙම එකක් ඇහුවොත් if you are given a different shape of a bob and you are asked to think of the rotating pin, right? එතකොට මෙහෙම අපිට fix point එකක් වගේ තියෙන bob එකක් දුන්නොත් ඒ fix point එක ගන්න එක lazy. right? දැන් මේකේ මේ උඩ flat surface එකක් ඉඳලා B වගේ කෙනෙක් not that suitable. මේ වගේ කෙනෙක්ට මේ point එකේ තමයි rotating pin එක තියන්න ඕනේ. Got the point? right? okay, plum shape කියන ඒවා දැන් නැත්නම් මේක එක shapes තියෙනවා. other than spheres. symmetric shapes නෑ. right? වෙන මෙන්න මේ වගේ shapes ගොඩක් වෙලාවට මෙහෙම ඒවා තමයි plum එකේ තියෙන්නේ. පොඩි point එකක් එක්ක. right? okay. next point strings with multiple threads කියන්නේ මොනවද? ඒ කියන්නේ have you seen nylon වගේ strings එකක් තියෙනවද? nylon එකක් තියෙනවනේ. nylon එකේ දන්නව නේද මේ? ඒ කියන්නේ දැන් nylon string එක තියෙන්නේ මෙන්න මෙහෙම මේ තුනකින්නේ. නොහොම එකක් නේ nylon string එක කියන්නේ. මේකේ මේවා තුනක් තියෙනවනේ. right? ඔය තියෙන්නේ සරුංගලයක් දිහම ගන්න nylon string එක. මේ nylon එකේ threads ගොඩක් තියෙනවා. ඒතර ඒක ඇත්තටම හදලා තියෙන්නේ මේ මෙහෙම අර rotate කරනේ හදලා තියෙන්නේ. එතකොට bob එක දාපු ගමන් ඕකත් rotate වෙනවා. අර වෙලා නැද්ද සරුංගලයක්දී කොච්චර කරත් ඒක කැරගෙනවා. නූල අර කොච්චර අපි ඒ කියන්නේ අර machine cut එකෙන් අරගෙන machine cut එක කියන්නේ once you buy it from the shop, right? ඒක machine එකෙන් නේ ඕක ඔතලා තියෙන්නේ. හැබැයි අපි එකපාරක් යවලා පස්සේ අපි ඕක ඔතද්දි ඕක ඇඹරෙනවා. සරුංගලවල නැහැ. හරි? මේ normal මේ general things එහෙම වෙනවා. ඒතර nylon ඒවා use කරන්නේ නැහැ. මේ එක මේ thread එකක් විතරක් තියෙන string එකක් තමයි ගන්න ඕනේ. threads ගොඩක් තියෙනවා කියන්නේ ඒක මෙහෙම අඹරලානේ තියෙන්නේ. ඒතර ඒක ආයෙවා තනකින් මේ ගැරෙහුවට පස්සේ ආයෙ ඕක ඇඹරෙන්න පුළුවන්. there's a possibility. ඒ කියන්නේ බම්බරේ වගේ මෙහෙම කරගෙන නැහැ. පොඩ්ඩක් අරගෙනවා. right? okay. මොකද මම කිව්වේ? A string with multiple threads are not used. Strings with multiple threads are not used. Right. Strings with multiple threads are not used. Strings with multiple threads are not used. Within brackets, nylon strings. So if you haven't seen nylon strings, go to hardware tomorrow and ask for a nylon rope. එතකොට බලන්න පුළුවන්. ඒ rope එක ඇතුලේ strings තව ගොඩක් තියෙනවා. nylon ropes තියෙනවා. දන්නවනේ? Strings with multiple threads are not used. Within brackets, nylon strings. As there is a possibility of rotating. Next point. A metallic bob. මම කලින් උත්තර mention කරා. A metallic bob is preferred. Since it oscillates for a longer period. It oscillates for a longer period. It oscillates for a longer period due to less inertia. Due to less inertia. Due to less inertia. What is inertia? Inertia. What is inertia again? Again. Definitions. What's your thought? Inertia. What is inertia? Online? Inertia. What is inertia? Inertia. Huh? What is inertia? Yeah. That is the reluctance to change the state of an object. It is called inertia. Objects which are moving are always trying to keep moving. An object which is at rest tries to keep at rest. Right? That reluctance is called inertia. Right? Now, if I compare this with metal and wood, metallic bob and a wooden bob, when mass increases, inertia increases or decreases? When mass increases, inertia increases. Right? That reluctance increases. Reluctance increases කියන්නේ it keeps the state. Right? Last paper එකේ මේක 27 paper එකේ තිබ්බේ. ඔයගොල්ලෝ ඒකේ තිබ්බේ නැහැනේ. inertia question එක තිබ්බේ නැහැනේ. 27 paper එකේ තිබ්බ question එක. Right. Just know that inertia varies with mass. Right? Varies with mass, even if the same size. So let's say you have two bobs. One is metal made of iron or something, right? Iron or steel, let's say steel or something, and a bob of same size made of wood, right? Which comes to the rest faster in a quick time, wood or metal? Obviously wood. That is because of wood is less in mass. Less in mass means less in inertia, right? So it comes to the rest quickly. So the wood back use karo 25 oscillations okay right? It stops before doing 25 oscillations. It stops. It is coming to a stop before 25 oscillations. Therefore, it is not going to work with our thing now. It's not going to work with our thing. So we are using metallic ones, right? Inertia කියන එක දන්නේ නැත්නම් inertia is the reluctance to change the state, a present state. Reluctance to change the present state of an object, right? So objects at rest, දැන් මේවා rest එකේ ඉන්නේ. මේවා rest එකේ ඉන්නවා කැමතියි. ඒක මුලින් තල්ලු කරන්න අමාරුයි. But once it starts motion, then they will keep moving, right? Objects at motion tries to keep moving, and objects at rest tries to keep at rest. Inertia, right? Again, the moment of inertia again in rotational motion, right? That property is called inertia. Alright? The point next point. A spherical bob is more suitable. 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 Yeah, class එක දැම්මේ නැහැ නේ මේක class එක දැම්මේ නැහැ නේ මේක class එක දැම්මේ නැහැ නේ දැම්මද දාන්න එපා අවුද ඒක එකතු කරලා කොහෙන් හරි තියන්න මම නේ එනවා බෑග් ගෙන අවුලන්න නැත්නම් මේකනම දාන්නවා spherical bob is more suitable because air drag within brackets air resistance is comparatively low. Air drag is comparatively low, right? ඒක shape එකෙන් එන්නේ, right? දැන් box එකක් වගේ use කරොත් එහෙම air drag එක ගොඩක්ම වැඩි, right? මේ ඔක්කොම air flow එක මෙතනින් අර cut off වෙලා යනවනේ. දැන් මේකේ air flow එකට පොඩි මේ යන්න පුළුවන් path එකක් තියෙනවනේ. So therefore spherical shape is more suitable. අර streamline shapes වගේ තව හොඳ ඒවා තියෙනවා. හරි. මෙහෙම එකකට ගියොත් වෙන ප්‍රශ්න තියෙනවා. ඒ නිසා දැන් under laboratory conditions this is the most suitable shape. Right? නැත්නම් අර streamline shapes ඉන්නට වඩා හොඳ ඒවා තියෙනවා. හැබැයි මේ වැඩේට අපි lab එකේ ඉගෙන කරන්නේ. So under school laboratory this is the most suitable shape. Right? Right. And one more thing, listen. When we start the stopwatch, listen. When you start the stopwatch, look at the board. When we start the stopwatch, right? First you have to get familiar with this rhythm of the oscillation. No? මුලින්ම එකපාරට කරපුවාම oscillation එකේ rhythm එක අපිට තේරෙන්නේ නැහැ. For that we are using a small trick. Trick is this. First, you are releasing the bob from here, right? Somewhere here, and let it oscillate. And you are going to count down as 5, 4, 3, 2, 1 likewise, and you are going to count 0. Right? 3 වලින් ඔගේ start කරත් ප්‍රශ්නයක් නැහැ. Right? දැන් මේක oscillate වෙනවනේ. බලන්න. Now this releases, and then මේක release වෙනවනේ 1 මේ 1 මෙතෙන්ට 1 2 sorry 3 2 1 and then the 0th one comes down. At 0 you can turn on the stopwatch, because after seeing 3-4 oscillations we can get an idea about the rhythm of the oscillation. එකපාරම තේරෙන්නේ නැහැ මොකද්ද මේ oscillation එක යන විදිය කියලා. පොඩ්ඩක් කියලා බලන් හිටියම ඔගේ idea එක එනවනේ. ආයෙත් දැන් right. Look at here. මෙන්න මෙහෙම එකක්. Now this is at the initial point only. Initial point only to get the exact rhythm of this oscillation. See, the මෙහෙම අපි release කරනවා. Right? Release කරපුවාම දැන් 1 කියලා stopwatch එක දාන්න බෑ. ඔර අනිවාර්යෙන් delay එකක් තියෙනවා. So therefore what we are doing is you let this go and 3 2 1 කියලා මේ count down එකක් එනවා. Count down එකක් ඇවිල්ලා 0 වලදී තමයි start කරනවා. Right? 5 වලින් වගේ ආවත් ප්‍රශ්නයක් නැහැ. minimum 3 වත් එන්න ඕනේ. minimum 3 මේ වගේ නේ. මෙතනින් පටන් ගත්තා. මෙතන ඉඳන් මෙයා මෙතෙන්ට කියලා once this travels to the amplitude, opposite amplitude and comes to the same amplitude, only one oscillation is completed, no? So මෙන්න මෙහෙම එකක්. 3 2 1 0. This is where you start the stopwatch. ඊට පස්සේ 1 2 3 4 up to 25. Right? නැත්තම් අර starting point එකේ ඔයාලට lag එකක් එනවා. delay එකක් කියන lag එකක් එනවා. Right? You will make a lag when turning on the stopwatch. Right? So therefore that's a precaution followed. That's a precaution followed. Right? Write down last point. Last point. Write down. To start stopwatch. To start stopwatch. Start counting with a countdown as start counting with a countdown as start counting with a countdown as 3 2 1 0 1 2 3 up to 25. Measure this. 3 2 1 0 1 2 3 up to 25. Right? Listen. Okay, now let's go through what is given here. Right? Quickly. මොනවා හරි තව මිස් වුණාද කියලා බලන්න. මේක නිකන් go through කරලා බලමු. And the past ever questions which have been come from the experiment is mentioned at the last page of the tutor. Questions එක තියෙන්නේ. එක mention කරලා තියෙන්නේ ඉතින්. මේ paper එක අතර බලන්න පුළුවන්. Quickly නිකන් go through කරලා බලන්න. Determination of acceleration due to gravity, a simple pendulum, meter ruler. හරි මේ මේකට වඩා මගේ list එකේ තිබ්බා. හරි. ඒ මං කියෝ list එක පාඩම් කරගන්න. මොනවා හරි මිස් වෙලා තියෙනවද කියලා දෙන්න බලන්න. Method. Pass the pendulum string through the cork and suspend the pendulum from first hand. Measure the oscillating length L of the pendulum from the point of suspension down to the center of the pendulum, center of gravity, right? Note down the value of L and fix the locating pin vertically below and close to the lowest point of the path of pendulum bob. Pull the bob aside till the incline by an angle vertical 5 or 6. Release the pendulum. Start by 40. ඒකත් මම කියවනේ 6 recordings. Table එක තියෙනවා, right? Considering the value of G into 9.78, find the percentage error of the, okay. Right, may 3 to 1 එක මේක තියෙනවා. In order to activate this stopwatch, when the pendulum bob passes the locating pin, start counting in the descending order. Start counting from 3 when bob passes. Sorry, I explain that, that's all. Right. And listen. And there is another thing that we can do from this same experiment, same setup, right? This same setup can be extended to find height to the ceiling from the floor. Ek question සමහරට ඔයගොල්ලන්ට හම්බුලා ඇති. කළා දෙනවා. Right? එදා පෙපරේ තිබ්බා. Right? එදා පෙපරේ තිබ්බා. ඊට ඩිස්කෂන් එකට තියෙන පෙපර් එකේ තියලා. Right? ඉතින් මේක එක්ස්ටෙන්ඩ් කරන්න පුළුවන්. ඒකත් මෙහෙම කියලා දෙන්න නැත්නම් අපරාධනේ. සමහර ඉස්කෝලේ කරලා තියෙනවද දන්නවද? See, this is something we can do further, right? මෙන්න මෙහෙම වැඩක් කරන්න පුළුවන්. Look at the board. Right down below. This same experiment can be extended to, this same experiment can be extended. This same experiment can be extended. This same experiment can be extended to find height to ceiling from floor. To find height to ceiling. To find height to ceiling. To find height to ceiling from floor. Right. දැන් pendulum එකක් use කරන්නේ height to ceiling ගන්න ඕනේ from here to here. Pendulum එකක් use කරේ නැත්නම් කොහොමද ගන්න පුළුවන්? So if you are not using a pendulum to find the height from the floor to ceiling of a building, what are the other methods you have? Can you do it using a meter ruler? Right? Not that accurate. A tape. Possible. හැබැයි tape එක හරියටම vertical ද කියලා අපිට කියන්න බෑ. But even though you are using a tape, right? We can't make sure that the tape is exactly vertical. Roughly ගන්න පුළුවන්, right? So that's why to get more accuracy, this kind of a method is used, right? Make it here. Listen. The bob is attached to the ceiling like this, with the cork, everything is there. And cork එක තියෙනවා. With the cork, everything is there attached to the ceiling, right? And now you have to take it down somewhere up to some level which is close to floor, right? දැන් අර අල්ලන්න බැරි තරම් උඩින් මේක attach කරගෙන ඉතින් කරන්න බෑනේ, right? අල්ලන්න බැරි තරම් උඩින් attach කරගෙන යන්න බෑනේ. So you have to take it somewhere close to you, right, from the ceiling. And let's consider height from floor to ceiling as capital H, right? And height from floor to height from floor to bob as simple H, right? Simple H කියලා ගමු. Now you can rewrite the equation using these two terms by substituting L and repeat the experiment. Now in this scenario, this is going to change like this. Look at the board. T equals 2 pi root L over G. Now instead of L, right? Make an L. Instead of L, you can write H minus H over G, right? Then T squared equals 4 pi squared over G H minus H, right? See? I put this question in the last paper and I went through few answers and I didn't see anyone who has done it in the exact proper way, right? Variables වල වැරදි මම papers 3ක් විතර නිකන් බැලුවා. බලමු. Right. And see, t squared equals, this is 4 phi squared h over g minus 4 phi squared simple h over g. No? Now tell me, what are we going to choose as the independent variable? What should we choose? Capital H or simple H? Huh? Can you change the distance between flow and the ceiling? Right? Make a change it. Now, once you adjust the length of the string, simple H changes. Right? There's no L in this story. Right? You have rewritten L using H and H, simple H and capital H. Right? Now, when length of the bob changes, length of the pendulum changes, simple H changes. So manually, what you can change is simple H. Right? This whole term is a constant. 4 phi squared h over g is a constant. Right? Then this is x. Whatever it is as a product with independent variable is gradient minus, and this is a constant intercept, and this is y. So what you are going to get is y equals c minus mx graph. හැමෝම ඇදලා තිබ්බ mx. හැමෝම කියනවා තුනක් විතර දැක්කේ. හැමෝම ඇදලා තිබ්බ mx. h minus s කියන්නේ h minus h එකට variable එක අරගෙන. Capital H is not a variable. Alright. Now what you are going to get is this t squared with h minus mx plus c. මේ තියෙන minus mx plus c නේ, that is a standard curve. Minus mx plus c. හරිනේ? මේක මෙහෙම පේන්නේ නැත්නම් ඉතින් මෙහෙම ලියාගෙන y equals minus mx plus c. That is a standard curve. Plus c minus mx. Something like this. හරි? මේක තමයි curve එක. මේක තමයි curve එක. Now, once this curve is plotted, you know gradient and intercept. Gradient of this graph is 4 phi squared over g. Intercept of the graph is, look at here, last part. Intercept of the graph here, 4 phi squared capital H over g. Right? Now tell me, what is the easiest way to find capital H? What is the easiest way to find capital H? Now, using the graph. Quickly. Practicals කරන්න. What is the easiest way to find capital H? මම කියලා දෙනවා paper discussions වලත්. What is the easiest way to find capital H now? Huh? Using intercept the. Huh? Using intercept. Online? Who says using intercept? Just using intercept. Again, my point up there. Now, certain experiments got make hambu. Not only today, throughout. What's the easiest way? Easiest and the best way, actually. Easiest, the best way to find capital H. Any idea? No? No? Yeah? Yeah. No. Possibly. No. I have told you, right? Maybe once or twice. First tell me whether is it determinable using intercept? Intercept එක use කරලා මට capital H හොයන්න පුළුවන්ද? පුළුවන්ද බැරිද? කතා කරන්න ඕනේ. පුළුවන්ද බැරිද? කතා කරේ නැත්නම් මේකෙන් දෙනවා පාරක්. ඔය නෑ නෝ තෙන්ට යන්න පුළුවන්. Tell me, can we find, listen, can we find capital H just by using intercept? Can or can't? පුළුවන්ද බැරිද? එච්චරයි. ඇයි බැරි? පුළුවන්. ඇයි බැරි? ඉතින් graph එක තියෙනවනේ. Graph එක තියෙනවා නම් don't you know the intercept of the graph? We know. ඉතින් බෑ කියන්නේ. පුළුවන්නේ. පුළුවන්ද බැරිද? පුළුවන් නේ ඉතින් පුළුවන් කියලා කිව්වනේ. Right? Now, if the graph is there, listen, make a good point. If the graph is there, you know the intercept. Intercept එක දන්නවා. මේක use කරලා කරන්න පුළුවන්. But we don't do. Because there's a safe method because 4 pi square dou g is common, right? If you divide intercept by gradient, only h remains, no? And now we are totally safe. ඉතින් කියන්න ඕන. right? ඒක දැනගෙන හිටියද? දැනගෙන හිටියේ? right නේ? Now we are safe. දැන් මේ 5 squared g ඒව මේවා එක ඩීල් කරන්න ඕනේ නැහැ. right? Because c and m are kind of very trustworthy values because of the graph. ඒතොර ඒවා sure නේ. දැන් මේ 5 වගේ කෙනෙක් ආව බොරුවට substitute කරන්න ඕනේ නැහැ. Got the point? So in such cases, keep this in mind here onwards, right? You will see the same thing in more coming up experiments. Not only today, right? Current electricity වල එහෙම ගොඩක් ඒවා තියෙනවා. thermal වලත් තියෙනවා. ගොඩක් ඒවා තියෙනවා. right? Check both, and if you can find it using gradient and intercept with the division or multiplication, our first priority is that. මේකට යන්නේ නැහැ. මේකට යන්නේ නැහැ. First priority is this. Hey, මෙතන error එක ඒතකොට කෙලින්ම නැහැ. We don't need to worry about 4 pi squared over g. Right? Okay. Let's say මේ දෙක ලියලා and h equals c over m. So like this, you can find the height to ceiling from the floor. Right? This is an extension of the same experiment. Right? හරි. ඔය වඩා මොකුත් නැහැ ඔය experiment එක ගැන. Take it down. What on you? You want? Okay, take it down. This is it. Take it down. Take it down. This experiment has taken 2 hours. නෑ මේමයි ගයිඩ් එකේ තියෙන විදිහට මට කරන්න පුළුවන් 15 minutes වලින්. එහෙම කළා වැඩක් නෑ ඉතින්. ප්‍රශ්නයක ලියන්න බෑ ඕගොල්ලන්ට. right? ඔව් නිකන් බලන්න ගයිඩ් එකේ මොකක්ද දීලා තියෙන්නේ කියලා. හැබැයි questions වලට ඒක එන්නේ නෑ. Because guide is for, I mean, reference. Right? There is a more depth compared to that. ඒක තියෙන ටික පුළුවන් වුණා කියන එක නෙමෙයි වැඩේ. Basics is there. I mean, basic is in the guide. But this is what you should know about this whole thing. දෙකට නම් ඉවර ගන්න බැරි වෙයි. Where are you from? Yeah. Huh? Close by. Orang kau? Aku kesan tu. Ikan ni mana? Ikan ni mana? Nata. Adi je? Ah, ni. Ya? Kau? Balik dia. What balik dia ni? Ah, nak pokok ni. Right, take it down, take it down. Okay, fast down. Oh, hinail. Saugasan di ko da, tuloy lang. Actually, ma ini. Oh, ¿qué es? Tú. Hey. මේ ලියන්න බෑ හොඳේ. සිරාවට ගියා. මේ මට ඒක ලියංගත් කිව්වා මේ ඔය දැන් මෙතන ගියේ ප්ලස් එක දිදුලත් කිව්වා මේ මම පර්මිෂන් ගත්තම එහෙම කියලා එළියට යන්න බෑ මම ඉඳලා කිව්වා රයිට් යන්න බෑ නැත්තම් ඒක මට ප්‍රශ්න මේ මම ඉන්ස්ටිටියුට් එකට කතා කරේ මේ විදිහට නැත්තම් ඒක අවුලක් තියෙනවා රයිට් hey finished okay මොකද okay finish let's move on okay now tell me any questions from this හරිනේ මේක ඉවරයි hey okay let's move on write down practical 2 write down practical 2 practical 2 හරි මේක lazy write down කලින් ගත් lazy මේක පොඩක් දිගයි මොකද දුවන්න බලාගෙනවද කියන්නේ හොරගත්තා okay practical 2 write down verification of the relationship between write down second one verification of the relationship between the mass of a body suspended from a helix spring and its period of oscillation right first write down materials and apparatus materials and apparatus right write down one by one a helix spring a helix spring second one a supporter a helix spring you can write with me second one a supporter stopwatch two locating pins 6 loads or weights of 100 grams 6 loads or weights of 100 grams 6 loads or weights of 100 grams right so get here right manga explain කරන්නම් ඊට පස්සේ බලමු first the apparatus right apparatus is going to set up like this right first you have to fix the spring to the supporter right you have to fix the spring look at the board to the supporter like this you have to fix the spring to the supporter like this right you are fixing the spring and here mass එකක් නෙමෙයි here we are using something like this kind of a pan where you can put masses in like this right? That is not a bob, that is a pan to add masses. That is a pan to add masses, right? And what about now here we are going to use two locating pins now. Why two? දෙකම මොකටද? එකක් සමාන්තරද? දෙකම මොකටද? දැන් කලින් එකෙන් වැඩේ කරගත්තානේ. Any idea why two pins? එකෙන් කරන්න පුළුවන් for more accuracy අපි දෙකක් use කරනවා. Why two pins? Any idea why we are going to use two pins? එකෙන් කරන්න පුළුවන්. I mean it is doable using one, right? But still we are using two for more accuracy. Why? Any reason? Any reason? මොනවා හරි දෙනවද? Any possible reason? Any thinkable reason? හිතලා කියන්න. No idea. Right. එකක් කොහොමද ඕනේ මේක තේරෙනවද? Right. මෙහෙමයි කරන්නේ. See, listen. The reason to use two locating pins is, right? One pin we are going to fix here, right? You are going to fix one pin here, right? And one pin here and another pin here for more accuracy, right? Now when it passes through, right, you can clearly see, right, at which point it exactly passes pins, right? Easily count එකක් ගන්න පුළුවන්. නැත්තම් වෙන්නේ මේ එක පොයින්ට් එකක් දිහා විතරක් බලාගෙන ඉන්නකොට අමාරුයි, right? මෙහෙම පොයින්ට්ස් දෙකක් පාස් වෙන තැනක් බලද්දි ලේසි නෙමෙයි. What area? That is why you are going to use two pins. So මේ දෙකම pins නා. Both of them are pins. Pins දෙකක් මෙහෙම අපි fix කරනවා. Right? So this is the helix spring and this is the supporter, right? Locating pins, there are two locating pins and these are the loads, right? So basically here onwards what we are going to do is we are starting with 100 grams, right? At the 100 gram weight here and give a small displacement. You are taking this, dragging this a little bit downwards and giving a small displacement and release, and this is going to undergo a simple harmonic motion like this, right? This is going to undergo a simple harmonic motion. Then similarly as we did before, right, we are going to count the time period for number of oscillations for 20 or 30 or whatever it is, right? With respect to the setup, to maintain the error less than 1%, you are going to count oscillations and take down the reading and going to repeat the experiment by adding masses, starting with 100 grams and we have 6 loads now, right? Then adding another 100 grams, then 200, 300, likewise up to 600 we can continue. And again we are going to record all values, right? Okay, so first take this down under apparatus. මේක තමයි apparatus එක. Take down. ඇයි කලවද? හරි. ඔයා බලන්න. දැන් සාමාන්‍යයෙන් 100න් 10 මදි. ඒ කියන්නේ ස්පින් එක හැටියට ගොඩාක් ස්මූත් ස්පින් එකක් නම් 10ක් වගේ අවුලක් නැහැ. ඒ කියන්නේ මේක දිනවනේ මේ ස්ටිෆ්නස් එකක් K ගොඩක් අඩු ස්පින් එකක් නම් පොඩි එකක් අවුලක් නැහැ. දැන් ඒ වගේ එකට මේක දැම්මොත් එහෙම මේ වගේ ඔසිලේෂන්ස් කරනවා. අර depends. ඒක මම කිව්වේ. generally බලනකොට දෙන්නේ 30 oscillations. ඔය ගයිඩ් එකේ තියෙන එක. මේ අනිත් එක මේක දෙන්නේ 50 oscillations. දැන් මම කියන්න හදන්නේ 100 grams 25 oscillations කියලා. depends. 50 oscillations count කරනවා කියන්නේ ටික අමාරුයි. ඒ කියන්නේ එක ඉඳන් 50ට මේක දිහා බලාගෙන ඉන්නවා කියන්නේ සෑහෙන අමාරුයි. That depends. ඒක තමයි. If the error is less than 1%, doesn't matter if you are counting 10 oscillations, 15 maybe. Depends on your setup and the spring, because this changes with the stiffness. ඒ කියන්නේ spring constant of the spring. Spring එක නිකන් අර stiffness අඩු එකක් නම් පොඩි weight එකක් ඇති. But if you have a spring with the higher stiffness, you need to have a higher weight. Right? That's it. That's a good question. Right? ඒක තමයි එතන point එක. Right? Sandil, all good? Finish? Okay, then the theory. Theory. Over again, කසුදු. උගේ කාඩ් එකක් කුඩු. නැන්ද? රෙඩියෝ දානවද? ඈ? ඈ? හරි, theory. Write down. Let suspended mass be simple m. Let write down. Let suspended mass be simple m. Let suspended mass be simple m. Let suspended mass be simple m. Let suspended mass be simple m and spring constant be k and spring constant be k. Right. Put a comma and write down. Then period of oscillation is given by. Write down. Then period of oscillation is given by. Then period of oscillation. Then period of oscillation is given by T equals. What is the equation? Period of oscillation of a spring. 2 pi root m over k. Right? 2 pi root m over k. Given by, put a comma and write down T equals 2 pi root m over k. Introduce terms. M suspended mass k spring constant. Spring constant. Right? Okay. See, now again T squared equals 4 pi squared m over k, no? Which means T squared equals 4 pi squared over k times m. Right? Okay, now tell me, what is possible to change manually from our end here, from these terms? Huh? Again, there is only one term, only m, right? 4 pi squared is a constant, k is a constant for a given spring, and time exchange karna කොහොමද බෑනේ, right? Time exchange karna එක අමාරුයි ඔන්න, right? Then m is going to be considered as the independent variable x, right? And whatever it is as a product, with x with independent variable is gradient, and this is going to be considered as y, right? Now we are going to verify the relationship between t and m now, right? If this relationship is correct, t and m, t squared and m, if this relationship is correct, theoretically you should get a straight line which goes through origin, right? Y equals mx. Therefore, now you have to plot the graph. You have to plot the graph between t squared and m, and check whether this graph goes through, right? Check whether this graph goes through origin. If it goes through origin, this is verified, right? This is verified. So you can say t squared is proportional to m, right? If t squared is proportional to m, t is proportional to root m. It can be verified, right? That's a verification. You have to plot the graph and check whether it goes through the origin point. Got it? Right? Okay, as a theory, take this down. Write down. Right? Mike මොකවත් සද්දයක් නැත්තේ? All good? Step in now. Okay, finished? Write down below. If the graph between, right? මේක ලියන්න එපා. Only the graph මේක ලියුවද? Come on, නෑ ලියුවද? Below the graph. If the graph between t squared and m, if the graph between t squared and m, if the graph between t squared and m, if the graph between t squared and m is a straight line goes to origin, is a straight line goes to origin, is a straight line goes to origin, relationship of mention this t squared proportional to m can be verified, of m can be verified. Right? Okay. Then method. So write down in point form, right? I explain what we are going to do basically generally, right? And now let's see the steps one by one, right? Okay, method. First point. Fix helix spring. Fix helix spring to supporter and attach a load holder, and attach a load holder slash pan, a load holder slash pan to the other end, of spring, Second point. Second point. At 100 gram load, at 100 gram, at 100 gram load into pan, into pan, into pan, pan එක කියන්නේ hold එකකට, into pan එක, right? මේක උනා මේ load එක. So if needed, you can label this. This is the holder, holder or pan, right? නැත්තම් මේක ගලව ඉන්න ඕනේ. Otherwise, one by one you have to detach and attach, right? මේක පොඩි hold එකක් තියෙනවා. Then you can add the weights onto the pan, right? Okay, what did I say? Add 100 grams weight into pan. Okay. Into pan and give a small displacement downwards and give a small displacement downwards and give a small displacement downwards and release. Give a small displacement downwards and release. Next point. Measure time takes, measure the time takes, measure the time takes, measure the time takes for 20 or 25 oscillations, 20 or 25 oscillations, 20 or 25 oscillations as percentage error is maintained, as percentage error is maintained at less than 1%, as percentage error is maintained at less than 1%, as percentage error is maintained at less than 1%. Next point, repeat the experiment, repeat the experiment, repeat the experiment, repeat the experiment, adding 100 gram weights one by one. Repeat the experiment, adding 100 gram weights one by one. Adding 100 gram weights one by one. And record mass and periodic time in following table. And record mass and periodic time in following table. And record mass and periodic time in following table. Right? Now here also, we are not going to take the time for oscillation at once, right? So we take two readings, similar table as before, right? Similar table as before. First one is mass is in grams, right? Mass is in grams. And then these two are the two readings of T. T is measured in seconds. First reading, second reading, and the average and T squared. Same table, right? Same table. Take down 6 pairs. We need 6 pairs, right? And here also T is average periodic time. Average periodic time. This is in seconds. This is in second squared. Squared. Maybe. Finished? Write down below. Plot t squared. Units are known. Plot t squared. Put units. Mass is in grams. T in seconds. T squared is in square seconds. Right? Plot t squared against m. 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 And check the shape of graph and verify the relationship as mentioned under theory. And verify the relationship as mentioned under theory. Right? One second. Right, listen. Now, listen. If you get a graph which goes through the origin, that is verified. But usually, we don't get the graph, exact graph, which goes through the origin. What are the reasons? There's a main reason behind it. Usually, we don't get the exact one. What are the reasons? Right, now from here, the method is done, but usually we don't get the exact graph which goes through. Any reasons? What are the reasons? What are the reasons? What again? Huh? We have no reason. Kya? Give any reasons? Main what is the error we have made in simple lem? Simple lem we have made an error in simple lem. What is it? This equation is valid for only for which strings? Huh? Which strings? Which type of strings? In both physics and combined maths, we do the same. This equation is only valid for which type of strings? Online students? Tell me, this equation is valid for only for which strings? I have explained under theory in waves, in simple harmonic motion. Oh? Huh? Huh? Strings are by default elastic. Which type of strings? Huh? Tell me that. Yes? Huh? Then I'm not again. Huh? Not clear. Huh? No, clear. No. Just tell me. Anyone? Simple harmonic motion. Light springs. Right? We don't consider mass of a spring. That is why this period remains same. I'll explain again. That is why this period remains same even though the orientation of the spring changes, right? Doesn't matter whether it's vertical low, horizontal low, angled, inclined or whatever it is, right? Period remains same. Period remains same because weight of the string is not impacting on this equation, only the mass. So therefore that doesn't matter. But in reality, we don't have light springs, no, right? We have springs which are like having negligible weights, but not light. 0 grams, that is not 0. Therefore, that error comes into this. There is something that we can't get rid of. Light springs are not really existing, right? So therefore, usually we won't get this as it is going through the origin exactly, right? So ඉස්කෝලේ ගණිතදී shape එකේදී මේක origin එකේ යන්න ඇඳ වෙන්න පුළුවන්. අතර වෙන්නේ නැහැ. එහෙම ගන්නවානේ. right? Points එක දාලා points එකේදී මෙහෙම වෙනවානේ. But in reality it won't go through because of that error. Is it clear? Right. One second. Vidul. Right. Listen. Hurry, okay? By the way, did you see that? Mute the නෑනේ. මේ t-shirt tape මේ ගහලා ඉන්න මට පේන්නේ නැහැ mute දාන්න කියලා. ඒ කියන්නේ වත් වෙලාද? Right. Did you see that? That video getting viral from that Sirmavian or Sirma student? ඒක දැක්ක? ඒ මරුනේ. නෑ ඇත්තටම. I'm serious. එහෙම තමයි වෙන්න ඕනේ නේද? දැන් ඔයගොල්ලෝනත් එහෙම දන්නවා ඇතිනේ. right? මම මේ දැනුත් ෆෝන් එක බලද්දි ඒක එකක් දැක්ක. ඒක දැන් මට මතක් වුණේ. මම නැත ස්පීච් එක බලුවා. right? So if you haven't seen that video yet, I highly advise you to watch it. Right? Please watch it. Right? So that's the what we call that gut. A girl or boy, that doesn't matter, should have, if there is something, I mean, if she is truly deserving it, එයාගේ point එක කතාව ඇහුවනම් දන්නවා ඉතින් speech එක ඇහුවනම්, right? එයා truly deserve, and because of the favorations, that award is that award is has been given to someone else, and the reason has been the girl is not participated the rehearsals because of an exam, something like that. And one madam has given it to another one who is having not that qualifications, not that maybe achievements compared to her, right? She is already passed out. 23 batch again, 23 dana. She's already passed out, right? I think she's from 23 batch. That's 23. දැන් මේ පස්සේ ආපු color coding එකක් මොකක් හරි, right? ඊට පස්සේ ඒක බලන්න, ඒක නියමයි. And what I say is, මම මේක කියන්න හේතුව, I mean the reason to share this is, right, with all of you, as Gen Z students, Gen Z කියන එක දන්නවද? ඒක දන්නේ නැත්නම් ඉතින් Gen Z දන්නවද? right? අපි කියන්නේ ඕගොල්ලෝ. As Gen Zs, right? ඔගොල්ලෝ Gen Z නේ. As Gen Zs, something like that. As Gen Zs, ඒ වගේ දේවල් නම් අනිවාර්යෙන් තියෙනවා. මොකද ඉස්සර ලොකුවට දැන් සාමාන්‍යයෙන් if something goes against, say, the supposed way, usually we don't speak, right? We කියලා කියන්නේ majority don't speak, right? Majority don't speak up, especially girls, right? Boys ලාත් majority එක speak up කරන්නේ නැහැ. ඇත්තනේ? කරන්නේ නැහනේ. එහෙම කතා කරන්නේ නැහනේ. මොකක් හරි එකක් තිබ්බොත් නිකන් බලන් ඉන්නව ඇරෙන්න. Against අපි කතා කරන්නේ නැහැ. Against කියන්නේ ගහගන්න කියලා නෙමෙයි කියන්නේ. මම කියන්නේ if you see something that is not justifiable, right? Not reasonable, then you should be able to, you should have a spine to stand against that. අන්න ඒක තියෙන්න ඕනේ. right? ඒක කවුරුණත් doesn't matter whether boys or girls, right? මම කලින් දවස් ගත්ත ඔහොම එකක් මොකක් හරි මේ ක්ලාස් එකේ මම හිතන්නේ ෂෙයා කරා මේ අර බසස් වල ඉන්සිඩන්ට්ස් ගැන මම කිව්වනේ. අන්න ඒක තියෙනවා. මම එදත් ඔය පොයින්ට් එක කිව්වා. මට වීඩියෝ දැක්කම මාර සතුටු වෙනවා මේ ඒ ගර්ල් ගේ තියෙන ඒ ස්ට්‍රෙන්ත් එක නියමයි. ඒක මරු. ඒක තමයි තියෙන්න ඕනේ. right? I mean, a girl should be girlish. ඒක නෙමෙයි මම කියන්නේ. ගර්ල් කෙනෙක්ට බෝයි කෙනෙක් වගේ වෙන්න කියලා නෙමෙයි. හැබැයි අර ඕන තැනදී එයාට කතා කරන්න පුළුවන් වෙන්න ඕනේ. අර දැන් එතන වෙන්නේ බෝඩ් එකේ ආරගෙන පැත්ත කරනවා නම් no one knows the story. Right? Only those madam and the girl, the victim girl, that's it maybe. Or maybe close friends of that girl, that's it. But now the whole country knows. Right? And most probably, for sure, actions are going to be taken against the staff. Staff means the involved parties. Right? That is what we should have. Right? කියන විදිහට මිනිස්සු කරනවා. If you see that that is not a correct thing to do, not a correct thing that you are seeing, right? What my advice is, you should be able to stand up against. Right? ඒක තමයි වෙන්න ඕනේ. නිකන් බලන් ඉන්න බෑ. ඇත්තටම. ඒක ක්වොලිටි එකක් ඕගොල්ලන්ට තියෙන්න ඕනේ. මම මේක දැක්කම කියන්න හිතුනේ මේ ඒක ඇත්තටම තියෙන්න ඕනේ ක්වොලිටි එකක්. ඒ වීඩියෝ එක මම තුන් පාරක් දුකද බැලුවා. මේ ඒක ඒ තරම් මාරු. මේ ඒක බලන්න බැලුවේ නැත්තම් අවෝඩ් එක ගන්න කලින් එයා කෙලින්ම ස්පීච් එක කරනවානේ. right? අර මැඩම් ඇවිල්ලා කියනවා මේ stop this මේ මෙහෙම කරන්න කියන්න එපා කියලා. අරයා කියනවා මැඩම්ට දැක්කද ඒක? මේ නෑ මැඩම් මොකක් හරි කියලා එයා ඒත් කතා කරන එක. ලොකු කේස් එකක් යනවා. මේ this is only one scene, one incident that you saw, right? There are maybe hundreds, thousands of incidents in any school. Favorations තියෙනවා. schools වල favorations තියෙනවා. not only in schools, මේ society එකේ ඕන තරම් තියෙනවා. right? So if you see something like that, right? Now you should be able to stand up against. right? එහෙම තියෙන්න ඕනේ. right? ඒ habit එක ඇත්තටම හදාගන්න. ඒ කියන්නේ Tamanට මොකක් හරි අසාධාරණයක් වෙනවා නම් කඩ වහගෙන ඉන්න එපා. simply ඒක තමයි මට කියන්න තියෙන්නේ. simple as that. ඔයාට මොකක් හරි ප්‍රශ්නයක් වෙන්න යනවා නම් right? ඔයා දන්නවා නම් ඒක ඇත්තටම that is not the correct thing කියලා. right? Don't hesitate to speak up. right? Because once the society understood that what you are saying is correct, the whole society will be standing up with you. right? You are not alone. The other party will be alone. right? ඔයාට වැරදි point එකක් එක්ක ඔක් කරන්න බෑ. If you got a wrong point, the vice versa happens. But if you have a valid point, if you have a good point, justification, something like that, right? Don't hesitate to stand up. right? ඒක ඇත්තටම පුරුදු වෙන්න. right? සමහරවිට පොඩි දේවල් දැන් මිනිස්සු ඕන තරම් එහෙම වැඩ කරනවා. ඕනනම් දැකලා තියෙනවා. නිකන් කිව් එකක් පැන්න වුණොත් ඕනනම් කැමති නැහැ. අපි කවුරුත් කැමති නැහැ. හිතන්නකෝ මොනවා හරි කිව් එකක ඉන්නවා. right? මොකක් හරි කිව් එකක ඉන්නවා. බේත් ගන්න ගිහලා මොකක් හරි කිව් එකක ඉන්නවා. නිකන් එහෙම හිතන්නකෝ. ඊට පස්සේ ආපු කෙනෙක් ડોක්ටර්ගේ ෆේවරේෂන් එකකට ගිහලා ගන්නවා. ඉතින් අපි උදේම ඇවිල්ලා channel එකේ මොකක් හරි channel එකක් දාගෙන අපි උදේම ඇවිල්ලා බලන් ඉන්නවා නම් if someone is skipping the queue because of a contact or a favoration, එහෙම හොඳ නැහැ. එහෙම වෙනවා. ඉතින් ඒ වගේ තැන්වල ඉතින් be vigilant. ඒ වීඩියෝ එක දැක්ක නැත්නම් බලන්න. ඒක ඇත්තටම හොඳ වීඩියෝ එකක්. right? ඒක නියමයි. කාලෙකින් මේ ඒක ස්කූල් ලෙවල් එකේ වගේ දෙයක් මම හිතන්නේ උනේ. ගොඩ කාලෙකින්. right? මේ ඇත්තටම එයා කතා කරන විදිහෙන් තේරෙනවා that she has everything deserved to do the speech that way. එහෙම නැත්නම් කතා කරන්න බෑ. right? එයාගේ qualifications පොඩ්ඩයි speech එක කියන්නේ. ඊට වඩා යාට තව ගොඩක් තියෙනවා. එයා well deserved. That's it. පොඩ්ඩක් නෙමෙයි. එයා well deserved. අර ළඟින්වත් නැති කෙනෙක්ට තමයි ඔක දීලා තියෙන්නේ. ඔක තමයි case එක. right? okay. මොනවද කිව්වේ? මොකද කිව්වේ නැහැ. mention remarks. As girls, you all should. I'm serious. Again, especially girls are අමාරුලාවට බයයිනේ කතා කරන්න. ඇත්තටම කියන්නේ. එහෙම වෙන්න එපා. මොකක් හරි Tamanට අසාධාරණයක් වෙද්දි කතා කරන්න බයයි. කමක් නැහැ කියලා පැත්ත කරලා ඉන්නවා. That is not innocence. Innocence කියන්නේ ඒක නෙමෙයි ඔය. කියන්නේ Tamanට මොනවා හරි වෙනවම මිනිස්සෙක් කියලා අපිව යූස් කරලා යනකම් එහෙම නැත්තම් අර අපෙන් මොකක් හරි අපිට අපි කියන්නේ මොනවද අපිට මේ මොනවද කියන්නේ රෙදි හොදලා යනකම් වගේ එහෙම කියන්නේ. අර අපිට යූස් කරලා යනකම් බලන් ඉන්න එපා. right? අනිත් එක එහෙම කට්ටියව සුද්ධ කරන්නත් එපා. අනිත් පැත්තට කතා කරන්න ඕනේ. එහෙම තමයි. එහෙම තමයි. මේ especially girls මේ පොඩි advice එක සෑහෙන්න වැදගත්. when you are moving forward in your life, right? I mean after A-levels කෙලින්ම society එකේ ඉන්නේ. So when you are in the society, right? Society is always unfair. Keep that in mind. Society is always unfair. fair කියලා හිතන කිසිම දෙයක් society එකේ fair නැහැ. කිසිම දෙයක් නැහැ. right? කිසිම දෙයක් නැහැ. Society is always unfair. It's a fact. It's a fact. right? වෙන කෙනෙක්ට benefit එකක් නැත්නම් වෙන කිසිම කෙනෙක් ගොඩක් වෙලාවට අපිත් එක්ක ඩීල් කරනවා අඩුයි. ඉස්සරහට යද්දි society එකේ. right? එහෙම ඩීල් කරන්නේ ඇත්තටම ඩීල් කරන්නේ parents ලා විතරයි ගොඩක් වෙලාවට. without having no benefit at all. right? මොනවා වුණත් ඔයත් එක්ක ඉන්නේ ඒගොල්ලෝ විතරයි. all the society except your family circle is unfair. right? best friend උනත් එච්චර තමයි ඔය. ඇත්ත කතාව. බොරු නේ. කොච්චර close උනත් even though you are maybe very close, same. එහෙම තමයි. ඉස්සරහට තේරෙයි මං කියමු මොකක්ද කියලා සමහරවිට මේ maybe after 10 years, maybe after 15 20 years of time, right? You will see. ඒ නිසා මේ ඇත්තටම according to my understanding, the only circle you are with without gaining no benefit at all is the family. Immediate family එක. right? girlfriend boyfriend නෑ. no way. ඉස්සරහට තේරෙයි. okay. yourself. ඉස්සරහට තේරෙයි හොඳේ. දැන් හිතාගෙන ඉන්නේ නෑ නෑ ඇත්තට listen I'm serious. මම මේ කතාවයි කියන්නෙත් නෑ. listen I'm serious. කොච්චර වුණත් affair එකේ ඉන්නකොට සමහර විට ඒ කියන්නේ affair එක පටන් ගත්ත ගමන් නම් සමහර විට එහෙම ඒ කියන්නේ හොඳයි අම්මලාටත් වඩා හොඳයි තාත්තටත් වඩා හොඳයි එහෙම හිතනවානේ. අම්මලාටත් වඩා හැබැයි දාන්නේ මම රෙකෝඩ් කරා. මේ ඇත්තම කතාව benefit එකක් නැත්තම් ඉන්නේ නැහැ for sure. right? benefit එකක් නැත්තම් ඉන්නේ නැහැ. simple example එකක් කියන්නම්. නිකන් හිතන්නකෝ. both of you are in a relationship, in an affair, and after A-levels, the girl is selected to say University of Moradua, Faculty of Engineering, and the boy has got 3 C's and doing say applied maths, physical science, doing an average degree like physical science somewhere else, right? Most probably soon after results, right? Not even waiting until university starts, soon after results, right? Most probably this is happening for 99% of affairs, right? ඔයාලා බලන්න right? ඒ හින්දා දෙන්නම එක්ක වැඩේ කරගන්න ඕනේ නැත්නම් දෙන්නම මොඩේ දෙන්නෙක් වෙන්න. දෙවැත්තම I mean either side works. මෙහෙම වෙච්ච ගමන් right? for sure this is going to break up. for sure ඒක තමයි that's a bitter truth. right? ඒක boy ද girl ද කියලා නෑ හොඳේ. මේක අනිත් පැත්ත උඩ තරම් වෙන්න පුළුවන් මැත්සල. normal ලා. එහෙම එකක් නෑ. මේක නැත්තම් එහෙම favorizations එතනත්. එහෙම එකක් නෑ. stereotypes. එහෙම නෑ. anything can happen. Anything can happen. right? So therefore be careful. because මේක කියන්න හේතුව දැන් මෙහෙම එකක් වුණාට පස්සේ දැන් මෙන්න මෙතන ඉන්න එක්කෙනා the victim say this one is taking the second side, right? ඊට පස්සේ දැන් මේ බූට් එකක් අරන් මේක දුවට ඉන්නවා තව මාස 3ක් විතර වැඩ කරන්න නේද? ඊට පස්සේ උඩ සෙකන්ඩ් එක කරගන්නත් බැරි වෙනවා. මේකද දැන් ඇත්තටම කරොත් නැත්තම් අවුලක් නැහැ මං කියන්නේ. ඇත්තම I mean if they were in a serious relationship, if something like this happens, no probably this one has to do the exam again, right? දැන් මෙහෙම කරන්න බෑ ඊට පස්සේ ගෙදරින් කැමති වෙන්නේ නැහැ. එහෙමනේ. right? කරන්න වෙනවනේ. ඊට පස්සේ until you are getting recovered, again you have to spend some more time. ඊට පස්සේ second try එක ඇත්තටම කරගන්න බැරි වෙනවා. ඊට පස්සේ third එකවත් තමයි කරන්න වෙන්නේ. නිකන් බොරුවට you have delayed 2 years of your life just because of this, right? Something like that. ඒ නිසා මේ I'm serious, the whole society is unfair. ඒක විතරක් මතක තියාගන්න. මම මේ කියපු එකේ whole society is unfair. whole society is unfair. එහෙම නැති තැනක් නෑ. තියෙනවා නම් මට කියන්න එහෙම එකක් නෑ. Okay, that's it. Remarks. Write down. Right. එහෙම කරකට මොනවද නෑ? කාටද මෙතන ඉන්න එක්කෙනෙක්ද? මේවයි. හරි. ආගන්න. හරි එහෙම වෙන්න තියනවා කියලා if you foresee, right? එහෙම වෙන්න තියනවා කියලා foresee කරනවා. Right? If you can predict that it is going to happen, shape එකේ break up වෙන්න. ඒක දෙන්නටම හොඳයි. මේ එතනින් එහාට මම මුත් කියන්නේ නැහැ. ඇත්තටම. Right? That depends, huh? That depends. මම මේ කියපු එකේ 1% එකක් තියෙනවා. ඒ 1% එකේ ඉන්න කට්ටියක් ඉන්නවා. They exist. මම කියවනේ 99% එකට මේක වෙන්නේ කියලා මම කියවනේ. 100% නෙවෙයි. This happens for 99%. 1% එකක් ඉන්නවා. හැබැයි ඔයා ඒ 1% එකේ ඉන්නවද කියන එක මම දන්නේ නැහැ. That's the thing. Right? ඒක මාරම rare. Right? Once we are going to university in the first year, right? Once we are going to university in the first year, මම නිකන් අපේ batch එක ගන්නකො. අපේ batch එකේ අපි whole batch එක ගමු 939. Right? Whole batch. Right? එනකොට සාමාන්‍යයෙන් 500 විතර affairs තිබ්බා. ඒ කියන්නේ මාර අහන එකට affairs. ඔක්කොම I mean both girls and boys affairs තියෙනවා. ඊට පස්සේ first semester එක ඉවරන්න ඕනෙත් නැහැ. first semester එක ඉවරන්න ඕනෙත් නැහැ. මේ ඉන්න set එකෙන් මෙච්චරක් විතර batch එකේ උන් එක set වෙලා. එහෙම තමයි. That happens. That happens. මේ මෙතන ඉන්න පොඩි set එකක් ඉන්නවා. හැබැයි අරක වෙනවා. ඒක වෙනම එකක්. campus එක ඇතුළේ ඒ කියන්නේ campus දෙකකට ගියොත් ඉවරයි. එක මේක හිටියොත් නම් ගොඩ. නැත්තයි ඉවරයි. Right? That happens මේ වගේ තමයි. ඒ කියන්නේ දැන් කිව්වා ඇති. ඒවට එක that happens. ඒතර මේකෙන් ගන්න දෙන point එක තමයි if you don't have an affair yet, right? Don't start one before the exam, right? exam එක කරගන්න. කරලා campus ගිහලා ඕන තරම් වහගන්න. ඕන තරම් ඉන්නවා. right? I mean for both ඕන තරම්. දැන් ඉස්සර මේ කතාවට කියනවා මොරටුවේ girls ලා අඩුයි කියලා මේ effect එකක්. ඒ කියන්නේ engineering ඉස්සර engineering විතරනේ ඉස්සර තිබ්බේ. දැන් එහෙම නැහැ හොඳ. දැන් මොරටුවේ ඕන තරම් ඉන්නවා. Architecture faculties තියෙනවා, business we have, medicine we have, IT. අර ඉස්සර කතාවට පරණ වයසායකයන් අහලා බැලුවොත් කියන්නේ මොරටුවේ මේ girls අඩුයිනේ කියලා. ඇත්ත in effect we don't have. මම දැන් මේ count එකක් ලියුවේ. From this there were only 200 girls. effect එක. This is the story in effect. medicine එකේ මේක අනිත් පැත්ත. right? medicine වල අනිත් පැත්ත. මේ engineering faculty මේ වගේ. That is true. That is true. ඉතින් batch එකේම set වෙන්න ඕනේ නැහැ. තව departments තියෙනවා, faculties තියෙනවා. ඊට පස්සේ ආගි එකත් එහෙමයි. ආගි is like 60-40 වගේ. ආගි එක 60-40 වගේ. right? මේ එහෙම තමයි. ඉතින් ඒ නිසා මේ එහෙමයක් නැහැ. Just wait until you go through the exam and then you can do anything that you need later on. Right? Remarks. Right. Remarks are the most important ones and they are not given in the guide. Okay, first one. Measure periodic time for measure periodic time for adi tips එක ගත්තා නේ තව ඉන්නවනේ යන්නේ මේ මට අර ඇන්ගල්ස් ටිකක් වෙනස් වෙන්න තමයි ඕනේ. ඇත්තටම මේ විහඟ ඉන්න දණේ දෙක ගන්න. ඒකයි මේ සයිඩ් එකෙන් ගන්න. right first one what is it? Measure periodic time for number of oscillations within brackets 20 or 25 measure periodic time for number of oscillations to maintain percentage error less than 1%. 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 Second point. Listen, you have to do only small oscillations. What's the reason? Only small oscillations. What's the reason? If oscillations are more larger, what happens is a considerable amount of energy is going to be lost as or converted as potential energy under gravity. Potential energy difference එක කාපු ගමන් ඉතින් ඒතොර ඒකත් මේක ඇතුළට ෆැක්ටර් වෙන්නේ නැහැ. MGH එකක් එනවනේ. A considerable MGH is coming. So therefore we have to avoid that MGH term as much as it's doable, it's possible, right? So therefore only small oscillations are considered, right? මේ වගේ oscillation එකක් consider කරොත් 1 meter වගේ එකක් එනවා කියන්නේ MGH is a considerable value, right? So therefore that total energy stored in this string is not going to be half kx squared. That will be half kx squared plus MGH, right? අන්න MGH part එක ආව තෙර එක, right? Second point, only small oscillations are considered. Only small oscillations are considered. Only small oscillations are considered because only small oscillations are considered because difference in gravitational potential energy, because difference in gravitational potential energy can be neglected for small oscillations. Next point. Even if the experiment is conducted successfully, you won't get a straight line which goes through origin. Instead, for the same point, going to get a y equals mx plus c graph. Because around one third of mass of string because around 1/3 of mass of spring. One-third of mass of spring contributes the motion. Within brackets in red, T equals 2 pi root m over k. T equals 2 pi root m over k. T equals 2 pi root m over k. T equals 2 pi root m over k is valid only for light springs. Is valid only for light springs. Is valid only for light springs. Right. Next point. Listen. Now, when you add more mass, this is coming down now. So therefore, accordingly, you have to change this locating pin as it is coming to the same point when you add the mass. Right? Once you are adding masses one by one, this goes down little by little. Right? So therefore, accordingly, you have to change this locating pin as well. Right? Next point. Change the position of locating pin. Change the position of locating pin. Cinematic moves done not the change the position of locating pin accordingly. Change the position of locating pin accordingly when change the position of locating pin accordingly when masses are added. Right? Now here also, now when you start the stopwatch, the countdown as we did before is also followed. Oscillations, right? 3, 2, 1, 0, 1, 2, 3, up to 25. Right? Next point. Start stopwatch. With a countdown as 3, 2, 1, as 3, 2, 1, as before, exact thing, as 3, 2, 1, 0, 1, 2, 3, up to 20 or 25. Within brackets, start stopwatch at 0. Next point. Fixing one locating pin. Fixing one locating pin at the bottom end of spring. At the bottom end of spring. Make it easier to count oscillations. 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 Right? Okay. So that's basically everything you should know about this. Fine. Any questions? Any questions? Online students? Anything to clarify? All good? Dinugi? Mata kana danno. Dinugi. Dinugi ini. Itu lazy. Striving no. Onet me. Berarti na. Onet ma. Onet me. All good? Dinuga. Everything is clear? Huh? Clear? Mau bayar lagi? Right. Ya kan? Desi teman. Desi nu. What? Desi nu. Clear? Set me there? Hmm? Right. Adisha? Are? Mayus, Adish? Right. Online ones. Quickly. Any responses? Quickly. No කියලා කියන්නේ ඒකද? Is it all clear up to this point? Now we have completed two experiments, right? There's nothing more to know about these experiments, right? Everything I have covered. Okay, all good. All right then. Break account and try कर लेने बोला. Try करो. Break account. We need a break. It's 10:08. Need a break? Kau kini gaman ne? Break account ada. Kisi gaman ne? Ogolan ne father? Hah? මම නිදිමතේ ඉන්නේ පොඩ්ඩක් බ්‍රේක් එකක් ඕනේ කියලා කෑ ගහලා කියන්නේ. ඔන්ලයින් එකත් කෑ ගහලා කියන්නේ. හා? ඊවන් ඔන්ලයින් ස්ටුඩන්ට්ස් ආම ගෙදර නිදි නැතුව තියා කෑ ගහන්නේ. ඕනද? සද්ද නමදී ඉතින් බ්‍රේක් එකක් දෙන්න තරම්. ඕන් නැද්ද? දැන් මං හයියෙන් කෑ ගහනවා උඹලා සෙට් එකට වඩා. ඕනද? Right. Okay, 10:10 now. We'll get a break of 20 minutes. නැද්ද? අදද නැත්නම් 30 minutes ඕනද? 30 minutes ඕනද? එතකොට දෙකට ඉවර ගන්න බැරිද? ඈ? 20 අදිනේ? 20 කිව්වම කොහොමද 30 වෙයිද? නෑ 20 වලින් එන්න ඕද? මේ 10 to 10:30 pm. Break 1. Break 1. Listen. Shh. Physical students. You can't go out the institute, right? You can't go out, and this room is allocated for dining, and everything is here. You can manage. After the camera, right? So let's break up and regroup at 10:30, right? Okay. ඒක ඉවරද? right. Okay. All right. We'll start. Okay. No. ඔන්න එන්න මේ ඉල තියෙනවා. ඔය ඔන්න අන්තිම දෙකම මෙතෙන්ට එන්න. සමහරවිට නැත්තම් කවයි බෝඩ් එක. ඔන්න එන්න. Right, listen. So I hope everyone from the online students are back. හරිනේ? හරි. Right. Let's start. Right, let's start. Practical 3. Practical 3. Write down. Write down. Determination of frequency of a tuning fork. Determination of frequency of a tuning fork. Determination of frequency of a tuning fork using sonometer. Determination of frequency of a tuning fork using sonometer. Right. Does it? So first, have you seen sonometers? Seen? All of you? Have you seen sonometer in the lab? All of you online? Have you seen sonometers at the lab? Sonometer is an instrument we have with a small box, and there's a point, actually 2 points to fix a wire, right? There are 2 points to fix a wire and hang a weight. A setup, right? Sonometer is a setup. Sonometer කියන එක අපිට හදන්න බෑ, right? It is something made. Sonometer එක තමයි ගන්න තියෙන්නේ. හදන්න පුළුවන් හිතුවොත්. I mean, otherwise it is something that you can purchase from a shop. Sonometers ගන්න පුළුවන්. ඒක අරගෙන තමයි experiment එක කරන්නේ. Right? Okay. First, write down materials and apparatus. Materials and apparatus. Materials and apparatus. Right. Write down one by one. First one, a sonometer. A sonometer. A sonometer. Then tuning fork with unknown frequency. Tuning fork with unknown frequency. Tuning fork with unknown frequency. Set of weights. Third one, set of weights. Set of weights. Within bracket 0.5 kilograms. Right? Right. Paper riders. I will explain what this is. Paper riders. If you don't know, I'll explain. Paper riders. Right. First, write down the list. Paper riders. A wire for sonometer. A wire for sonometer. A wire for sonometer. Meter ruler. Meter ruler. Then triple beam balance or electronic balance. Triple beam balance or electronic balance. Triple beam balance or electronic balance. Right, කාල වේලනේ ආවේ නිදා ගන්න එපා. ඉතින් නේ. හරි. This is what we do. Listen. මේ බලන්න මේක තමයි apparatus එක. Sonometer is, look at the board. Sonometer is something like this. Right? So here in the sonometer we have a box, a small box. මෙහෙම box එකක් තියෙනවා. දැකලා තියෙනවා කියවනේ. There's a small box. Right? මෙහෙම box එකක් තියෙනවා. Right? And sonometer wire is fixed to 2 points like this. Sonometer wire is fixed to 2 points like this. And here we have some setup fixed to keep a mass at the weight, simply to add the weight. Right? Sonometer box එකේ මේ holes එකක් තියෙනවා ඉතින්. මේ holes එකක් තියෙනවා ඉතින්. There are holes as well. So this is basically the sonometer. Right? What we do is මේ sonometer එකේ එනවා bridges කියලා එකක්. Right? Bridges means a small a small item like this that we can keep this underneath. Right? Underneath, right below the sonometer wire. Right? To adjust the vibrating length. To adjust vibrating length. හරිනේ? the vibrating length එක adjust කරන්න මෙහෙම පොඩි මේකක් තියෙනවා. මම ඒක මෙහෙම අදින්නම්. They are called bridges. They are called bridges. They are called bridges. Right? And then what we do is we are adding a weight here, adding a mass here. Right? Let's say now we are starting with 0.5 kilograms. Right? We are adding a weight here. Once a weight is added, let's say that added weight is capital M. Right? Then added mass is capital M, weight is mg. Say tension of the string is, sonometer wire is T. right? There is a single wire, so same tension remains throughout. Same tension remains throughout, right? And now we have a tuning fork of which frequency is unknown. We have a tuning fork of which frequency is unknown. Tuning forks, have you seen tuning forks? Have you seen? Have you seen? Tuning fork කියන්නේ මෙහෙම එකක්. ලැබ් එකේ තියෙනවා. වැස්සකට හරි ලැබ් එකට ගිහින් තියෙනවා නම් දැකලා තියෙන්න ඕනේ. ගිහින් තියෙනවද? ඒතර මේක තමයි tuning fork එක. It is something made with a given frequency. දැන් මේ experiment එක අපි ගන්න unknown එකක්. But usually what you have in your labs are a set of tuning forks. Box එකක් දැකලා ඇති. A box of tuning forks from somewhere around 512 or 1024 in descending order, right? 512 එකෙන් වගේ පටන් ගත්තොත් 512, 512, 256, 128, 64, 32, 16, 8 කොහොම set එකක් තියෙනවා, right? මේක තමයි tuning fork එක. How to vibrate the tuning fork? How this tuning fork is vibrated? කොහොමද vibrate කරන්නේ? දැකලා තියෙනවද? tuning fork එක මොකක්ද දැකලා තියෙන්නේ? කොහොමද vibrate කරන්නේ? Tell me, how to vibrate the tuning fork? Right? What's the way? What's the way that we are vibrating the tuning fork? Come again. Yeah? Come again. No idea. No idea. मैं experiment कर लेती ना. Right. Tuning fork එක vibrate करना. एक एक tuning forks වල මේ දෙකම තියෙනවා. With some tuning forks, listen. With some tuning forks, you are getting something called a rubber pad. Something called a rubber pad. You are getting with the tuning fork, a rubber pad, right? So what you should do is you can hit this tuning fork on the rubber pad, right? Once it is hit, it vibrates with the given frequency. That is one way of vibrating tuning fork. You have to hit this on the rubber pad, right? And the other way is, instead of the rubber pad, with some tuning forks, you are getting a rubber hammer. මේ දෙකම තියෙනවා, but this is more popular, right? So instead, you are getting a rubber hammer, right? This part is rubber, right? A rubber hammer, right? Rubber hammer එක තියෙනවා නම් fork එක අරගෙන hammer එකෙන් fork එකට ගන්න. Then it vibrates, right? So you can hammer the fork using this rubber hammer. Then it vibrates, right? Usually we use this. This is what most commonly available in labs, right? Rubber pad, right? Then once it is hit on the rubber pad, it vibrates. It starts vibrating, right? So what we do is this. Listen. Now, that vibrating tuning fork is kept in between the bridges like this. If it is kept in between bridges like this, at some point, right, on the box, it is kept on the box in between bridges, right? At some point, we can experience resonance. We can experience resonance. What is resonance? Last paper, what is resonance? Phenomenon of occurring equal frequencies, right? Phenomenon of occurring equal frequencies. So at one point, this will resonate, right? And we are starting the experiment with the smallest gap between these two, and we are going to make sure that we are not going to miss the fundamental frequency. Because if the fundamental frequency is missed, then we don't have any clue at which pattern you are. Right? If you miss the fundamental frequency, right, you can't get any clue regarding which pattern you are. So therefore, we have to make sure that we are starting from the smallest gap between bridges and increasing little by little. Then the very first resonance you are going to hear is the fundamental one. For sure. Is it clear? Fundamentally is the first one. Logic. Then we have to make sure that we are going to obtain the fundamental frequency, right? Now, if it resonates, which means frequency of tuning fork and frequency of wire are equal. Wire are equal, right? Now, you know this. If this wire vibrates, only one loop creates. Only one loop creates. In terms of lambda, one loop is, what can you say? One loop is lambda over 2, right? So let's say this length between these two bridges, length between bridges is L. Length between bridges is L, right? Then lambda over 2 equals L, right? Lambda equals 2L. Lambda equals 2L. Now my target is finding unknown frequency. Let's consider it as F. Finding unknown frequency. Since it is resonating, we know frequency of tuning fork and frequency of wire now are equal already. They are equal, right? Now we can apply an equation for wire. What is the equation for speed of a wave through a wire? Stationary waves. V equals, for wire, V equals root T over M. V equals root T over M, right? What is V? Speed of wave. Speed of wave. This equation is valid for solid mediums. Solid mediums. T, tension of string or wire. M, mass per unit length, right? Not a mass, mass per unit length. Mass per unit length. Mass per unit length. Mass per unit length is a constant. Listen, mass per unit length is a constant for a given wire, right? We don't know mass per unit length of this wire yet, but for sure we know there is a constant, right? So unless the wire is not changed, as long as the same wire is used, mass per unit length is a constant, right? And using the equation, we know we can expand this as, I'm going to expand as F lambda equals root T over M. But we know from the vertical equilibrium here, T equals capital Mg, right? Vertical equilibrium, T equals capital Mg. Then capital Mg over simple M is a constant. Lambda is here 2L, right? Lambda is 2L. Now F into 2L equals root Mg over M, right? I'm running out of space. First tell me, now what are we going to change here onwards in this experiment? What are we going to change? First, let's identify the constants and variables. What about F? Is it a constant or a variable? Constant, because you are using only one unknown fork, tuning fork. One unknown tuning fork. That's a constant. Right? What about L? L. Constant or a variable? It's a variable. It's a variable. It's a variable. That is why we are moving these bridges to adjust length. You have to move these bridges to adjust length. Right? It's a variable. Capital M? Capital M. It's a variable. Yeah. Set of weights. One weight is added here. Now you have got set of weights. Right? You have set of weights. So therefore, M is a variable. G is a constant. Simple M is a constant. Right. Now, what are we going to change now? Length or mass? Variables. Length is here. Length can gap between bridges and capital M, load, weight. What are we going to change? Weight. Right? Mass. Mass. When mass changes, see, when mass changes accordingly from the other side, L changes. Right? When mass changes, L changes. Which means respective lambda for the fundamental frequency changes based on the mass here. Based on the mass we put here. Right? Okay. There is a little bit more to explain. Before that, you haven't drawn the apparatus, right? Take this down. Apparatus. Apparatus. Materials and apparatus. This is the apparatus. Apparatus. Take it down. And this is something additional. If you don't know these things, something additional, right? know. How the way? I know. Okay, Parakula, I know that. Namadane. Madane. Argal ni kamo kina na yenu kaya. Ah, right. Na kita ambil ganda. Ekola hai na. Only the apparatus. Megaliya ne pa. Only the apparatus. Only the apparatus. Megaliya ne pa. And you can label this sonometer. Label sonometer. This one tuning fork. Tuning fork. Right. This one sonometer wire. Sonometer wire. Wait. These two are called bridges. These two. Bridges. Right. මේ sonometer එක box එකක් වෙන්නේ ඇයි මේකට holes තියෙන්නේ ඇයි ඔක්කොම කියලා දෙන්නම් මේකෙන් පස්සේ. Right, because we have two experiments from sonometers. Right, දෙකම කරලා මම sonometer එකේ I mean the general things you should know about sonometer I'll explain after both experiments. There are two experiments from sonometer and there are two more coming up from tubes. Right, ඔතනින් තමයි වැඩේ ඉවර වෙන්නේ. Finished? Okay. Now, the theory is this. Theory එකෙත් මට මෙතන තව part එකක් I have to write. Right. First, write down theory from here to here. There's more to write. I'm going to erase the board. Right. Write down the theory from here to here. Right. Write down the theory starting from here up to this point. Okay, now this is what we do. Now we have identified the independent and dependent variables already. We are going to change capital M. Then accordingly, from the other side, L is going to change, right? So therefore, my independent variable now is capital M and the dependent variable is going to be L, right? Always when we draw graphs in practicals, in experiments, first thing is we are giving the first priority for linear graphs, because the reason is after drawing a graph, we should be able to find or calculate intercepts and gradients. No? If you got a curve, gradient changes from point to point, then it is much difficult compared to a straight line to determine gradients. Therefore, always our priority is getting a straight line. That is why this equation is rearranged. Otherwise, if you draw the graph for ln root m, right? For ln m, not root m, ln m, you are going to get a curve, right? Where we can't find gradients easily, intercepts easily, right? So therefore, always we are plotting straight lines only, right? So as you are getting a straight line, you have to rearrange this, right? Nikan me rearrange karanne to get a straight line, right? To get a straight line, that is the easiest type of graph we have to find the gradient, right? Curves වල හොයන්න මාරාමාරුයි. Curves වල හොයන්න ක්‍රම තියෙනවා. You are getting curves in thermal physics. Thermal physics වල තියෙනවා cooling curves එහෙම අඳිනවා. Cooling curve එක කොහොමද curve එක? It's a curve. එතකොට ඒකට mirror එකක් use කරලා ඕන ගන්න. ඒක අමාරුයි. ගොඩක් අමාරුයි කියන්නේ. Point to point gradient changes, and to get the gradient of a point you have to use a mirror. Mirror method එකක් තියෙනවා. mirror එකක් use කරන method එකක් තියෙනවා. Right. So that's why I'm going to rearrange the equation, right? The rest is here. Look at the board. Now f times 2l, this is what I have got. F times 2l equals root mg over m, right? Square both sides. F squared 4l squared mg over m. Separate variables, right? L squared equals this is my variable. I'm going to separate capital M and keep the rest here. G over m 4mf squared. 4mf squared. Right. Now we are going to change this independent, and whatever it is as a coefficient, as a product, as a coefficient as a product with x is gradient, and L squared is going to consider as y. We have a straight line. If the graph is plotted between L squared and m, now you are getting a straight line which goes through center. You are getting a straight line which goes through center, right? Where gradient equals, now for gradient I'll be using m dash here onwards in this experiment, because simple m is already used for a different purpose, right? So therefore I'll be using m dash for the gradient, right? Because simple m is already used for mass per unit length, right? Then gradient of graph, gradient m dash of graph is g over 4mf squared, right? Now what are we determining here? What are we seeking? What are we determining? මොකක්ද හොයන්නේ මේකේ? මේ experiment එක මොකක්ද හොයන්නේ? Huh? As a term, tell me, what are we finding from the experiment? Frequency, f, subject f. Then f squared equals, see, f squared equals g over 4m dash. So f is root g over 4m dash. If gradient of graph is known, right? What else? If gradient of graph is known and mass per unit length of the string is known, of the wire is known, f can be determined. So therefore, we are seeking another data to be found, that is mass per unit length of the wire. That is why I gave you the triple beam balance and a meter ruler in the list of the materials, right? Then what we should do is, we are detaching this wire from the sonometer. We have to take it out from the sonometer and have to measure the length separately, right? Total length, because mass per unit length is mass per unit length is total mass over total length, right? Mass per unit length, total length total mass. For that, we can't keep it on the sonometer, detach it from the sonometer, and separately we can measure mass by keeping it on the triple beam balance or the electronic balance, and total length. Total mass or total length gives mass per unit length, and then it should be plugged here finally to find f, right? This is the theory. Understood? Clear? Okay, now start from here again and write up to this point, from here to here. Using rubber hammer, yeah, correct. I actually just saw now. Using rubber hammer is correct. Rubber hammer or pad, rubber pad. Okay, okay. Right. You can ask if any questions so far, right? Especially the online ones. Sorry. Kayaknya bantuin. Right. Okay, finished? Right. Now, write down below. Write down below. Since gradient of graph, since gradient of graph within brackets m dash, since gradient of graph within brackets m dash, since gradient of graph within brackets m dash, comma, mass per unit length of sonometer wire, mass per unit length of sonometer wire, mass per unit length of sonometer wire, mass per unit length of sonometer wire. And G, gravitational acceleration, G, are known values, if can be determined, are known values if can be determined, are known values if can be determined. Right. Then write down method. Write down one by one, right? One by one method. First point, add one weight to the pan at the end of the sonometer wire. Add one weight to the pan at the end of the sonometer wire. Within bracket 0.5 kg. Within bracket 0.5 kg. Adjust the length between second point, right? Mention everything in point form. Adjust the length between adjust the length between bridges to a small value and keep paper rider. What is a paper rider? That I didn't explain before. First write down monkey and keep paper rider at the middle of bridges on sonometer wire. At the middle of bridges on sonometer wire. Right? Right. Look at the board. Paper rider කියලා කියන්නේ මෙහෙම එකක්. කියන්න බැරුණා. Paper rider කියන්නේ මෙහෙම එකක්. A small piece of paper that is bent like this, something like this. A small piece of paper that is bent like this, right? A very small piece of paper that is bent from the middle, right? පොඩි මෙහෙම paper එකක් අරගෙන, right? Take a small paper like this, a small piece of paper, and bend it from here, right? එතකොට මෙන්න මෙහෙම shape එකක් එනවා, right? That is called a paper rider. And paper rider should be kept on the wire like this. Right? The idea of paper rider is this. Now, once the resonance starts, resonance is the vibration with the highest intensity, no? Maximum intensity. Maximum intensity means maximum amplitude. At the maximum amplitude, now when the wire vibrates, the wire may vibrate around. When the wire vibrates, at one point, paper rider goes out from the wire. It jumps out from the wire, right? Podi paper kakka. Having a negligible mass, a small, very small piece of paper. Podi ekak. Menna me wage. Something like this, menna me wage ekak. Peennet nathu. Meka thamai paper rider ekak kiyanne. Right? Then when it vibrates, this jumps out from the wire. That is how you are going to identify the resonance, the exact point of resonance. Because at the maximum vibration, at the maximum amplitude, it jumps out. Right? Okay, one sentence again. Just the length between bridges and bridges to small value and keep the wire. Right. Next one. Vibrate tuning fork. Vibrate tuning fork. And keep it. Vibrate tuning fork. And keep it. Vibrate tuning fork and keep it on sonometer box. Keep it on sonometer box. In the middle of bridges. Right? Next point. Gradually increase the gap between bridges. Gradually increase the gap between bridges until paper riders are until paper riders are suddenly jump off, until paper riders are suddenly jump off, from sonometer wire, suddenly jump off from sonometer wire, suddenly jump off from sonometer wire, and identify fundamental resonance, right? Next point, take the value of m, capital M, take the value of capital M, take the value of capital M, take the value of capital M and measure the length between bridges, at this instance, right? Okay, listen now. Now you have identified, we have already identified the fundamental resonance length for first mass, initial mass, and then you have to keep doing this, repeat this by adding masses 1 by 1, 0.5 kilograms 1 by 1, right? Now this is the respective length for 0.5, and then add another mass, then for 1 kg respective length, right? When mass increases, what happens with the length? That is here. When mass increases, length also increases. Okay? When mass increases from the equation, L also increases, right? From the equation. So therefore, that is why we are starting from a small value of bridges and then increasing gradually. Then you are increasing, right? Then only we can ensure that you are not going to miss the fundamental resonance, fundamental frequency, right? Right? If a question asks whether we can do the vice versa, starting from the from larger length and decreasing, we can't do because we can't make sure which resonance is heard at that point. We don't know. From the beginning side we can say, but from the other side we don't know. There's no end for the vibrations, right? That's the thing. Logic එක තේරෙනවනේ. හරිනේ? එහෙනම් මේ පැත්තෙන් මේක පටන් ගන්න ඕනේ. Okay. Then write down next point. Repeat the experiment. Repeat the experiment. By adding weights 1 by 1, and record values of capital M and L, in following table. Right? First, mass is in kilograms now, right? And L is in centimeters. For the equation we need L squared, right? L squared, then L squared square centimeters, right? minimum 6 values. Minimum 6 values. Right, take it down. Right. ගොඩක් අමාරු. අමාරු. ඒක තමයි. ගොඩක් කවුද? ජීවිතවල නේද? අර waves එන්නේ. Right? මේකයි වත්තු. එකයි නේ වත්තු. Listen. Now this time, I mean 25 A levels, the structure came from optics, right? If you have seen the paper, you should know. Structure came from optics, right? So most probably, next time you are going to get a structure from waves. Waves means you are going to something out of these 6, right? Which means this is a definite 5 marks now, right? 20 කියන්නේ, I mean out of 100, this is 5%, right? මේ 5% එකක් මේ එන්නේ, right? 5% එකක් එන්නේ. Most probably නෙමෙයි අත්‍තරම definitely next time it will be waves because last 2 times has been optics now, right? 24 25 දෙකම optics, 26 එකේ තවඩ waves එකක් එනවා, right? So therefore that is very important this time. I mean these experiments are very important this time, right? So by today itself, finish this all 6 experiments and you can refer later after 2-3 days again and make sure whether you have these things in mind and try few questions and finish this off, right? එතකොට මේ වැඩේ මෙතනින් ඉවරයි. Then when you are writing papers, definitely you will be writing these questions, no? Then you can keep that momentum. එහෙමයි යෝග වෙන්නේ, right? ඇත්තටම last paper එකේ මේ waves optics දෙකෙන්ම questions දෙකක් මම දැම්මා. ඒ දෙකම දැම්මනේ. ඒක optics question එක තමයි. ඒ කියන්නේ එකම question එක නෙමෙයි, I mean the same experiment came last time 25. මම දාපු optics එක. Determination of critical angle. Right? Okay. මෙතනනේ. Write down below. Write down below. Plot the graph between. Plot the graph between. Plot the graph between. Plot the graph between capital M and L squared. Capital M and L squared, and determine F and determine F and determine F as discussed in theory, as discussed under theory, as discussed under theory, as discussed under theory. Next point. Right. Okay. Put the graph between M and L squared and determine F as discussed under theory. Right. Next point. Next point. Next point. Detach. Next point. Detach. 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 Sonometer wire. Detach sonometer wire. Detach sonometer wire. Detach sonometer wire. And measure its length using meter ruler. And measure its length. And measure its length. And measure its length using meter ruler. And measure its length using meter ruler. And its mass using triple beam balance. And its mass using triple beam balance. And its mass using triple beam balance. Right. So below that point, write this down. Mass per unit length. Mass per unit length. Simple length equals total mass over total length. Right? Total mass over total length. Right? Mass per unit length is total mass over total length. Right. Right. Basically, from here the experiment is done. Right? Experiment is done. Mass per unit length if the mass per unit length is known, G is a known value. Right? Now M dash is the gradient from the graph, F is determinable. Right? So like that you can find F. Right? You can find F. Listen. Listen. Right? Listen. Now, didn't anyone get this kind of a question? That why we are doing this for 6 pairs of values rather than taking it at once from the equation? Because, see, now from here, right? Right? From here, if simple M is known, right? Mass per unit length is known. If this is a known mass, 0.5 kilograms at the start, right? G is a known value, right? L is a known value, right? Then only unknown variable here in the equation itself is F. Then why are we doing the graphical method without finding this at once using the equation? කරන්න පුළුවන් නේද? දැන් කිව්වම තේරෙන්න පුළුවන් කියලා දැන් කලින් තේරුණාද නේද? පුළුවන්. Just by using the equation. See? Just by using the equation. මම ආයෙ මෙතන ලියන්නද? Look at the board. මේවා තමයි දැනගන්න ඕනේ. මම මේ අහන ඒවා questions වල අහලා තිබ්බ ගමන් ඉතින් මේවා ලියන්න ඕනේ. L squared equals G over 4m f squared m. See? Now, when you are taking the very first instance, first resonance, right? First resonance itself, L is a known value. L is known, right? G is anyway known value. M is a known value, 0.5, right? And mass is a known value. Making hogan puluwan. 4 is a constant. Then f squared is determinable. F squared is determinable, which means f is known. Then why are we wasting time on a graphical method like this when we have this kind of a faster and easier method? What's the reason? Any thoughts? Online? Any thoughts? What's the reason? What is the reason? Why we are doing this for 6 times? For 6 different pairs of values. What's the necessity of going to graphical method? What are the reasons? But we don't do. What's the reason? Yes, accuracy. It's correct. Generally. How accuracy increases? This is the thing. Shh, listen. Accuracy is higher than using equation. Yeah, the reason is this. Exact reason is this. Accuracy, right? So at the end of the day, that is accuracy, right? So what happens here is, if we make the mistake while measuring LO, MO, whatever it is, right? When we find it using a single equation, the error we make is higher. But once we plot this on a graph, even if there is a mistake, that mistake is distributed. That is generalized. Right? To plot the graph, you are considering 6 points minimum, right? 6 points, you know. So therefore, you are going to get a line. If a mistake deviate in a point, then the line is not going to deviate. Right? Then points say මෙහෙම මේකේ ගොඩක් ඒවා points මෙහෙම ඇවිල්ලා නිකන් එකක් මේ වගේ ආවා කියලා මේක මොකක් හරි එකක් වෙච්ච එකක්. But still you can get the correct straight line. What the point? දැන් මෙහෙම error එකක් එකපාරින් කරනකොට උනනවා. You are going to make a huge error in the calculation. Right? So therefore always graphical methods are more accurate, because even if there is an error, errors are generalized and distributed throughout. So therefore you are going to get more accurate results when using a graphical method. That's why we are going for the graphical method, even if it is determinable just by using this. Right? So questions are now there. Right? Right. Then write down remarks. 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 Yeah, this is correct. Percentage error decreases when graph is used. That is correct. That is correct. That decreases because the errors are going to be generalized and distributed. That is correct. Good. Right? Write down. A graphical method is used. A graphical method is used. A graphical method is used to decrease, to minimize, to minimize, to minimize to minimize percentage errors, to minimize percentage errors, to minimize percentage errors when taking readings, when taking readings. Within brackets, errors are within brackets, for the same point within brackets. Errors are more generalized. Errors are more generalized and distributed in a graphical method, hence deviations are minimum. Hence deviations are minimum. Hence deviations are minimum. Right. Another thing, listen. To increase the accuracy, listen. To increase accuracy, we can take readings when increasing and decreasing both sides. I mean, now initially we are starting from the smaller value and increasing now. And then once all 6 values are taken, then we have a rough idea where you are going to get the resonance. And then you can do the experiment backwards again and find these resonance points again. එතකොට වරදින්නේ නැහැ because you already have value. දැන් පළවෙනි එකේ ආවේ say when you are doing the forward direction, you got 12.23 centimeters for a particular resonance. And when you are coming backwards also, you are going to something around no. මේකට 18 වගේ එන්නේ නැහැ. So therefore you won't going to miss. Right? So therefore, to more accuracy, yeah? To more accuracy, if you need to get more accuracy, we can do the experiment back and forth, right? In increasing direction and to the decreasing direction. And you are going to get 2 readings for L under each mass, no? In that scenario, then can get the average. Then it increases accuracy. Got the point? එහෙම කරනවා නම් මෙහෙම එන්නේ. Additional thing that we can do to increase accuracy, right? In that case, listen, in that case, right? In that case, you are going to get 2 values for L in these 2 directions, right? 2 values for L by conducting the experiment in increasing and decreasing directions and get the average value as L finally, right? That is more accurate. Not a necessity to increase the accuracy, right? Next point, write down. Next point. After taking readings, when increasing the gap between, after taking readings, when increasing the gap between, after taking readings, when increasing the gap between bridges, another set of readings can be obtained. Another set of readings can be obtained by decreasing the gap, within brackets conducting backwards, and get the average value of L, and get the average value of L for more accuracy and get the average value of L for more accuracy. Take this down quickly. Then our data table should be changed like this. Should be changed like this. Right. So basically that's it for that experiment. Any questions? Right. We'll quickly go through what is given in the guide here. About tunings, I'll explain everything after the second experiment of sonometer because they are common for both. That's it. Why is that? If the Y is corroded, then A changes. A because as V equals root T O M, T O rho N, when it changes, the error comes to this. මෙයාට error එකක් එනවා. ඒතර වැරදි. මෙයාට error එකක් එනවා. Because cross sectional area is not going to be uniform throughout the wire. ඒතර මෙතනින් error එකක් එනවා අනිවාර්යයෙන්. Even if you find mass per unit length, it is not uniform if it is corroded. Listen, that's a good question. Listen, if this wire is corroded, what happens is, so you know as V equals root T over M, this is equal to root T over rho N, right? If corrosion happens, A changes. When A changes, M changes. So therefore, M is not going to be uniform throughout the wire. M is not going to be uniform throughout the wire. And even if you find M by measuring using the meter rule and triple beam balance, this M is having an error, that is erroneous. So therefore, the value you are going to get here is ultimately and eventually that is wrong. Right? That's the impact. Finished? Right. About tuning, we'll explain after both experiments of sonometer. They come common. Right. Let's move on. How many questions now? Right. All good? Adish, all good? Right. Any other questions online? Is it clear? quickly. Let's move on. Right, let's move on. 4. Right, practical 4. Write down verification of the relationship between verification of verification of verification of the relationship between verification of the relationship between resonance length and frequency resonance length and frequency of wire and frequency of wire. Right, write down again materials and apparatus. Materials and apparatus. Materials and apparatus, right? Very much similar for the previous one. And here, listen, the difference is we are going to use a set of tuning forks with known frequencies, right? We are going to use set of tuning forks with known frequencies, right? Simply, you have to have a tuning fork box with you, right? Box again, usually in a tuning fork box, you have got 6 tuning forks, right? You have to have the box with known frequencies, right? Write down the materials and apparatus. First one, a sonometer. A sonometer. Set of tuning forks. Set of tuning forks. Set of tuning forks of known frequencies. 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 Next, tape riders. Tape riders. Next one, a weight. A weight. Next one, a weight. A weight slash load within brackets about 1 to 2 kilograms. About 1 to 2 kilograms. About 1 to 2 kilograms. A meter ruler. A meter ruler. A meter ruler. Right. See what we are doing. Now, the setup is also the same. Look at the board. The setup is also the same, more or less the same. See? These are the features. Right. Now, what we are doing is this. First, tell me whether the shortest resonance length, vibration length is going to be with the highest frequency, maximum frequency or minimum frequency. What's the relationship we know? That we already know. We are going to verify. We are going to verify. Is it a direct relationship or inverse relationship? Length and frequency. Inverse. That is an inverse relationship. Right? So therefore, minimum or the shortest gap between bridges is with the maximum frequency. No? We are starting the experiment with the maximum frequency. Right? So what we are doing is we are starting with the smallest gap. Look at here, more or less the same. Starting with the smallest gap and start vibrating the tuning fork with maximum frequency. Right? Start vibrating the tuning fork with maximum frequency. And we are doing the same thing we did before. Right? By vibrating this slightly gradually, you are adjusting the length between bridges until the paper rider jumps off from the wire. And that is where the resonance occurs. And that is definitely going to be the fundamental frequency. Right? Therefore, same logic. I'm not going to label here again. We have labeled before. So the theory is more or less the same now. We know this is lambda over 2 equals, let's say this length is L now, right? So lambda equals 2L and V is root T over simple M and V is F lambda, T is capital Mg over simple M, right? And F lambda is 2L root this, right? Now we are going to verify the relationship between F and L. No need to square. Purpose and no need to square, right? Now what are we going to change here? What are we changing? What are the variables? The variables here, F, is it a variable or a constant? F is a variable. Again, set of tuning forks in, right? F is a variable. That's the dekathiya. Right, F is a variable. Did you know? Adisha video ko tara video ko da. F is a variable. What about L? L. 2. 2. L. L is a variable. Capital M. Constant. G is a constant. Simple M is a constant. Then when F changes, L changes. Right? So independent variable is F or L. What is the independent variable? F. F. Sorry, F ne? F X karagan. Right? I'll do the rest here. Now independent variable is going to be F. That is what we are going to change with the set of tuning forks. Then accordingly L changes. Right? Then keep L on this side and 1 over 2F root Mg over M. Right? Alright. Now once set of values. See, 1 over 2 root Mg over M 1 over F. Right? Now 1 over F, this whole thing is going to be considered as X. The reason is to have a straight line. Otherwise, if L and F are plotted, there is an inverse curve. Right? Inverse curves. Then this is X. Whatever this is as a multiplier product with X is gradient. This whole thing is gradient. This is Y. Right? Now, if you plot the graph between, right? If you plot the graph between L and 1 over F, right? If this graph is a straight line which goes through origin, if this is a straight line which goes through origin, මේ අන්තිම ටික dotted lines අඳින්නේ. The reason to plot dotted lines here is, right, you are not going to get the curve up until here because you are starting somewhere in the middle, right, starting from 2 kg or 1 kg, right, somewhere in the middle මෙහෙම points එකක් එන්නේ. You are going to get some points like this and going to get something like this. Extend it and check whether it goes through the origin. If it goes through the origin, this is valid, which means this equation is correct. If the equation is correct, which means, right, ln f are inversely proportional. ln f are inversely proportional. If that is correct, right? If it goes through origin. Alright, මේක වැඩේ උතනින් ඉවරයි. පොඩි වැඩක්. Alright, any questions? You got a question? No? All good? Right. Then where did you stop? Theory clear? Examiner? මේක ඇන්දෙත් නැහැ. Take down the apparatus. Take down the apparatus and write down the theory until here, up until here. Write down. Any questions? All good. All good. කන්නෝනේ. That's it. All good. ඉවරයි. TV. පොඩ්ඩක් මොටිවේෂන් එකක් දෙන්න, ගැම්මක් දෙන්න කට්ටියත් එක්ක. අදීසි ඉන්නෝනේ. All clear? All good? And එහෙම වුණොත් මීටර රූලර් එක නෙමෙයි තියන්න පුළුවන්. ස්කේල් එකක් පින් කරලා අලවනවා. ඒක තමයි හොඳ වැඩේ. මේ හැබැයි වාට එකෙන් මේ මොනවද සිම්පල් ලෙම් හොයන්න බෑ. මේකෙන් ගන්න පුළුවන් the length between pitches විතරයි. අයි කැලලක් මෙහෙ හැංග වෙනවද? අරක මෙෂර් කරන්න පුළුවන්. ඒක එහෙම සමහරවිට ගන්නවා. ඒ වෙද්දි නෑ එහෙම ප්‍රශ්නයක් නෑ. ඒ කියන්නේ මෙහෙමයි. අතන අර පැත්තේ පොයින්ට් එකේ තියෙන්නේ ගැට ගහන රවුමක්. ඒ කියන්නේ පොඩි welding points නෙමෙයි, welded points නෙමෙයි. You have to tie it up. පොඩි ඇණයක් වගේ. ඒකේ ගැට ගහනවා. මෙතන තියෙන පොඩි පුලි එකක්. පුලි එකෙන් දානවා. එහෙම නැත්නම් වෙන එකට alternative එකක් නෑ. ඒකයි ප්‍රශ්නේ. ගොඩාක් කාලයක් කරද්දී වෙන්න පුළුවන්. වයර් එක බෙන්ඩ් වෙලා වයර් එකේ ඉලාස්ටික් ප්‍රොපර්ටිස් එහෙම නැති වෙලා එහෙම එරර්ස් වෙන්න පුළුවන්. ඒ අරෙන්න වෙන මේන් එරර් එකක් එන්න. ඒ කියන්නේ දැන් අර අතන ගැට ගන්න තැන වෙනස් වුණා කියලා ප්‍රශ්නයක් නැහැ. ඒක වෙනස් වුණොත් වායි ඒක ගලවලා මෙෂර් කරද්දී that is included no and the mass is already included. ඒ හින්දා එහෙම එරර් එකක් එන්නේ නැහැ. ඒ කියන්නේ significant එරර් එකක් එන්නේ නැහැ. All good? Alright? ඒත් එක්ක hina වෙවි ඉන්නෝ. Right? Why are the holes are in sonometer box coming up? Right. Finished? Arne? Huh? Oh. Take this down until up until here. Up to this point. My God. What that? Something is bad. Make it wrong. මොනවද මොනහරි හොඳ දැන් අනිතින්ට වලට කැම ගෙනල්ලා තියෙන්නේ ගෙනල්ලා තියෙන්නේ දැන් අරන් එන්න බෑනේ එහෙනම් ඉතින් ඩිලිවර් දාගන්න මේ උබ පික් මේ තියනවද ඉට්ස් නෑ උඹලට උබ දුවන්න බෑනේ නෑ අද බෑ පස්සේ ඈ පොඩ්ඩක් බලන්න මේ අතරම කැම ගෙනල්ලා තියෙන්නේ මම දන්නේ මේගොල්ලෝ නම් ගෙනල්ලා ඇති ගෙනල්ලා ඒ කියන්නේ ඉන්ටර්වල්ස් කීයකට කැම ගෙනල්ලා තියෙන්නේ කොල්ලෝ සාමාන්‍යයෙන් කියන අඩුවේ කීයකට කැම ගෙනල්ලා තියෙන්නේ දෙකක් වදි දෙකක් කන්න එහෙම කේස් එකක් තියෙන්නේ right හරි හරි තා පොඩ්ඩයි මේකෙන් පස්සේ බ්‍රේක් එකක් දෙනවා මේකෙන් පස්සේ බ්‍රේක් එකක් දෙනවා I'll be giving a break after this one right තා පොඩ්ඩක් ඉන්න finished okay write down the method before method මෙතන යටි ලියන්න ඕන finished write down below write down below write down below if the graph between 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 L and 1 of f L and 1 of f Adisha performance මදි ඈ L and 1 of f දැන් ආච්චි yes මේ සතියේ එක්ස්කියුස් එකක් තියෙනවානේ හැබැයි මට හැම සතියෙම වගේ තියෙනවා දැන් මේ පාර ටියුනල් එකේ ඊ වෙනකන් හිටියන්නේ මේක තමයි නැත්තම් එහෙම නෑ කොල්ලා මේ පෙට්ටියක් තිස්සුවද තනියෙන් ඉස්සුවද හරි හරි if the relation if the graph between L and 1 of f is a straight line if the graph between L and 1 of f if the graph between L and 1 of f is a straight line is a straight line is a straight line goes to origin the relationship write this down L inverse proportional to 1 over f the relationship L inverse proportional to 1 over f can be verified right okay method write down the method first point see now when you study these two experiments both of them sonometer now Only difference is in the first one, mass is being a variable and frequency is determined. Frequency is unknown. Here, frequency is known, right? And mass is a constant. Simply, in the first one, there's only one tuning fork which is unknown. And here, set of non-tuning forks. What is the difference? Method is same, right? Okay, first one. Set up sonometer, and suspend. Set up sonometer 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 and suspend. Wait to the free end of sonometer wire. Wait to the free end of sonometer wire. To the free end of sonometer wire. Adjust the gap between bridges. Adjust the gap between bridges. Adjust the gap between bridges to a smaller value. To a smaller value. And keep paper rider in the middle of bridges on sonometer wire. And keep paper rider in the middle of bridges on sonometer wire. Right? Second point. Vibrate the tuning fork with highest or lowest. Highest or lowest. Highest or lowest. Highest. Right? What is it? Vibrate tuning fork with the highest frequency. And keep it on sonometer box. And keep it on sonometer box. Next point, gradually increase the gap between bridges. Until paper rider is suddenly jumped off from sonometer wire. And take down values of F and L at this instance. F and L, and take down values of F and L, simple F and L at this instance. Right? Next point, repeat the experiment. To the descending order of frequencies of tuning forks. To the descending order of frequencies of tuning forks. And record them in following table and record them in following table. For 6 instances, L is in centimeters and frequency that is in hertz, right? And we need 1 over f, no? See, we are going to plot with the 1 over f, then 1 over f, 1 over hertz, 1 over hertz. 1 over hertz is actually equal to seconds, huh? That you know, because hertz means per second. 1 over hertz means seconds, right? And here, get these 6 values. Right, then next point, plot the variation of L against 1 over f. Plot the variation of L against 1 over f. Plot the variation of L against 1 over f. Plot the variation of L against 1 over f. Plot the variation of L against 1 over f. Next point, verify the relationship. Huh? Oh. Plot the variation between variation of L against 1 over f. Right? Last point, verify the relationship between L and 1 over f as discussed under theory. Verify the relationship between L and 1 over f as discussed under theory. What's the value of velocity of sound through air? What's the rough value, general value of velocity of sound through air? 300? Huh? Huh? 340, right? Rough value 340, right? 340 meters per second, right? But මේක දීලා sentence එක දීලා විනාඩි 2කට විතර පස්සේ තමයි අදිශරය per second උත් මේක මෙච්චර යන්න ඕනේ processing speed එක අවුල තියෙන්නේ එහෙම වෙනවා මේ මම මොකද දවසක් කිව්වනේ once we are lacking sleep, right? Now always මේ බයෝ ගන්නයි මේක මට වඩා හොඳට දන්නවා ඇති අහගන්න මේ always our brain has like practiced for a certain amount of rest with the lifestyle we maintain, right? ඒක habit එකක් වෙලා තියෙන්නේ. That's been a habit, right? If you are sleeping say 5 hours a day, then that 5 hours is it's needed. That 5 hours is needed, right? අර ඉඳලා හිටලා දවසක් මේ වුණා කියලා එහෙම අවුලක් නැහැ. හැබැයි එකපාරට listen 5 hours නිදාගෙන say you had to stay awake and sleep only 2 hours a day per week වගේ දවස් දෙකක් විතර යද්දි අර පොඩ්ඩක් අවුල් ඒ කියන්නේ process වෙන්නේ නැහැ සමහර දේවල් එහෙම වෙනවා ඒක fact එකක් it's a fact අර මේ අර කියන්නේ මේ දැයිලවල්ස් වලට එහෙම අහලා ඇති 25 batch එකේ අයට නම් මම කිව්වා 26 එකට තාම කිව්වද කියලා මට මතක නැහැ. 25 එකට කරපු academic session එකේ හිටියා නම් ඒක දන්නවා. මේ ඒ කියන්නේ exam එකට කලින් දවසේ අර පාඩම් කරලා නිදාගෙන ඉන්න නැතුව යන්න එපා කියලා කියන්නේ ඒකයි. හරි? මම ඔයගලන්ට වෙන මේ ක්ලාස් එක කියන්නේ නැතුව ඇති. ඔයගලන්ගේ exam ලඟ වුණාට පස්සේ කියන්න එහෙම ඒක මේ it's proved. ඒක researchers වලින් prove කරපු එකක්. just one day before the exam එනද හෙට exam නම් අද නිකන් පැය දෙකක් විතර නිදාගෙන නැත්නම් පැයක් විතර නිදාගෙන පාඩම් කරලා exam එකට ගියාට පස්සේ දන්නේ ක්ලියර් කරන්නත් බැරි වෙනවා. එහෙම සමහර විට වෙලත් ඇති already. right? term test හරි මොනවා හරි test වල. එහෙම වෙනවා. එහෙමත් තියෙනවා. because now there's a certain time of rest that is needed for our brain. That is needed. right? අපි ඒ rest එක දුන්නේ නැත්නම් brain takes the rest. අපි ඒක දෙන්න ඕනේ. අපි ඒ කියන්නේ brain එකට දෙන එකම rest එක නිදා ගන්න වෙලාව විතරයි. right? ඒක brain එක වැඩ. I mean that's a resting time. Resting time. brain එකට අපේ තියෙන the only time for our brain, human brain is the time we stay in sleep. right? During the sleep. ඒ හින්දා හැමයක් තියෙනවා. ඒතර අපි නිදාගත්තේ නැත්නම් දැන් exam එක ලියන වෙලාවට එතකොට මොනවද රෙස්ට් කරන්න ගන්නවා. ඒක තමයි වෙන්නේ. ඊට පස්සේ ලියන්න බෑ. ලියන්න බෑ. සමහරවිට හොඳටම දන්නවා මේ જાතිය ගාන කලිනුත් හදලා තියෙනවා කියලාත් මතකයි සමහරවිට අදා යන්න බෑ. එහෙම වෙනවා. that happens. ඔය A levels කරන අයට එහෙම මේ කොච්චර කරත් 18 hours වැඩ කරන අය ඉන්නවා. එහෙම කරත් පැය 4ක් නිදා ගන්න minimum 4 hours ඕනේ කියන එක තමයි finding එක. research finding එක. minimum 4 hours of sleep. minimum 4. උඹලා පැය 11ක් විතර නිදා ගන්න ඕනේ. ඒතකොට මේක අදාළ නෑ. ඉස්කෝලේ යන දවස් වලට. මේ minimum 4 hours of sleep. අර ඒක ගොඩක් කල් නැති වුණොත් ඒකේ consequences තියෙනවා. right. what do you give? ඉවරයිනේ? okay, remarks. write down. experiment ඉවරයි. experiment is done. if any questions you can raise. So under remarks, we'll discuss all other things about the sonometer and other things. Right, remarks. $340. Yeah. Remarks. Remarks. First one, write down. There are three methods. Of tuning. There are three methods of tuning sonometer wire. There are three methods of tuning sonometer wire. There are three methods of tuning sonometer wire. First one, right? So under that first one, there are three methods of tuning sonometer wire. Under that first one, tuning by hearing. Write down. Tuning by hearing. Tuning by hearing. Tuning by hearing. Listen. Anyone who have done or who is doing music? Another. Music. You? Tuning by hearing කියන එක කරලා තියෙනවද? දැන් ඒක මෙහෙමයි. මේක අහන්න රීසන් එක. මෙයා ඉන්න දිරු. මේ මියුසික් කරන අය දන්නවා. මේක මම කියන්න හදන්නේ. මියුසික් කරන අය දන්නවා මම කරලත් නෑ ඔය. මියුසික් කරන අය දන්නවා කියලා කියන්නේ ඒක. මියුසික් කරන අය දන්නවා. This is the most difficult method of tuning. You have to practice your ear to hear the sound properly and tune it. අර දැන් මොකක් හරි එක ටියුන් කරපු ඉන්ස්ට්‍රුමන්ට් එකක් තියෙනවා නම් ඒක වයිබ්‍රේට් කරලා අනිත් ඉන්ස්ට්‍රුමන්ට් එකක් ටියුන් කරන්නේ. ඔය ටීචර්ස්ලා කරනවා සමහරවිට. දැන් ඉතින් ඊසිලි ඇප් එකකින් ඔක කරන්න පුළුවන්. දැන් එහෙම ඇප් එකකින් පුළුවන් නේ. අරක කරලා තියෙන කට්ටිය දන්නවා. මෙයා දන්නවද? ටියුනින් බයි හියරින් දැකලා තියෙනවද? දන්නවනේ. අන්න ඒක තමයි මේ මෙතඩ් එක. ඒක මේකටත් කරන්න පුළුවන්. මේකයි කරන්නේ. මියුසික් කරන අය නම් කරන්නේ මෙහෙම එකක්. දැන් මොකක් හරි ටියුන් කරපු ගිටාර් එකක් තියෙනවා නම් වෙන ගිටාර් එකක් ටියුන් කරන්න ඕන නම් රයිට් සර් හරි මොකක් හරි අර ගහන එකක් අරගේ ගහලා අරක එයාට ඒ කියන්නේ ප්‍රැක්ටිස් එක තියෙන්න ඕන අහලා tuning by hearing you have to hear the sound properly from both and tune it. Here what we are doing is you have to get used to the sound of the vibration sound of the wire and tuning fork. And adjust this length until you hear the same sound from both. Tuning by hearing. Right? A possible method, but not that easy. Lazy. Right? Music කරනවා මම කියපු එක දන්නවා අනිත් අර කියලා දෙන්නේ කරන විදිය. මේ ඒක අයිඩියා එක ඉතින් මේක කරන්න දෙන්නේ this is a given frequency no. මේක vibrate කරනවා මේක vibrate කරනවා ඒ sound එකට පුරුදු වෙන්න ඕනේ. For the vibration and then this is adjusted. Right? Write down tuning by hearing මේක ඉස්සරහට යන with a dash write down. Vibrate tuning fork. Vibrate tuning fork. Vibrate tuning fork. And hearing the sound and adjusting the gap between bridges 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 until same sound is heard from both right. Second one tuning by beats. Okay, what is beats? Beats, difference between frequencies, right? So we will hear the difference as intense sounds, no? Right? Beats as intense sound we hear, right? So if we vibrate say 250 hertz and 256 hertz, you will hear 6 intense sounds. Intense sound gaps hayak kehna. Ting 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 gala hayak kehna. Right? Intense sounds. Now here what we are doing is, now once these two are vibrated together simultaneously, we'll hear beats. And you have to adjust this until no beats are heard. Because at that point only, frequencies are equal. Right? Beats decreases. And at one point, beats are going to be vanished. There is a point where it is tuned to this frequency. Right? Okay, write down. Vibrate tuning fork and sonometer wire simultaneously. 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 And adjust the gap between bridges until no beats are heard. Adjust the gap between bridges until no beats are heard. Third one, tuning by resonance. Tuning by resonance. Right? This is what we did here. Right? Paper ideas still we're not going to explain. Tuning by resonance. Right. Then next point, write down. As the next point, write down. Function of sonometer as an amplifier. function of sonometer as an amplifier. Function of sonometer as an amplifier of sound, and as an amplifier of sound, as an amplifier of sound. Right. What's the meaning of amplifying? Amplify. Amplify can work? Huh? Increasing. Right? Developing, increasing. Amplifying can වැඩි කරනවා කියන එකනේ. Right? මෙයා කරන්නේ මෙහෙම එකක්. හරි. Now, when the sonometer wire is vibrated, since it has only a very small area, right? It is not going to transfer energy that much, and you are going to hear a very lower intensive sound, right, from the sonometer wire. So therefore, holes are made in the sonometer, and then the air column inside, the gas medium, air medium inside the sonometer, right? Gas medium inside the sonometer also starts resonating with the wire itself. Then both wire and the gas medium vibrates together. Then it amplifies the sound, and we can hear more intense sound. Right? So that is how the sonometer box works as an amplifier. That is why holes are kept. And this is the exact same thing that is done in a guitar. Guitar එකේ හිලක් එක්ක මේකක් තියෙන. Same thing. නැත්නම් ඉතින් string එක නිකන් ගලවලා vibrate මේ ගහලා බලන්නකො. සද්ද එන්නේ නැහැ. string එක නිකන් ගලවලා කියන්නේ මේ නැත්නම් අර මේක වහලා ගහලා බලන්න. දන්නවද? ඒ music එක නෑ. මේ මැද තියෙන hole එක වහලා play කරලා බලන්න සද්ද එන්නේ නැහැ. Right? කන පම්බියට තියලා අහන්න ඕනේ එහෙම සද්ද එන්නේ. Exact same thing. guitar එකේ තියෙන එකම තමයි මේකේ කරන්නේ. So in the guitar also, guitar එක දැකලා තියෙනවනේ. bass guitar වලද කොහොමද නෑ? bass guitar වල නෑ නේද? මොකද අර box එක තියෙන එකේ උදේ අර electric කියන්නේ bass guitars නෙමෙයි. box එක තියෙන දන්නවනේ. එච්චර පෙන්වන්න දෙයක් නෑනේ. guitar එකක් කොහේ හරි දැකලා තියෙන violins, guitars වල මොනවා හරි මෙන්න මෙතන මෙහෙම එකක් තියෙනවනේ. මෙහෙමනේ wires ටික තියෙන්නේ. Nice. Exact same thing. මේක empty box එකක්. Okay, write down. First point. Make under first bullet point. The rate of emitting energy. The rate of emitting energy. Write down. The rate of emitting energy by sonometer wire is lower. Hence, intensity of sound. Is also lower. Next bullet point. Therefore, holes are kept. In sonometer box. Holes are kept in sonometer box. To resonate with sonometer wire simultaneously. To have more intense sound at resonance. Right. So then make a what's the type of wave on sonometer wire? What type of a wave is on sonometer wire now? The waves දෙකක් තියෙනවා ඒකයි. What type of wave on sonometer wire? Huh? Complete answer then. Transverse or longitudinal? ඒ දෙකෙන් කියන්න මුලින් transverse or longitudinal? transverse, right? Wires. Y එකේ තියෙන transverse and progressive or stationary. Wires stationary. So therefore, wave type on sonometer wire is a transverse stationary wave. A transverse stationary wave, right? And wave type on sonometer box, inside sonometer box, is transverse or longitudinal? Yeah, medium. Huh? Longitudinal, right? Stationary or progressive? Stationary, right? Waves දෙකක් එන්නේ. And the wave that we hear this resonance is what? අපිට ඇහෙනවනේ දැන් මේක. What kind of a wave is that? Longitudinal, progressive, right? So ඒක පොඩි දේවල් ඉතින් දැනගෙන ඉන්න ඕනේ. Okay, write down next point. Next point. Type of wave on sonometer wire. 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 Transverse stationary. Transverse stationary wave. Stationary transverse, correct. Transverse stationary wave. Right? Next point. Type of wave in sonometer box. Type of wave in sonometer box. Type of wave in sonometer box. Longitudinal stationary wave. Longitudinal stationary wave. Break it. Yeah, no. Right. Listen. Next point. Next point. Right. අපිට ඇහෙන එක මං කිව්වේ නෑ. දැන් ඒක මතක තියාගන්න ඕනේ. Right. The wave type ඕන්න ලියා ගන්න. Wave type that we are hearing the sound is a longitudinal progressive wave. True yeah. Right. දැන් මං කතා කරන්නේ ඕගලන්ට ඇහෙන්නේත් ඒකකින්. Right. මං කතා කරන්නේ ඕගලන්ට ඇහෙනවනේ. Right. Online එකට ඇහෙන්නේ කොහොමද? ඕගනත් question එක මම වෙලා ඉදි කරා. කොහොමද එන්නේ? ඒ transmission එකේ තියෙන මොන wave එකක්ද? රේඩියෝ එන්නේ රේඩියෝ එකකින් ඇහුවොත්. ඒක electromagnetic wave එකක්. That is electromagnetic. Radio TV range එකේ වගේ තමයි තියෙන්නේ. රේඩියෝම කියලා කියන්න බෑ. That's an electromagnetic wave. Right? ඒ කියන්නේ මේ connection එක, wireless connection එක electromagnetic. Right. Next. The other thing is the reason to keep the tuning fork on sonometer box is to transfer more energy to sonometer box and wire. Right? Now, if you are tapping the desk like this, right? If you are just tapping the desk using a finger, desk tap karano, right? But if you keep your ear on the table, that is audible, no? Anne wagaya. Right? Can you langin tibbot hondra heno? Natham meheme ekak. When example like you say we are doing a vibration somewhere here and doing the same vibration on this kind of a solid medium, right? Solid medium එකේ sound එක propagation එක වැඩි, energy transfer එක වැඩි. ඕක තමයි reason එක. Right? එයා medium එකේ තියා හිටියොත් energy transfer එක අඩුයි පොද sonometer box. box එකට යන transfer එක අඩුයිනේ. ඒක එයා medium එකේම damp වෙලා යනවා. අරගේ උඩින් තිබ්බ ගමන් it damps on sonometer box and wire. That's the reason. එතකොට මෙයාට හොඳට energy එක හම්බ වෙනවා. From this energy transfer is high, then it vibrates with higher amplitudes. නැත්නම් මේක vibrate වෙන්නේ නැහැ. මේක කළා බලන්න පුළුවන් ඇත්තටම කරද්දී. නෑ. tuning fork එක vibrate කරලා මේ හරින් වගේ තියාගත්ත කියලා මේක vibrate වෙන්නේ නැහැ. Right? That's the thing. Okay, next point. Write down. The reason to keep tuning fork on sonometer box. The reason to keep tuning fork on sonometer box. The reason to keep tuning fork on sonometer box is to have a higher rate of energy transfer. Have a higher rate of energy transfer. Higher rate of energy transfer. And energy absorption to sonometer box is also higher. Energy absorption for sonometer box is also higher. Next point. Should start the experiment with the highest frequency, with the tuning fork with highest frequency. Should start the experiment with the tuning fork of highest frequency to ensure fundamental resonance is heard. 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 Then I will tell. To ensure fundamental resonance is heard without missing it. Right. That's all. Any questions? Okay. Online students? How are you doing? All good? Sleepy? Busy? Right? May break account. 12:15. 20 minutes. And one more thing. May then 12:50 ගන්නේ 1:10 අපි start කරන්නේ. 2:30 වගේ කියලා කියන්න. Right? එක කියන්නේ 2:30 කියලා කියන්න. 2:30 වගේ කියලා කියන්න. 3 නම් යන්නේ නැහැ. 2 වලට නම් දැන් අමාරුයි. 2:30 වගේ. Right? 2:30. Right. May let's have the break from 12:50 to 12:48 තාම 12:50 කියවමු. 12:50 PM නෙමෙයිනේ. to 1:10. 1:10. Right. Be comfortable. Online, physical, හැමෝම be comfortable කියලා කියන්නේ I know this is hard but just 2 more remaining. Right? ඒ දෙක කරා නම් මේ වැඩේ මෙතනින් ඉවරයි. එතනින් ආයි waves වැඩේ ඉවරයි. Right? Just 2 more remaining. right මේ මොනවා හරි පුළුවන් නම් hot drink එකක් බොන්න try එකක් දෙන්න coffee එකක් bread එකක් ඔන්න coffee එකක් වගේ පුළුවන් නම් හොඳයි right regroup in 20 minutes Right. என்ன வணங்க Right. Am I audible now? Okay, we'll start. Right. Coming. Am I loud and clear again? പറഞ്ഞേ kayak dia nggak udah nih Hah? මේ දෙකත් එක වගේ සොනමීට වගේ තමයි එකක් පුළුවන් කියන්නේ දෙවෙනි එක පුළුවන් වෙනවා එකම විදිහේ මගේ එක්ස්පෙරිමන්ට්ස් එක right write down practical 5 determination of determination of determination of velocity of sound determination of velocity of sound using a closed resonance tube using a closed resonance tube using a closed resonance tube and a tuning fork and a tuning fork and a tuning fork and determination of n correction of tube and determination of n correction of tube and determination of n correction of tube and determination of n correction of tube. Okay, Write down materials and apparatus. Materials and apparatus. Materials and apparatus. List down. First one. A tall jar. A tall jar. A tall jar. A tall jar. Right? Second one, glass tube. Right? Make a glass වෙන්න ඕනේ metal කියලා කියන්නේ copper tube සේන සමහරලාට labs වල that is also fine. Right? Glass tube or metal tube, glass or metal. As metals, mostly copper tubes are there in labs. Right? Anti-corrosive no copper එක තියෙනවා. මේ නැත්නම් මේවත් තියෙනවා. මොනවාද? brass කියලා කියන්නේ. ඔව් පිත්තල ඒවත් තියෙනවා. Right. Next one. A meter scale. A meter scale. Or you can say meter ruler. A meter scale or a meter ruler. Tuning fork of non-frequency. Tuning fork of non-frequency. Tuning fork of non-frequency. Of non-frequency. And some water. Set square. A thermometer. Rubber pad. Supporters. And some cotton or sand. Some cotton or sand. Some cotton or sand. Some cotton or sand. Right. Look at here. Listen. So first, look at the board. First, we have to fix this tube. Fix this tube like this on a stand, on a supporter, on the stand. Right? And this is a tall jar which is filled with water. Like this. The jar is filled with water. Make it lazy. Burn. The jar is filled with water. Right? And now we have tuning fork, no? Tuning fork of non-frequency with a rubber pad, which means we are going to vibrate the tuning fork and keep this here at the top of the tube, near to the main axis or the center axis on the tube, right? To give a better transfer of energy, right? To give a better transfer of energy, right? And we are starting from the shortest possible length, starting from the shortest length. To make sure, first we are going to catch up the fundamental frequency, right? And tell me, this is a tall jar. This is a tall jar, and this is the tube. Both ends open tube. Supporter. Then meter scale should be fixed here, right? Usually අපි මේ tube එකකට fix කරනවා, right? මේ එළියේ තියෙන tube එකට. So likewise, this meter scale can be fixed. Like this. Then very easily readings can be taken. This is the meter scale, right? Tuning fork that you know already. And water is added here. Set square එක මම මොකද්ද කියලා කියන්නම්. And thermometer is used to check temperature. මේක ඇතුළෙම check කරන්න ඕනේ නැහැ. atmosphere එකේ check කරත් ඇතියා. to check temperature එක මා දින්න දුන්නා. And rubber pad එක ඕනේ supporters, and cotton or sand is used to put here. Right? ඒකේ reason එක මොකද්ද කියලා කියන්න. Right. First take this down. Apparatus එක. Shall we use resonance tube rather than a glass tube? Same. Resonance tube කියලා කියන්නේ metal usually, right? දෙකම මම mention කරන්නේ glass tube or metal tube. This supporter is an adjustable one, right? මොකටද කියලා මම කියන්නම්. This supporter is an adjustable one. This is adjustable. Apparatus is this. Okay, finished? Write it down. And now we are starting with the shorter length. No? We are starting from the shorter length. Tube is immersed. And we are going to slightly increase this height of the tube until the first resonance is heard. Because this is adjustable. Starting from a shorter length. Which means we are going to ensure that the fundamental frequency is heard at one point. Right? So until then, this tube can be adjusted. Adjusting means this can be moved on the supporter like this, up and down, right? Down move karna because we are starting from the shoulder's length and increasing the length now. Make increase karna. Once this tube is moved upwards, what is happening with the height here, which is open to the gas medium? By the way, now if one side of this tube is dipped in water, immersed in water, tell me how this tube is going to work from the tubes you know. What are the tube types we know? Both end open, both end closed, one end open. Right? Then, कौन में tube बेटा बेटा करने हैं? Tube is both end open, but now one side is blocked by water. Then it acts as one end open. Right? It acts as one end open. That's the purpose of using water here. Right? The purpose is blocking one side of the glass tube. Right? Closing one side. When one side is closed, this is going to act as a one end closed tube. This is going to act as a one end closed tube. Right? Then you have to adjust this length until the first resonance is heard. Then at one point, we are going to hear the first resonance. And at the first resonance, we know that is a fundamental frequency. At fundamental frequency, this is what you are going to obtain. This is what you are going to obtain as a pattern. Right? And let's consider end correction of this as E and length from here to here as L1 for the first scenario. And then, now the first resonance is heard, no? We know definitely the second resonance is going to hear if, now this is only lambda over 4. If another loop is added, one loop is lambda over 2, one loop is lambda over 2. Then you have to take this upwards until more space is created here to add the next loop. Right? Make it by adjusting the supporter from the supporter. This can be moved. Right? You can release the nut and you can move this upwards. When it is moved upwards, what happens is the height of the tube, which is above the water level, increases like this. The height of the tube, which is above the water level, increases like this. Right? And at some point down the line, we are going to hear the next resonance. And that is a consecutive resonance after the fundamental. Then it must be the first overtone. Right? Second harmonic, first overtone. It must be the first overtone. First overtone of a one and closed tube is a non-one. Right? Then that is going to be like this. That is going to be like this. Right? For the same tube, there is same V under same conditions. These are different length, let's say L2. Right? So likewise, these two are the occasions we are going to find now by adjusting the length, by increasing the length. Right? Clear? Take this down too. And it's better if you can have some space here to write lambda and apply the equation. To write lambda and apply equation. Adish. Thank you. Write down as theory and take it down. That is better. Write down as theory and take it down below. Apparatus name, right? Write down as theory and take it down. And now we know that this is the first resonance. Make it clear now? First resonance. And this is the second resonance. First resonance and second resonance. First resonance and second resonance. First resonance and second resonance. So if anyone confused, this is also called the resonance tube generally, right? This is also called the resonance tube generally, but resonance tube is either glass tube or metal tube. That is what it should come in the material list, right?
One end open, yes.
Yes. These two occasions are two known occasions, right? First resonance and second resonance. See? Considering the first and considering the second, considering the first and considering the second, දැන් අදි චරවුලන්නේ නැනේ. දැන් ඇස් දෙක ඇරිලා. කලින් ෆ්ලැට් නේ. දැන් ගොඩක් රවුම් වෙලා. හය වෙනකන් අවුලන්නේ නැහැ. පහ වෙනකන් ඉඳියා පහට නේ ගියා. හරි. finish. හරි. Okay, first resonance. See? For the first resonance, wait the board. This is half of a loop. One loop is lambda over 2. Half of a loop is lambda over 4. Right? First again, for the first resonance, then lambda over 4 equals L1 plus E. Right? Lambda over 4 equals L1 plus E. Right? Which means lambda equals 4 times L1 plus E. Right? Okay, I'll consider this as equation 1. For the second resonance, right? Here we have 3 half loops. 1, 2, 3. 3 half loops. One half loop is lambda over 4. Such 3 total length is L2 plus E. Right? Then here lambda equals 4 times L2 plus E over 3. We'll label this as equation 2. Right? Okay. Now hereafter, we can do the calculation at once. See? And one thing, this is not a graphical method. From the experiments we have, I mean, out of all 38 we have now, right? There are only very few number of experiments without graphs, right? This is also one graph fact, no graph. Usually an experiment is followed by a graph, no? But here there's no graph. Same experiments, you know, around 7, 8, right? Very few number. In all 38. Make up. Not a graphical method. We have two equations. We know V equals. What about this? Gas mediums. V equals. What is the equation? Speed of wave through a gas medium. Longitudinal wave through a gas medium. Stationary. Root gamma RT over M, or else you can say gamma P over O, right? Now, gamma is a constant. What is gamma? Ratio between specific heat capacities. R, universal gas constant. T, temperature, absolute temperature. Now, until the experiment is carried out, temperature is constant. It should be constant. We have to keep it constant. To check whether temperature is constant, we have a thermometer here. Thermometer gatte ekai. To make sure that temperature is constant during the period that you are conducting the experiment. So we have to keep it constant. And M, molar mass, right? So same air medium is used in both cases. Molar mass is also same. Which means ultimately V is same. V is same in both, right? Velocity of sound through air is same. Gamma is a constant, R is a constant. We have to keep this a constant, and this is also constant because same gas medium is used. Same gas. The මේ room එකේ කළා වෙන room එකක ගිහිල්ලා ඔක් කරොත් වැරදි. Right? එහෙම බෑ. It can change. එකම තැනනේ කරන්නේ. All the setup is here at a single place, single space. Same. So V is same. V is constant. But we know V is F lambda. No? V equals F lambda. Now V is a constant. V is being constant. V is being constant. What about F? Are we changing the tuning fork or same tuning fork is used? How many tuning forks we have now? How many tuning forks? Then kiyat තියෙනවද? How many tuning forks we have now? Huh? How many tuning forks? Tuning fork of non-frequency, right? Only one. Only one. Only one. Then tuning fork is also same in both scenarios, which means frequencies, it's resonance, no? At resonance, frequency is equal. Frequency is also same. If frequency is same, lambda is also same, which means these two lambdas are same. That's why I didn't use lambda 1, lambda 2. Lambda is same. Lambda is same. Right? තේරුණානේ? Okay. මම මේකේ logic එක මොකක්ද කියලා වෙනම දෙන්නම්. This is what I used. නෑ මෙතනම දෙන්නම්කෝ. Take it down. මේ දෙක ලියාගෙන. නැත්තම් මෙහෙම ලියාගෙන. මේ line එකේ ලියන්න. V is F lambda. F lambda is root gamma R T over M. Right? Write down. T is constant, M is constant, F is constant. Then lambda should be constant. Take down from here to here. This is the logic behind it. Alright? No, make a common. This is not on the first one. This is common, no? This is common. This is not under the first one. This is a common part again. A common part. First and second එක මෙතනින් ඉවරයි. ඔයගොල්ලෝ කවුරු හරි දැවිලාද? ඔයගොල්ලෝ කවුරු? Right? මම මේකේ points එක දෙන්නම්. මේ square brackets දාලා තියෙන constants වලට. Right? Sambil. Okay, write down below. Write down below. Since temperature, since capital T temperature, capital T, since temperature, molar mass, and frequency, remain same at both instances, remain same at both instances. Lambda should be same. Right? Okay, now if lambda is same, 1 equals 2, no? Lambda equals lambda. Look at the word. If lambda is same, lambda equals lambda. 1 equals 2. From 1, you can say lambda is 4 times L1 plus E. And this side, 4 over 3 times L2 plus E, right? Simplify this and subject E. Simplify and subject E. 4L1 plus 4E equals right, this cancels, then 3L1 plus 3E equals L2 plus E, right? 3E plus 3 minus E is 2E. 2E equals L2 minus 3L1, right? E equals L2 minus 3L1 over 2. So here we have E. Here we have E, which means n correction is known because L1 and L2 are known values. L1 and L2 are known values. Since L1 and L2 are known, n correction is known. Just a calculation. Right? We can easily get the reading of L1 and L2 using the scale here, the fixed meter scale here. Since L1 and L2 are known, E is known. Right? Now E is done. E is done. Right? Write down. And then the next part is determination of V now. To determine V, I'm going to consider this equation from here itself. Label this equation as equation A and label this equation here as equation B. A and B, right? Because the purpose is this: to find V, F is known. To find V, lambda should be known. To find lambda, E should be removed, right? E එක ඕන්න plug කරලා ගන්න පුළුවන්, but we are going to remove E because the whole purpose is minimizing errors. Like E එක හොවත් error එකක් වුණා නම්, then it comes to the calculation. It will be factored in the next calculation. So therefore, always we try to cancel them off. If these two are from B minus A, if these two are subtracted, E cancels. Then lambda comes, right? Just playing around with the equations, no graphs, play around with the equations. B minus A, 3 lambda over 4 minus lambda over 4 equals L2 plus E minus L1 plus E, right? 3 lambda minus lambda is 2 lambda. 2 lambda over 4. 2 lambda over 4 equals L2 plus E minus L1 minus E. E to E cancels, right? 2 lambda over 4 is lambda over 2. So lambda equals 2 times L2 minus L1. Lambda is known. 2 times L2 minus L1, lambda is known, right? If lambda is known, it's done now. Apply V equals F lambda, right? We'll write here. Then apply V equals F lambda. F is a known value, then V can be determined. Shall I erase here? Write down up to that point. Lambda is known now. Lambda is known. Lambda is 2 times L2 minus L1. Lambda done now. If figure done, that's a known tuning fork. Right? Where you right? Using V equals F lambda. Right? V equals F is a known value and lambda is 2 times L2 minus L1. So V equals 2F L2 minus L1. V can be determined. Right? Write down below. Since L1, L2, since L1, L2, and F are known values. Since L1, L2, and F are known values, both E and V, both E and V, both E and V, both E and V can be determined. Both E and V can be determined. Both E and V can be determined. Right? That's it. Right? මේකේ තියෙන බලන්න මේකේ තියෙන V හොයලා. Right? මෙහෙම හදන්නත් පුළුවන්. Now in the guide what is given is doing the same after finding V. V හොයන්න නැතුවත් කරන්න පුළුවන්. දැන් මම කරේ V හොයන්න නැතුව. Right? If V is determined, V is also same no? Right? V එක same නම් we can do the same thing by equating V. Right? ඒක මේකේ තියෙනවා. මේකත් බලන්න. Right? Lambda එක හොයාගත්තා. Then apply V equals F lambda. Then you know two V's at two instances. Same thing, huh? Same thing. But V one node na. No need to find V because we can argue as V is same. So does lambda is same. Right? That was my argument. Both are fine. මේක තව step එකක් ඇහිඳ වැඩිපුර ගිහිල්ලා තියෙනවා. Because V is determined. Both are fine. Right. Answers are same either way. Answer එක වෙනස් වෙන්නේ නැහැ. හොඳේ එහෙම වෙනස් වුණොත් එහෙම වැඩේ වැරදි. Answers are same either way. Right. හරිනේ? So let's mention the method. Write down method. මේ theory එක දැන් මෙතනින් ඉවරයි. Theory is finished, then method. First point. Immerse the tube. First point. Immerse the tube. Immerse the tube in tall jar. Immerse the tube in tall jar filled with water. Immerse the tube in tall jar filled with water. Second point. Vibrate tuning fork. Vibrate tuning fork. Vibrate tuning fork. Keep it above the open side of tube. Keep it above the open side of tube. Keep it above the open side of tube. Close to center. Close to center. Close to center. Next point. Gradually raise the tube by adjusting supporter. Gradually raise the tube by adjusting supporter. Gradually raise the tube by adjusting supporter until first intense sound is heard. Until first intense sound is heard. First intense sound is heard at fundamental resonance. Until first intense sound is heard at fundamental resonance. At fundamental resonance. Next point. Take the respective length of tube. Take the respective length of tube. Take the respective length of tube above water surface. Above water surface. Within brackets L1. Within brackets L1. L1 using L1 using meter scale. Using meter scale. using meter scale. Right? Next point. Raise tube further until the next resonance, intense sound के लिए until the next intense sound is heard at next resonance, until next intense sound is heard at next resonance, within brackets first overtone, Next point, measure the respective length within brackets L2. Next point, conclude the values of length within brackets L2. Right, last point, conclude the values of E and V, E and V, velocity of sound through air. Right, conclude the values of E and V as discussed under theory. Okay, listen. Now from here, experiment is done. Right, experiment is done. There are a few more things as remarks to be given. Any questions about the experiment before moving on? Ask something? No? Any questions? Online? Make lazy. Make lazy. What do you think? Any questions? Clear? Right. Then write down as remarks. First point, tuning fork should be kept. At the center line, at the center axis of tube, just above the tube, just above the tube, within brackets perpendicularly, perpendicular to axis. Perpendicular means perpendicular to axis. I have drawn perpendicular to axis. For better energy transfer. Next point, before that, take this down. This is exactly how it should be placed. Come on. How about that? කතා කරන්නෙත් නෑ. ඔය මොනා හරි කාලා බීලා ඉන්න හොඳේ තව චුට්ටයි. Last ones. මටත් ඉතින් වාඩිලා හිටියොත් ඉතින් තේරෙනවා. මම මෙතන කෑග් ගහ හැම යන හින්දා ඉතින් මෙතන. What about online? You are awake, right? පොඩ්ඩ ආයෙ පොඩි වෙනවානේ. හරි? Right, finished? හරි අතන second point. Write down second point. Second point. Three resonance lengths. Three resonance lengths. Three resonance lengths. Three resonance lengths can be obtained. Three resonance lengths can be obtained for a given instance. For a given instance. For a given instance. For a given instance. And for a given instance and average value of all three, an average value of all three can be considered as L, can be considered as L for better accuracy. For better accuracy. Right. See, another important thing. Now, when this wave hits with this water surface, right? This is an air medium. This is a water medium, right? Now this wave, the stationary wave here, hits with the surface. No? The surface hits with the surface, right? In terms of waves, tell me. One wave phenomenon is going to occur. What is it? Huh? Refraction. Refraction is happening because this is hitting with an air medium, with a water medium. Air medium එකේ තියෙන wave එක water medium එකත් එක්ක collide වෙනවා. Right? Then some part of the wave, right, is going to refract through the water surface, through the water medium, right? And it is going to go up until the bottom. මම මෙතන අඳින්න. එබා now this is going to refract. Just say මේ wave එක යනවා මෙතෙන්ට යනවා. ආයෙ නතර වෙන්නේ නැහැ. And it is going to මෙතනත් ආයෙ එකක් වෙනවා. මෙතන මොකද වෙන්නේ? මෙතන මොකද වෙන්නේ? Now from here this is refraction. At this surface refraction. Due to refraction it goes into water medium and then it travels through water medium and reaching the bottom. At bottom what happens? Huh? Bottom में होता है. How many medium? How many media are involved? Only one at the bottom. Only one, no? Then what's happening? Reflection. It reflects, right? To minimize reflection and actually avoid reflection, a small piece of cotton or sand is used, right? මේ මේක මේ wave එක මෙතන vanish වෙනවා. නැත්නම් මේක ආයෙ අනිත් පැත්තට එනවා. මේක ඇවිල්ලා මේ පැත්තට refract වෙනවා. ඊට එන කරදරනේ මේ wave එක impact එක. මේ පැත්තෙන් ඇවිල්ලා මේ ආයෙ refract වෙනවා. Right? That's why either cotton or sand is used. Right? Cotton තමයි හොඳම. Cotton තමයි හොඳම. ටක් ගාලා absorb වෙනවා wave එක. Absorption එක වැඩි. Right? තේරුණානේ? Next point. Write down. Next point. To avoid the reflection of refracted wave through water medium to avoid the reflection of refracted wave, to avoid the reflection of refracted wave through water medium. At bottom, some cotton or sand is added to bottom. 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 Right? Next point. Variation of temperature during the experiment. 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 Should be checked using thermometer. Should be checked using thermometer. And there shouldn't be any variation. Okay. See, one more thing. Now, since this is a water medium here, since there's a water medium here, right? Air medium around the tube, I mean inside the tube, and here around here is a little bit saturated from water vapor, that is vaporized from this tube, right? We can't stop vaporization, no? So therefore, compared to this normal atmosphere, water here, air medium here is a little bit saturated with water vapor because of the water surface here, right? නිකන් මේ වගේ එකක් උදේට notice කරලා තියෙනවා නම් ඔය fog වෙන, ඒ කියන්නේ mist එක බාන වෙලාවල උදේට තියෙනවනේ in the mornings, right? More close to water reservoirs, paddy fields, right, streams, there's more mist compared to buildings and other infrastructure. ඒක notice වෙලා තියෙනවනේ. ඔය දැන් කිරියල් ඉඳන් හිමෙද්දි හොඳට බලන්න පුළුවන්. වෙලවල් පහුවෙන ටිකේ දිගටම මේදුම තියෙනවා. හැබැයි ටවුන් ටිකේ නෑ. ඇත්තට බලාගෙන ඉන්න නිදාගෙන නිදාගෙන දෙන්නේ. බැල්ල පිටින් ඉඳන් යද්දි පුළුවන්. වරනේ. තල්ගහවිල පාරෙත් අර වෙලමැදිරිකේ යද්දි පුළුවන්. Right? Just notice it. Right? So in the mornings usually when dew forms, right? උදේට බලනවානේ. Around like 6 to 7 වගේ හොඳට බලන්න පුළුවන්. Around 6 to 7 okay, 7:30 8 වගේ වෙනකන් තියෙනවා. Around 6 to 7 you can notice it, right? On top of water reservoirs and paddy fields or water saturation එක වැඩි areas තියෙන. Paddy fields, water reservoirs, right? Lakes වගේ තියෙනවා, lakes, tanks, maybe rivers, right? Mist is more higher, right? More fog is there, more mist is there compared to the road. ඔන්න road එකේ බලන්න, road එකේ නෑ දෙපැත්තේ හැබැයි වෙලේ තියෙනවා. In the paddy field you can see හැබැයි යන පාරේ අඩුයි compared to paddy field. Reason එක අරග. ඒක ඔක town එකට වගේ ආවම හොඳට බලන්න පුළුවන්. Right? Buildings වල ඇත්තම නෑ. ඒතර water vapor වැඩි නම් vaporization එක වැඩි. When vaporization is high, forming mist is forming fog is also higher. ඒක වෙන හැටි thermal වල තියෙනවා. Right? ඒක ගොඩක් explain කරන්න නෑ හින්දා. ඒතර මෙතනත් point එක ඒක. Compared to the other surroundings, this is more dense with water vapor. This area is more dense with water vapor, right? When water vapor is mixed with air, what can you say about density of air inside this compared to that of outside? මෙන්න මේක density එකට මොකද කියන්න පුළුවන්? Density of air inside the tube. Is it greater than atmosphere or less than atmosphere? Water vapor is mixed with the air now. more water vapor is mixed because of this. Higher, right? It is higher. So with that, what happens is, we know V is gamma P over rho. V is gamma P over rho as gamma RT over M, right? When density increases, when density increases, V decreases. Therefore, you are going to get a value little bit less than the actual value of speed through air, right? You are going to get a value a little bit less compared to the actual value, right? For that, there's a precaution. Precaution in the sense there's a alternative method, not a precaution, alternative method, right? Instead of using a tube like this, right, a piston can be used. Labs වල ඒක නැහැ, right? But there is an alternative option. එතකොට හරිම value එකක් ගන්න පුළුවන්. A piston can be used. Piston කියන එක දන්නවනේ. Instead of that, a piston like this. මෙන්න මෙහෙම piston එකක් use කරන්න පුළුවන්. With an arm. And moving this part, this length can be changed, right? No involvement of water. Therefore, in here, accuracy is high. There is another, what we call next step of the experiment. If you are taking this experiment to the next level, right? Make a කරන්න පුළුවන් වැඩක් using a piston. But usually in schools we don't have, right? Okay, next point, write down. Next point. Since density of air medium inside tube is a little bit higher compared to that of outside, a lesser value for V, will be obtained. A lesser value for V, lesser in the sense slightly less, around 328, 30, 32, a lesser value will be obtained, right? Take this down. Make a logic here. This one, this equation. Take this down. Right, below that, write down a piston can be used, right? After this one, after the equation, a piston can be used. Piston done නැත්නම් piston එක අතට ගන්න. This is called a piston. A piston can be used instead of this setup. A piston can be used instead of this setup to eliminate that error. Instead of that setup, this setup, to eliminate this error. Right, and one last thing, the reason not to use a graphical method here, right? Even though graphical methods are more accurate, right? Even though graphical methods are more accurate, right? Errors are distributed. We don't use a graphical method here. Can you think of any possible reason not to use a graphical method? Any idea? Online? Any possible reason not to use a graphical method? Any possible reason not to use a graphical method? Anything? Listen, one thing is now if you are going to a graphical method, we have to have minimum 6 values, no? Right? Then this should be increased up to fifth overtone. හරිනේ 6 values ගන්නවා fifth overtone එකට යන්න ඕනේ. Right? Then a very high length of tube is needed. Right? Then lambda over 2 ගානේ from each resonance it should be increased by lambda over 2. Lambda over 2, lambda over 2. Then when you continue it for 5 overtones, 6 instances, right? The required length of the tube is very high, right? And it takes more time, right? And the other main thing is when the wave pattern increases, overtone number increases, intensity of sound decreases, right? Intensity of sound decreases. Therefore, we are not going to hear the resonance clearly as we hear in these two, right? The most intensive sound is the fundamental, and when we move up, intensity decreases. So reasons දෙකක් තියෙනවා not to use a graphical method, right? Last point, write down reasons not to use a graphical method. 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 First one. First one. First one. A very high length of tube is required. A very high length of tube is required. A very high length of tube is required when taking minimum 6 readings. When taking minimum 6 readings within brackets up to fifth overtone. Within brackets up to fifth overtone. Within brackets up to fifth overtone. Up to fifth overtone. Second one, second reason. Intensity of sound decreases when intensity of sound decreases when overtone slash harmonic. When overtone slash harmonic increases. Hence, for the same point, hence, resonance could not be identified properly. Hence, resonance could not be identified properly. Hence, resonance could not be identified properly. Right. Okay, that's it. And we are moving on to the last one. Right? An easy one. Okay. මේක ඔක්කොම basics ටික මම කතා කරා. I mean basics are here. Setup එකත් same. An easy one. Right. So what about the condition? පොඩ්ඩක් කියලා ඉන්න පුළුවන්. Right? All good? Right. Online? Online set හොඳයි. මම හිතුවේ break එකෙන් පස්සේ බඩු වෙනස් වෙයි කියලා. දාලා නිදිද දන්නේ නෑ දාලා නිදියන්න ඕනෙත් නැහැ ඉතින් කොහොමද YouTube live එක වැඩුත් නැහැ එහෙම නිදාගත්තේ එහෙනම් ඉතින් off කරලා නිදාගන්න හොඳ data තියෙන්නේ කොහොමද ඔක තියෙනවා මොනවද online are you awake all good මේ ඉන්නවා කට්ටිය this is greater than yes good right let's move on practical 5 may 6 last one for the day last one for the day. Six. Okay, write down materials and apparatus. Materials and apparatus. Materials and apparatus. Right? put a point, and write down same as previous. Same as previous. Same as previous. Right? Apparatus again. Draw the apparatus again. No need to label. That is also same. Right? Draw the apparatus again. Calculation is different. Right? Draw the apparatus. No need to label. Draw the apparatus again. This one. Same. That is same. Huh? Calculation is different. That's all. That's the calculation. Didn't I write the heading? Write down determination of practical 6 determination of velocity of sound through air, and incorrection of tube, using set of tuning forks. Using set of tuning forks. Right? Using set of tuning forks. Only difference is in the previous one we used only one tuning fork. Here we are going to use set of tuning forks. Right? Sonometer right? Both goes together. So even though there are 4 experiments, right? Just knowing about 2 is enough. Right? This is a very few difference. Right? Fork then set of tuning forks. Right? The theory is this. Okay, here, look at the board. Now we have a set of tuning forks. And going to start with the highest frequency, because highest frequency is going to give the smallest length, no? Right? Starting with the highest frequency. And repeat the same as we did before. And at one point, you are going to hear the intense sound, no? Right? At the intense sound, at the very first time you are hearing the intense sound means you are at the fundamental resonance. And let incorrection be E and length at this point is L. Right? Then we know, right? At this point, lambda of O equals L plus E. Lambda equals 4 times L plus E. Right? Apply V equals F lambda. Right? And V equals F lambda. Lambda is 4 times L plus E. Right? Then what are the variables and what are constants? What about V? V, variable or constant? It's a constant. It's a constant. F? Adish, F. Constant or variable? Variable. So, Hari, L is a variable now, because when frequency changes, who is going to change from the other side? It is L. E is a constant. That is same for a given tube under given conditions. Right? Then what are we going to change manually? That is F. Tuning fork set. So we are going to change F. Then F is going to be the independent variable. L is going to be the dependent variable. Subject L. V of OF equals L plus E. L equals V over 4 1 of F minus E. This is our X. And this part which is as a product of X is gradient minus this is a constant intercept, right? And this is Y, which means we are expecting a Y equals mx minus c curve. right? We are expecting a y equals mx minus c. Expecting a y equals mx minus c. Let me write the rest here, right? Now, the expected curve is here. Curve is between ln 1 over f, right? mx minus c. No need to draw the minus side. Use dotted lines. mx minus c, right? mx minus c, where c is my point agone. That's an important point. This point is minus e, no, right? This point is minus e, and gradient of graph and gradient m of this graph is v over 4. Gradient of graph is v over 4. Right? It's theory class, paper class, නෑ අදීස නෑ යනවා බලන්න අපිත් එහෙනම් ක්ලාස් නවත්තලා වණ ගෙදර එන්නද ඈ කාලෙකින් බණ මතක් කෑවේ නෑ හරිද finish no then finish it okay finish it optics එකක් කරමුද ඈ එළියට ගිහලා optics කරන්න ඕකේ හතක් වගේ තියෙනවා අවුලන්නේ හරි finish see now gradient of graph is මෙතනින් වැඩේ ඉවරයි gradient of graph is v over 4 so v is 4 times gradient right ඒක හරි and intercept of graph is right minus intercept is minus e no so intercept is e right e is no right which method is more accurate what do you think the previous one දැන් කලින් ගියේ මේ දෙකම right දෙකෙන් මෙහෙව එකම දේ right same things were determined using this experiment and the previous one right which method is more accurate this one is more accurate right because this is a graphical method right okay write down gradient is v over 4 make gradient මම මෙතන introduce කරා v is 4 times gradient and intercept is e එතනින් වැඩේ ඉවරයි graph එක හතුවාම ආයෙ මොකුත් calculations නැහැ හරිනේ write down below since gradient and intercept of graph is known 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 v and e can be determined v and e can be determined V and E can be determined. V and E can be determined. Right. Okay, theory is finished. Then write the method. Method එකේ ඇත්තම කලින් එක වගේමයි. කලින් එක වගේමයි. There's a small difference. Same කියලා දෙන්න බෑ. නැත්නම් දෙනවනේ. There's a small difference. අරක වගේම තමයි. More or less the same. Right? So එකක් මතකයි නම් මේකේ පොඩි change එකක් තියෙනවා. Right? Same කියලා දෙන්න බෑ. ඊට පස්සේ මට තමයි වැරුණා මේ පාඩම් කරලා ලියන්න ගිහිල්ලා ප්‍රශ්නෙකට. Right, write down method. ඇයි මේක tuning fork එක දැන් වෙනස් කරන්න ඕනේ? Right? Tuning fork එක වෙනස් කරන්න ඕනේ. හා? ඔය ඒක විතරයි. ඒක ඉතින් ලස්සනට ලියන්න බෑ නැත්නම් ඉතින් same කියලා ලියලා tuning fork එක වෙනස් කරනවා කිව්වහම අවුල්නේ වැඩේ. හරිනේ? හරි හරි. First point method. Method. First point. Immerse tube inside. Immerse tube inside. Water in tall jar. Water in tall jar. Water in tall jar. And gradually increase vibrating length. Gradually increase vibrating length. Gradually increase vibrating length by raising the tube until by raising the tube until an intense sound is heard for the first time. An intense sound is heard for the first time. An intense sound is heard for the first time. Right? Next point. Note down කියන්නේ point එකේ. Note down the respective frequency of tuning fork. And length of tube at this instance and length of tube at this instance. Oh, I missed one thing. Higher scale given any? Third point, next point, Mike. Yeah. Next point. Repeat the experiment from highest frequency to repeat the experiment from highest frequency to lowest frequency, from highest frequency to lowest frequency in set of tuning forks, and record the values in the following table, right? Length is measured in centimeters, right? Then frequency in hertz, 1 over frequency, because we need 1 over frequency to plot here, 1 over hertz. right? Next point. Plot the variation of L. Plot the variation of L. Plot the variation of L. Plot the variation of L against 1 over F. Plot the variation of L against 1 over F. Plot the variation of L against 1 over F. Next point. Determine V and E. Determine V and E. Determine V and E using gradient and intercept of graph. Using gradient and intercept of graph. Using gradient and intercept of graph. Using gradient and intercept of graph as discussed under theory. As discussed under theory. Using gradient and intercept of graph as discussed under theory. Right? Okay. Practical number 7. Right. Listen. Listen. In this last page, I have put the years where these questions have appeared. Right? So all of you got either classified structured essays or a past paper book, no? Right? So what you can do is you can find these questions and try them out. Right? Before you forget this, before you forget this. Again, the mega ඊළඟ ටර්ම් ටෙස්ට් එකට ලං වෙලා කරලා වැඩක් නැහැ. හරිනේ? එතකොට ඉතින් අවදලා තියෙන්නේ. මේ questions ටික මෙතන ඔක්කොම දාලා තියෙන්නේ. කරලා බලන්න. Right? It's better if you can do it using the classified one. Classified එක තියෙනවා නම් ඉතින් හොඳම ලේසි. ඒතර මේක ඕනෙත් නැහැ එතකොට. If you got the classified one. Classified pays through structured essays. Right? ඒකේ කොහොමද තියෙනවනේ. Right? For others, anyway, I have mentioned the years here. Right? එතනින් ඒක බලා ගන්න පුළුවන්. That's it. And if you are not in the channels, you can access the channel using this QR here. Right? If you are not in the channel. Right. Listen now. Any questions? Any questions? 2 minutes. Any questions? From any experiment? From any of the experiments that we discussed today? Anything? All good? All good? What about you? Is it all clear? Huh? Online? Online? 2 minutes, 2 minutes. Online? Any questions? Or is it all clear? Clear. Right. Clear. Right. Okay. We managed to end this at 2:35 now. මම ඇත්තටම හිතුවේ 3වත් වෙයි කියලා. ඔයගොල්ලෝ ඉතින් අර දක්ෂයින්ද හොඳයි ලේසි ඉක්මනට ටක් ගාලා කරන්න පුළුවන්. Right. Listen. Now, since you know all 6 experiments here under waves, right? Questions කරන්න ඕනේ. Questions කරන්න ඕනේ plus you are going to get questions from these ones, right? Plus optics උත් මම දානවා in coming up papers, right? These questions will roll up in coming up papers. ඇත්තටම මම දැන් හෙට discussion එකෙත් මේ එක question එකක් තියෙනවනේ first එක තියෙනවා. හරි? හෙට එකේම තියෙනවා. ඒ කියන්නේ that you have already written, right? ඒකත් හොඳයි. ඒතකොට දන්නවනේ මොනවද කරලා තියෙන්නේ කියලා. but ඒකේ පොඩි මේ modified part එකකුත් add කරලා තියෙන්නේ හොඳේ. මේ උඩ මෙන්න මේ string එක මේකක් වට යනවා කියලා කතාවක් තිබ්බනේ. එහෙම කරන්න හොඳ නැත්තේ කියලා එහෙම අහලා තියෙනවා. එහෙම ඒ කියන්නේ හොඳ නැත්තේ කියන්නේ ඒක why it's not suitable වගේ මොකක් හරි question එකක් අහලා තිබ්බනේ. දැන් ඒකට answer එක දන්නවා. ඒක හිට බලමු. Right. So likewise, I mean, you can try the past papers here, and I will also add more questions from these ones in coming up papers. Right. So you also can try them and check whether you are comfortable with this, right? අත්‍තරම mechanics practicals වල වඩා මේ practicals ටික lazy. එහෙම නැද්ද? optics වල වඩාත් lazy. අර mechanics වල වඩා lazy නෑ කියන්නකො. optics වල වඩා නම් කොහොමත් lazy. thermal වල වඩාත් lazy. waves කියලා කියන්නේ in terms of experiments kind of a manageable part. අත්‍තරම manageable. ආයි ගිහිල්ලා බලන්න එතකොට තේරෙයි මේකේ එහෙම ලොකු දෙයක් නෑ කියලා. There's nothing here. හයක් තිබ්බට sonometer එකෙන් දෙකයි. තොර ඒ ඔක්කොම sonometer. That is all about sonometer. අර set of frequency මේ set of tuning forks and one tuning fork කියන එක විතරයි වෙනස් වෙන්නේ. And two is from tubes. එතනින් හතරක් ඉවරයි. ඊට අනිත් එක spring and pendulum. අතරම මේ හයි lazy. Right? So go through again and make yourself comfortable. Right? Because we are only 33 weeks ahead of the exam. Right? 33 weeks. Days වලින් ගත්තොත් I haven't counted 200 බල දෙනවා කවුරු නේ? ඒ වගේ 235 වගේ නේද? Something like that. මම weeks සාමාන්‍යයෙන් බලන්නේ තව ලඟ වුණාම තමයි days බලන්නේ. 33 weeks now. Right? Now we have to plan for August now. We don't know. For August, if the exam is on August, only 33 weeks. Right? And listen, about optics. Now, about optics, the next practical seminar is also coming up. Right? Mankiwan, other seminars coming up are optics, thermal, and current electricity. මේ තව තුනක් තියෙනවා. Right? And they will also come in the coming months. Right? Updates වලට නම් channel එකෙන් ඕන එකක් ගන්න පුළුවන්. Now, if you need to join optics or other coming up practical seminars also, you can keep in touch. Right? ඉඳලා ඒවට join වෙලා කරගන්න කොහොමවත් free කරන්න. හරි මේ විදියම තමයි. Right? I can't say now whether it's going to be a day seminar or a night seminar. That will check with the availability. Now this time also I was planning for a day seminar. You know the story. Right? I was planning for a day seminar and it was planned for the last week of November. Right? And had to postpone due to flood disaster. That's why I had to pick this time. This is also the first time I'm doing a night seminar, a physical one actually. Physical night seminar like this. For practicals, first one, seminars කරලා තියෙනවා discussions, not practical seminars. Right? Now, participation is good. That's a good thing. Let's see how we can do the optics one. All other three are coming up. ඒ ටික ටිකක් ළඟ ළඟ set වෙයි. Probably I'll be planning the optics one around end of January or February. End of January or first weeks of February. ඒ වගේ තැනක තමයි plan කරන්නේ. Let's see. Right? ඊට පස්සේ somewhere around April, by the end of April or somewhere around April ගොඩක් වෙලාවට. Right? Thermal. And around the end of May. Right? Most probably electricity. වගේ rough plan එකක් තියෙන්නේ. Right? That's my timeline. That's my plan for now. Right? Let's see. All right. All good, no? Right. Then we'll wind up. 228 days. Right? Days බලන කට්ටිය ඉන්නවා. I didn't see. Thanks. 228 days. මම around 230 කියලා. ඒ වගේ තමයි යන්නේ. 33 weeks, something like that. හරිනේ? Not a big time. 228 days කියලා කියන්නේ එහෙම ලොකු එකක් නෙමෙයි. නිකම්ම යනවා. Because now New Year එක අමතක කරන්නකො. After Sinhala and Tamil New Year, වෙසක් පොසොන් ඒ season එක තමයි ඉක්මනට යන්නේ. මේ ටික නම් එහෙම ලොකුවට celebrate කරන්නෙත් නැහැ. අර 3 months එහෙම ටක් ගාලා යනවා. ඒක තේරෙන්නේ නැහැ. Right? ඔන්න අවුරුදු කියලා නැගත් කරනවා. ඊට පස්සේ වෙසක් එකට තොරණක් දැම් බලනවා, වෙසක් කුඩු හදනවා. පොසොනුත් මොකක් හරි අර 30 පස්සේ ගිහිල්ලා මොකක් හරි කරනවා. එකපාරට ඕගස්ට්. ඒකයි වෙන්නේ. මේ කල්ලා බලන්න නෙමෙයි. ඉඳලා බලන්න. එහෙම වෙනවා. So therefore 228 කියලා කියන්නේ එහෙම ලොකු ටයිම් එකක් නෙමෙයි. Right? Okay. So prepare yourself and don't waste even a single minute nowadays. Right? Every second counts. Every minute counts. Minute name, every second counts. Every second counts. Every second is going to impact on your final result, where you are going to end up. That is going to change where you are going to end up in your life. That's the thing, right? The engineering and organic physical ගියාට පස්සේ එතනින් පස්සේ ඉතින් ඔක්කොම අර path එක it's totally different. Engineering කියලා කරපු දේ physical කියලා කරන්න බෑනේ. I'm not condemning physical. ඒක හොඳයි. හොඳයි. හැබැයි ඔයාලට potential එකක් තියාගෙන engineering යන්න physical එකට ගිහින් වැඩක් නැහැ. ඒතර එතනින් පස්සේ ඔයාලට දිගටම ආයි මරණකම් ඉතින් physical එකට අදාළ job එකක් කරන්න වෙන්නේ. ආයි engineering degree එකක් කරන්න බෑ. That's the thing. PhD එකක් කරන්න පුළුවන්. From that side, if you are doing higher physics, higher chemistry or something like that, ඒ sides වල යන්න පුළුවන්. Since you are more like to be with physics, higher physics වගේ කරනවා නම් එහෙම ගිහිල්ලා යන්න පුළුවන්. Field එක වෙනස්. IT වලට යන්න ඕන නම් ඉතින් IT වලට යන්න ඕන කෙනෙක් physical ගියොත් totally different. Something like that. IT යන්න ඕන කට්ටිය ඉන්නවනේ. Right? You are doing chemistry or ICT? Chemistry or ICT? Chemistry. හරි ICT ගැන දාවෝද? විහංග දන්නවා. අදීශ දන්නවා. මෙන්න. හරි ICT වගේ කරන කෙනෙක් මේ ඉදන්නකෝ ICT related එකකට යන්න බැරුව වෙන open degree එකකට වගේ යනවා කියලා. යන්න පුළුවන් තව open degrees කීපයක් තියෙනවා. path එක totally different. UOM AI වගේ යන්න ඉඳලා University of Monaco AI වගේ යන්න ඉඳලා වෙන එකකට යන්න එහෙම වුණොත් ඒක මාර අපරාධයක්. right? දැන් AI එහෙම මේ දවස්වල මාර demand එක. තාම second batches දෙකයි ඇතුලේ ඉන්නේ. Only 2 batches are in. No one has passed out. right? ඉන්න senior batch එකත් second year එකේ තාම ඉන්නේ. right? Okay, we'll wind up. The point is, don't waste even a minute of time, even a second of time these days, and utilize it, right? Okay then, all good no? Right, then කටියකම ඇවිල්ලා තියෙනවා කොහොමද යන්නේ? ඔයගොල්ලෝ? ඇවිල්ලාද? boys කොහොමද යන්නේ? ඇවිල්ලාද? Alright, බලමු. Right, go safe and stay safe. And we have the theory class and paper class tomorrow. Right? See you there. Good night, නෙමෙයි නේද? Good morning. Right. Right. See you again. Good morning. Right, goodbye. See you in the next class tomorrow.